stand in regard. Thank you. A very good morning to our chief guest of the day, Dr. Naranjan S. Dhala, esteemed Vice Chancellor, Punjab University, Dr. Renu Vig, Dean University Instructions, Punjab University, Professor Yojna Rawat, Dr. Babul Kumar Bezburua, President, Indian Pharmacological Society, Dr. B. Kalakumar, General Secretary, IPS, advisors to IPS, Professor Diwan and Dr. Shiv Prakash, and our worthy chairperson and organizing secretary of the conference, Dr. Anil Kumar. Distinguished executive members of IPS, dear delegates from across the globe, valued faculty members and young scholars. It is with immense pride and honor that we welcome you all to the inaugural ceremony of the International Pharmacology Conference, IPC 2025, the 55th Annual National Conference of the Indian Pharmacological Society, IPSCON. This gathering, under the profound theme of empowering young minds to transform pharmacology for Viksit Bharat, represents a convergence of global expertise dedicated to advancing therapeutic science and clinical translation to the betterment of society. To formally begin the inaugural ceremony on a blessed note of knowledge and wisdom, let us now invoke the blessings of Goddess Saraswati by the ceremonial kindling of the lamp. May I request our dignitaries on the dais to perform the sacred ritual. Seats on the dais. Let us now stand for the Punjab University anthem, and I would request everyone to kindly rise for the same.
Soma सही गलत की समझ बढ़ाता तेरी जय गो शंख बजाए रोशन तारे बन जाए फखरी तेरी शोहरत सदा सदा रहे
Thank you. I request all of you to be seated. We are deeply honored by the presence of an exceptionally distinguished assembly of scientists on the dais today. Their leadership and vision are the bedrock of scientific progress in our nation and all over the globe. Now is the time to welcome our guests with a planter as a token of gratitude. I request Dr. Vandita to guide the same. We offer these plants as a traditional gesture of warm welcome and prosperity, wishing for a productive session. May their resilience inspire a productive session where every conversation takes root, guaranteeing strong positive outcome for all involved in this conference. It is my pleasure now to invite our dynamic leader, the driving force behind this entire event, the organizing secretary of IPSCON 2025, Dr. Anil Kumar, chairperson UIPS, to deliver the formal welcome address and provide an overview for the coming scientific discourse. Sir, please.
Thank you, Dr. Prerna. Very good morning to all of you. So hall is full, 8:30. Great. So it's very good morning to all of you. And I'm happy to see all young crowd here. It's my great honor to welcome you all to the inaugural session of 55th Annual Conference of Indian Pharmacological Society, hosted by our department UIPS, Punjab University, Chandigarh. As an organizing secretary of this conference, it is my utmost privilege to extend a respectful, heartfelt welcome to our distinguished dignitaries gracing this occasion. Our chief guest of today is Dr. Niranjan S. Dhalla, distinguished professor from Center of Advancement of Medicine, Canada. Driving force behind this institution, our most esteemed Vice Chancellor, Punjab University, Chandigarh, Professor Renu Vig ji, Dean University Instruction, Yojana Rawat ji, their constant encouragement and fostering an environment that truly nurturing the scientific inquiry. Your support adds immense value to the IPSCON 2025. The leadership of Indian Pharmacological Society, Dr. Babul K. Bezbura, President, Indian Pharmacological Society, Professor Kawaljeet Chopra, organizing chair of this society, organizing chair of the IPS, and our esteemed advisor, Dr. Shiv Prakash and Dr. P.V. Diwan. I also convey my sincere greetings to all the resource persons, academicians, scientists, delegates, research scholars, students joining from across the country. Your presence enrich the academic depth and collaborative spirit that define the Indian Pharmacological Society. I'm also delighted to thank my all sponsor exhibitors and in particularly the Bureau of Health Education Status Upliftment, Ministry of Ayush, CCR, RUM, CSIR, DRDO, ANRF, DBT, DST, RUSA, along with the different corporations like Himalaya, Mankind, Panisha Biotech, Medi Analytical, Adivity, Acrolabs, Hetero, High Tech, and many more names are there in this list across the globe for their kind, generous support. I, on behalf of organizing secretary and committee, I feel delighted to report that pre-conference workshop centered on the theme Emerging Tech Tools and Technology, Alternatives to the Animal Testing in Silico Experiment and Experimental Pharmacology and Networking Pharmacology were successfully initiated on November 18, 2025. The two-day workshop provided a comprehensive scientific orientation towards non-animal, human-relevant technological advancement experimental system. It served an inspiring prelude to a dynamic scientific conversation that awaits us the main conference. This year conference is dedicated to the central theme, empowering young minds to transform pharmacology for Viksit Bharat. Together with the foundational theme from the workshop, these topics reflect aspirational and looking forward scientific agenda that emphasizes ethical innovation, technological advancement, capacity building, and renewed commitment to the shaping India's pharmacological progress by 2047. The vision strongly aligns with the national goal of Viksit Bharat 2047. It is important to recognize that the extraordinary scale and diversity of participation in IPSCON 205. This year, the conference proudly hosts 143 national speakers, 23 international speakers, experts across the various fields, including 23 medical doctors, 68 pharmacy and life sciences academicians, 90 industry experts, 11 represented from drug regulatory bodies, 14 from industry partners. They are participating in this conference. Our global footprint is also inspiring about 1,200 registered participants representing 10 countries, including 262 from India, 12 from USA, 4 from Canada, France, Malaysia, Hungary, Japan, UAE, Poland, Russia, England, and Sri Lanka, and many more countries are there in the list. I'm not reading all, but this indicates that this is a global meet is there now. Upon conclusion of this distinguished inaugural ceremony, the intensive 3-day scientific program will commence. Our meticulously crafted program not only encompasses a series of esteemed orations, 25 specialized symposia, invited lectures, oral poster sessions, panel discussion, women forum, which is being done first time in the IPS to meet the interactive sessions with eminent pharmacologists there during lunchtime, and spirited IPSCON quiz is there, but also feature many more on the conferment of multiple prestigious awards throughout the 3 days sessions to recognize and honor the outstanding contribution of our participants. The themes span critical areas including translation pharmacology, molecular to clinical innovations, emerging metabolic and cardiovascular therapeutics, biological, biosimilars, herbal, nutraceutical sciences, regulatory frameworks, pharmacoeconomics, AI-enabled drug discovery, integrative networking pharmacologies are some of the theme area which are going to deliver in this 2 days program now. As we formally inaugurate 55th annual conference, I encourage each participant to immerse themselves to the scientific sessions, interact with the expert, embrace new methodological perspective, build network that profoundly influence your future contribution to the pharmacological landscape. I conclude by extending our utmost sincere welcome to all of you to this IPSCON 2025. May the ensuing days prove to be profoundly enriching and scientifically catalytic. Thank you very much.
Thank you, sir, for briefing us all about the scope and objectives of this conference. It's an honor now to call upon Dr. B. Kalakumar, General Secretary, Indian Pharmacological Society, to deliver his address.
Vice Chancellor of the prestigious Punjab University, Professor Renu Vigji, Dean of Instruction, Professor Yojana Rawat, Professor N.S. Dalla, our doyen in pharmacology, Dr. N. Zahir Ahmad, Director CCRUM, the President of the Indian Pharmacological Society, Professor Bes Baruwa, the past Presidents of IPS, Dr. Shiv Prakash, Dr. P.V. Diwan, and the Organizing Secretary Anil Kumar. Host of luminaries of the dais, greetings from IPS. And IPS, as you all know, is the largest scientific body in India, and it has its accreditation from International Union of Pharmacology. Our mandate, the society's mandate, is to propagate the knowledge of pharmacology, to encourage youngsters, to encourage those who have the passion for pharmacology, those who have done excellently in pharmacology. We honor them either through awards, orations, or prizes. So in one word, it is one for everyone. If you are a youngster, you would be eligible for prizes in oral presentation or poster presentation. And if you are middle-aged, then you would be eligible for orations. And if you are in old age, you will be eligible for Lifetime Achievement Award. So we preach pharmacology. Our gospel is pharmacology. And this pharmacology is an ever-changing subject, as its two arms spell out, pharmacodynamics and pharmacokinetics. So we keep moving on. And now we have AI that has entered into our classrooms and also into our experimental design, that is into research, and even in writing of articles, writing of research articles. So we plan to have symposia, conference, and seminar in this particular upcoming area. Not only that, we have our industry representative, Dr. S.D. Sinha. He is contributing a lot. So we thought that our MD pharmacology students and also MPharm or MVSC pharmacology students, they should be made industry competent. With that idea, we are coming out with good number of seminars and also training programs to make them industry competent. Pharmacology is an interesting subject, not because I have done my PhD in that subject, but it's a life-saving subject. It's the backbone of medicine. So I request all the youngsters who have done their pharmacology to join IPS and make it stronger, because the future is yours. Professor Renu Vigji, Honorable Vice Chancellor Madam, You stood by us in thick and thin of times. When there was a crisis, you were there with us. You gave a patient hearing, and I really thank you for that. Added, in spite of your illness, you have made sure to be here with us, and I really thank you on my personal behalf and also on behalf of the society. I think with these few words, I close. Thank you, one and all.
Thank you, sir. We are privileged to welcome Dr. Babul Kumar Besbura, President of Indian Pharmacological Society, to deliver his address and elaborate on the Society's vision in alignment with the National Development Agenda.
Very good morning. Nice gathering here. Honorable Vice Chancellor of Punjab University, Renu Vigzi, Yona Rawat Ma'am, Dean University Instruction, my left hand Dr. Kalakumar, our excellent advisors, Shiv Prakash and PV Diwan, and most respectful person present here is N.S. Dhalla sir, and last but not the least, the most dynamic Dr. Anil Kumar. Please give a big hand to him. Now see, in the month of July, we met VC Madam along with our team, and accordingly we made a plan here. So first of all, I especially thank on behalf of IPS to the Punjab University family, basically the UIPS family, for allowing us to hold this conference here. Now, as the theme of this year's conference is empowering young minds to transform pharmacology for Vikshit Bharat. So what should be the role of IPS to attain the goal? To some extent, I want to elaborate about the role of IPS in this regard. So IPS plays a crucial role in achieving the goal of Vikshit Bharat by promoting pharmaceutical research, education, and the rational use of medicines, thereby contributing to nation's health security and robust, self-reliant pharmaceutical industry. So what are the key roles of IPS in the vision? First one is to foster research and innovation. IPS promotes research in pharmacology and allied discipline with particular reference to the country's current health needs and national health policy. This also includes the studies on indigenous drugs, which aligns with the national goal of leveraging traditional knowledge and developing new relevant therapies. Second one is we have to enhance the human resources. The society contributes to capacity building by organizing conferences, workshops, and educational programs such as GCP, neuroscience, and pharmacogenomics. So these initiatives develop the skills of young researchers and professionals, creating a strong talent pool for academia, research institution, and the industry, a crucial enabler for Vikshit Bharat. Next one is promoting rational use of medicine. Its course objective is to collect, evaluate, and disseminate scientific knowledge about drugs for the benefit of the country, which encourages the rational use of pharmaceuticals. This is essential for better healthcare outcomes, combating issues like antimicrobial resistance, and ensuring patient safety. Next is the advising on health policy. Members of the IPS serve on advisory boards of various national and international bodies, including the ICMR, WHO, providing expert input on health-related matters and helping shape national health policies and drug standards. Next is how to strengthen the pharma ecosystem. By working to advance pharmacology in the country, the IPS indirectly supports the national pharmaceutical industry's goals for achieving self-reliance in drug production. Then enhancing the manufacturing capabilities and moving from a volume-based market to a value-based, innovation-driven pharma powerhouse. Last one is we'll have to ensure the quality and safety. Through collaborations with bodies like the Indian Pharmacopoeia Commission, the IPS helps promote medicine safety surveillance mechanisms and adherence to quality standards, ensuring that the Indian population has access to safe and effective drugs. In essence, the IPS helps build the scientific foundation and skilled expertise necessary to address India's health challenges, support a vibrant and innovative domestic pharmaceutical industry, and ultimately will contribute to a healthier and more prosperous and self-reliant developed nation by 2047. So thank you all and hope this conference will be a grand success.
Thank you, sir, for your kind words and sharing strategic vision for the society. The continuous success of the University Institute of Pharmaceutical Sciences is intrinsically linked to exemplary stewardship of our Honorable Vice Chancellor, Professor Renu Vig, the first Lady Vice Chancellor in the history of Punjab University. We are profoundly grateful to our esteemed VC ma'am, who despite having a heavy throat infection, has made it to this inaugural ceremony. Ma'am, your gracious presence is precious to us. With your kind permission, may I now request our respected DOI Professor Yojna Rawat to read Vice Chancellor's presidential address.
Good morning, everybody. I myself, and on the behalf of Professor Renu Vig, Honorable Vice Chancellor of Punjab University, I welcome you all to this 55th Annual Conference of Indian Pharmacological Society, IPSCON 2025, hosted by Punjab University Institute of Pharmaceutical Sciences, known as UIPS Punjab University, which has been recently ranked 3 in NIRF ranking. Punjab University is one of the oldest and most respected institutions of higher learning in India, which was established in 1882 in Lahore as a University of Punjab. The University Institute of Pharmaceutical Sciences, a stalwart of the university, has built an enduring legacy of excellence in pharmaceutical education and in research. Over the past 80 years, beginning in Lahore in 1944 and finally settled in Chandigarh, UIPS has remained steadfast in its commitment to serving society by upholding global quality standards, ethical values, and a culture of innovation. The Institute has consistently produced highly skilled human resources, cutting-edge research outputs, and professional services that contribute meaningfully to the healthcare and pharmaceutical sector. IPSCON 2025 is a testament to this legacy, bringing together over 1,000 delegates, including eminent national and international experts, this conference is a celebration of knowledge, innovation, and collaboration. It offers a unique platform for exchanging ideas, exploring emerging trends, and showcasing research that can transfer pharmacology in a Viksit Bharat. I congratulate the organizer, Professor Anil Kumar, entire faculty of UIPS, students and research scholars for their tireless efforts in curating a program of such breadth and quality. As we have heard recently, that 200 scholars and nearly 700 participants and delegates are attending this conference. I also extend my best wishes to all participants whose contribution will undoubtedly enrich the conference and inspire the next generation of the pharmacologists. Once again, I welcome you all to Punjab University and to IPSCON 2025. May this gathering be intellectually stimulating, scientifically rewarding, and memorable milestone in your professional journeys. Thank you all. Thank you very much.
Thank you, ma'am, for your insightful remarks and for the university's unwavering patronage of this conference. We have reached the moment we have all keenly awaited. We are privileged to have with us today an internationally recognized pioneer, prolific author, and a distinguished professor. Sir has spent over 5 decades advancing the molecular understanding of cardiovascular diseases. It's an immense pleasure to invite our chief guest, Dr. Naranjan S. Dhalla from the Center for the Advancement of Medicine, Canada, to deliver the inaugural address and formally launch the International Summit.
President of the Pharmacology Society, Professor Basbora, Professor Shivkumar, Professor Devan, Professor Mahatma Ramesh Goyal, and ladies and gentlemen, I am truly honored to be invited by very nice people, Anil Kumar and Yadav, my very close friend. It's very nice to come to such a beautiful gathering and to be with very young people who are really the future of not only India pharmacology, but I consider the world pharmacology. It's a very interesting for me to observe at this stage of my life that to come among friends, it gives a feeling which cannot be described in words. You know, Pharmacology Society has been so kind to me up till now, at such an age. You know, I'm quite an old man now. And but Pharmacology Society, in spite of the fact I left India in 61, and opted to live in Canada, I have always missed Canada very, very much, India very much, very, very much. So much that as somebody wrote, आया हवा का हर एक झोंका, आया हवा का हर एक झोंका, तेरा पैगाम लेकर, इतनी मोहब्बत मुझसे न कर तू, मर जाऊं तेरा नाम लेकर. Although I chose to serve the rest of the cardiovascular community all over the world, I had the opportunity of developing and founding two major organizations in the world with one with 5,000 members, other with 3,500 members, 3,500 members, and but I always was very, very close to India. It's the Indian people. It's the Indian people who made me, who gave me so much love. It's unbelievable love. Who made me build relationships which were very, very beautiful, very sustainable. Madam Vice Chancellor, I tell you that I had a very special regard for your university, because I think this university, there were two major people, Professor Puri and Professor Sobti, both Vice Chancellor of this university, have been my very close friend and came to Canada one or two times to visit us, our small institution. And I think also this city, you know, when you invited me here last year, and this city has a special connotation for me. The directors of the All India Institute of Medical Sciences, like Professor Wahi, Professor Sharma, Professor Talwar, became my very close friend. In fact, they in fact spent some time with me in a very cold city, Winnipeg in Canada. And that was a very nice start for them to come over here. So I built a tremendous relationships. And that helped me being alive at this stage. I'm at a situation where neither the university leave me, nor my friends all over the world leave me. I tell you, if you want to do something absolutely great, try to build relationships. If you want to progress in your profession, have good friends. It is the friends which make you. It is friends which make you achieve things, what you achieve. So I think all the young people, when I say that you are the future of India pharmacology and the international pharmacology, I can tell you with certainty that if you want to achieve something in your career, have good friends. They will help you, they will make you, or also they could at times, they could break you, but don't get afraid if somebody is talking bad about you. No, I consider that you should think it's not bad. He's trying to make you improve your own style and relationships. The criticism is always good. Criticism is not that bad. So don't get disheartened by criticism. Use them nicely and try to develop them. In my case, I had too many people. I think an Indian person coming into the United States and having a right away very nice position, and then wanted in Canada to develop an institute. It was not easy. I had a lot of opposition, a lot of friends. People never wanted me to progress, particularly when I I decided to serve people rather than, and if anybody opposed me, I just bypassed them rather than struggling with them. I think do not waste time in struggling with people. Always try to find ways to avoid the confrontation, because that's use your intellect and use your intelligence. If man like me, who's a man of less than average intelligence, can do this type of things, and I consider you could do much better than I could do. Thank you very much, and best luck to you.
Thank you, sir, for your motivational address and formally inaugurating IPSCON 2025. Your words will serve as a guiding compass for all the delegates. Now I invite Dr. Vandita to take forward the proceedings of the conference.
Thank you so much, Dr. Prerna, for entrusting me with this responsibility. Dear all, as we capture the essence of this momentous occasion, we now proceed to a very special segment celebrating intellectual legacy and professional excellence, the release of the conference souvenir and the abstract booklet. I request all the dignitaries on the dais to kindly participate in the ceremonial release of the conference souvenir and the abstract booklet. I request Dr. Prerna to please help all the dignitaries for the release of the souvenir. Further, the conference also marks a significant academic milestone, the official release of the 8th edition of Fundamentals of Experimental Pharmacology. We have the authors of the book over here, Dr. Anurabha Ray and Dr. Kavita Gulhati. Though Dr. Anurabha Ray couldn't make up, So this conference also marks a significant academic milestone because we're going to release the 8th edition of Fundamentals of Experimental Pharmacology. I congratulate the authors of the book, Dr. Anurabha Ray and Dr. Kavita Gulhati, for the release of this book. Though Dr. Anurabha Ray couldn't make up for this conference, we congratulate both the authors. I also request Dr. Sandeep Ghosh, nephew of Dr. M.N. Ghosh, the original author of Fundamentals of Experimental Pharmacology, to please join in. Thank you so much, all. As we conclude the release of the souvenir, which beautifully captures the spirit and achievements of IPSCON 2025, we now transition to a moment of recognition and celebration. It is time to honor the outstanding contribution of our eminent experts through our award ceremony, acknowledging the brilliance, innovation, and dedication in the field of pharmacology. For this, we have the first award in the category, that is the Lifetime Achievement Award. For the Lifetime Achievement Award, the award goes to our own Professor S.K. Kulkarni, sir. To honor the remarkable contributions of Professor S.K. Kulkarni in the field of neuroscience, the IPS Core Committee is presenting a Lifetime Achievement Award to Professor S.K. Kulkarni. This award is a proof to 4 decades of dedicated teaching, research, and excellent mentorship in neuropsychopharmacology. Professor Kulkarni's dedication and perseverance are truly inspiring. Congratulations on this well-deserved achievement. A huge round of applause for Sir. We are indeed so blessed with your presence here, Sir. Thank you so much, all. We now move to the second category of award ceremony. To honor those who have devoted their career for advancing our discipline, the IPS Fellows 2025. So the IPS Fellows 2025, we have 3 IPS Fellow who have been selected by the core committee. Professor Nirmal Singh, Professor and former head in Pharmacology Division, Department of Pharmaceutical Sciences and Drug Research at Punjabi University, Patiala. I request all the dignitaries on the dais to kindly honor the awardee. Next, we have Professor H.N. Yadav. Professor Harlokesh Narayan Yadav is an associate professor in the Department of Pharmacology at AIIMS, New Delhi. Congratulations, sir. The third in the category is Professor Saeed Ziaur Rahman, who is the chairperson of Department of Pharmacology at JN Medical College, Aligarh Muslim University. Sir couldn't make at this very time, so maybe we are going to award him after the plenary session. Thank you so much and congratulate all the awardees. The dignitaries need to remain still on the dais, please. The next category of award is the Pharma Ratna Award. The Pharma Ratna Award, which is organized by the Rabdi Meher NGO, is a prestigious global honor established to recognize and celebrate stakeholders across the entire pharmaceutical industry for the impactful contributions in the field. Serving as a crucial platform, the award aims to bridge the gap and foster vital collaboration between diverse segments of the pharma world. This year, we have again 3 awardees for the same: Professor Y.K. Gupta, Professor P.L. Sharma, and late Professor Manjeet Singh sir. Dr. Y.K. Gupta couldn't make up. He will be joining after lunch. I invite Professor P.L. Sharma sir to please come on the dais. You want to speak something?
Yeah. I think you have seen the living legend of pharmacology, towering personality, Dr. Professor P.L. Sharma, who is born in 1933, and today you have opportunity to see him, 93-year-old man, an excellent pharmacologist and a role model for pharmacologists. And I have the honor today to deliver the oration on his name because I have been his student for a PhD at PGI Chandigarh. Dr. Sharma is the first man to be recognized by the University of London for his project, and independently he has worked there, and the comments done by and he has many firsts to his credit. Number one is he has started DM clinical pharmacology at PGI. He has started PhD in pharmaceutical science throughout the world. He is the first man to start. There are so many things, and let us give very big appreciation to our great personality, Dr. Professor Sharma. Thank you, madam.
Thank you, sir.
It's my pleasure to introduce about late Professor Manjeet Singh sir. We have two professors, and both are from the Punjab. One started the first, you see, the clinical research in clinical pharmacology in India, and no doubt you can consider as you can say, father of clinical pharmacology of India, Professor P.L. Sharma. And man who is student of the P.L. Sharma is the late Professor Manjeet Singh. He was our teacher. He started. My dear friends, at that time, it was the time of just doing the evaluating the extract of the phytopharmaceuticals. And he is the man, Professor Manjeet Singh, late Professor Manjeet Singh, who started molecular pharmacology in India at the level of the international level. I would like to call Madam late Professor Manjeet Singh, please come, and his son, Dr. Amitoj Vaidwan, he is the cardiologist, to come and receive this honor by the Pharma Federation.
For young students of UIPS, you should be proud that Professor Manjeet Singh was also a teacher in our department.
Congratulations to all the awardees. Thank you so much, all. Moving forward, this time we have another award category, the Distinguished Industry Partner Award. And the award goes to Dr. Shubhadeep Sinha, who is the Senior Vice President and Medical Director, Hetero Group of Pharmaceutical Companies. May I invite Sir on stage, please? Sir, please. Congratulations, ma'am.
Sir, I'm here.
Somebody had to come. I have lost depth. Concept of depth, I have no.
Thank you so much, all. Congratulations to all the awardees once again. I congratulate all the awardees once again. We can have a huge round of applause for all of them. Your achievements are a beacon for the next generation of pharmacologists to come. Now is the time to honor our esteemed dignitaries on the dais as a token of our sincere gratitude for sharing their valuable time and knowledge with us today. Starting with our chief guest of the day, Dr. Niranjan Dhalla, sir, I request our Vice Chancellor, ma'am, to kindly felicitate our chief guest of the day. Okay, sir. Next, we move to felicitate our Honorable Vice Chancellor, ma'am, Professor Renu Vig, ma'am. I request the dignitaries on the dais to kindly honor ma'am with a token of love. I request all the dignitaries on the dais to kindly felicitate our DUI ma'am, Professor Yojna Rawat. May I request all the dignitaries to kindly felicitate the President of IPS, Dr. Babul K. Bezbaruha. The time to honor the General Secretary IPS, Professor B. Kalakumar. I request all to felicitate the advisors of the IPS, Professor Shiv Prakash Sir and Professor Divan. I request all to felicitate our chairperson and the organizing secretary of IPSCON 2025, Professor Anil Kumar Sir. Congratulations once again, sir, and to the complete organizing team for IPSCON 2025. Thank you, everyone. I request all of you to rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you so much. You can all please take your seats. We'll break for 2 minutes before we are going to start with the plenary session. Thank you all. I request you all to be seated, please.
Dear all, please be seated. We are starting with our plenary talk. We'll break for tea after this session.
No problem. It's okay. Let's call chairperson. Call chairperson.
Ladies and gentlemen, we now transition to the scientific cornerstone of IPSCON 2025 as we commence our first plenary talk, a session dedicated to presenting foundational and cutting-edge pharmacological research. This plenary talk is a hallmark event and we are honored to
May I request all standing in the hall to kindly settle down. We need to start with the next session.
Hello sir, how are you? मैं यहाँ बैठा हूँ। हाँ हाँ, मैं तो ऊपर से देख के आया हूँ मैं।
Apologies for the delay. We are now beginning with our first plenary talk. I have the distinct honor of inviting our distinguished session chair, Professor S.K. Kulkarni. Professor S.K. Kulkarni is a renowned pharmacologist and distinguished academician, best known for his pioneering work in neuroreceptor and behavioral pharmacology. He is one of India's most cited pharmacologists. A fellow of the National Academy of Medical Science and a recipient of prestigious honor, his exceptional contributions have profoundly shaped pharmaceutical research and education. Now, I request Professor R.C. Sobti to please come on the stage and chair the session. Sir, please. Now I request our distinguished chair to preside over the proceedings of this plenary talk and to offer your expert introduction of our esteemed plenary speaker, Dr. Naranjan S. Dalla, distinguished professor at the Center for the Advancement of Medicine, Canada.
Good morning to all of you. We are about to start the first session. We have a very distinguished speaker whom we have seen in the morning, so I will not take much time in introducing honored Dr. N.S. Dalla of Canada. Three things I wanted to tell about him. He is Punjab ka putra. He was born near Batala in 1936, and he is also an alumnus of Punjab University. He got his first degree, BSc in chemistry from Punjab University, and most recently in 2009, that then Vice Chancellor is sitting there, Dr. Sobti. He was given honorary doctorate degree by Punjab University. Here is Dr. N.S. Dalla. वहाँ से बोलेंगे यहाँ से बोलेंगे आ जाइए. Give him a big hand.
कैसे करना?
नेक्स्ट यहाँ से भी कर सकते हैं और ये जो प्रेस है बड़े वाला ये नेक्स्ट है और ये बैक है.
हाँ? ये फॉरवर्ड?
हाँ जी फॉरवर्ड.
वेरी गुड.
ये पॉइंटर. ये बैक.
I hope I always mess up with it. Professor Kulkarni, Professor Sobti, ladies and gentlemen. I'm so honored to speak to you, and particularly under the chair of two most distinguished people of India, and I am very honored. I am very honored for this. I am going to tell you a story about something which I only told 3 times, in a very brief version of 3 times. I might have given more than 550 lectures all over the world, But only in last month, from Brazil to Prague and here, I have told something, something very interesting, but very unique ATPase, which we discovered. We discovered in 1970. In my laboratory, discovered people that that there in the cell membrane there is an ATPase which is activated by millimolar concentration of calcium or magnesium, and this is localized in sarcolemma, the cell membrane of the heart. And this was something which we never thought it will go anywhere, but it kept us going for so many years. And that story I'm going to tell you about the implication of a calcium magnesium apto-ATPase in the pathophysiology and pharmacology of ischemic heart disease. Although we implicated this enzyme in a number of other disease processes, but I will focus myself on ischemia reperfusion injury. You all know that when a person has a heart attack due to the narrowing of the coronary arteries by cholesterol or by thrombosis, blockage of the coronary then people undergo the angioplasty and during coronary bypass, they also do cardiac transplantation. So all these procedures are associated with ischemia reperfusion injury. You see, establishment of the coronary flow called reperfusion is essential for the myocardium to get into its proper shape. But if the reperfusion of the ischemic myocardium is carried out in a delayed situations, then it creates more problems. So it impairs the coronary, it impairs the cardiac function further. And that's a major problem with being faced by this thing. So this is ischemia reperfusion injury. Now, wide variety of mechanisms have been suggested for this problem, that why coronary flow can be improved, that how coronary flow can be improved, and the heart function can be recovered. But although there is also a tremendous amount of the experimental evidence in animals and all that, lot of things have been, drugs have been tried to do that, but up till now, there is no success. There is virtually no success in this regard. And so I think it's an important challenge for the young people to continue developing appropriate therapeutics so that this problem can be solved in future. So you are, as it stands now, people think that there are two major problems which lead to reduced recovery of cardiac function upon reperfusion of the ischemic myocardium. And these are oxidative stress and calcium overload. There are two major. There are some other minor components too, but these are the two major things. So, and most of the drugs which are used at this time are based on blocking the channels or blocking the receptors so that less calcium enters, so calcium overload should not occur. But just to show you, oh, which way? So just to show you that ischemia reperfusion injury is essentially a problem of oxidative stress. And this leads to activation of influx of calcium. Increased entry of calcium occurs and occurrence of calcium overload. This then creates problems like proteases and all sorts of calcium handling, subcellular abnormality take place, subcellular organelles go kaput, and high energy stores go depressed, and that's the reason there's a reduced recovery. So I have focused on today on calcium influx type of things, which I will discuss with you. Is a new role which I am proposing. But in the meantime, I want you to know that oxidative stress is an important aspect of ischemia reperfusion injury. You can see that when ischemic made ischemia for 30 minutes and 30 minutes of reperfusion, you can see that the left ventricle valve pressure is markedly reduced. This left ventricle and diastolic pressure is markedly increased, and the calcium content are increased. The parameters for oxidative stress, hydrogen content or MDA content, they are increased under this. But interestingly, this was that calcium ATPase, which is different ATPase from any other ATPase in the cell, or magnesium ATPase, same ATPase, they are also reduced. And when we carry out such a reperfusion injury type of thing upon the treatment of N-acetylcysteine, which is an antioxidant agent, there is a attenuation of all these changes occurring. So antioxidant are considered to be beneficial, but the problem is that in clinical setting, some antioxidants have been tried, particularly vitamin E have been tried. They have not produced significant results. And so I think people are really disappointed from the oxidative stress. And I think it's a challenge for a young pharmacologist to produce an appropriate and effective antioxidants so that this problem can be solved under this situation. But I have always believed that oxidative stress has a very transient effect, and there is something calcium overload which is much more important, and that should be addressed, and that's what I am going to discuss with you, the pathophysiological implication and pharmacological implication of this ATPase under this. This is again a challenge for development of new drugs, and I'm going to show you why. But before I get into pathophysiological implications, I like to describe to you some biochemical characteristics of this enzyme, its location, and its function. And I thought before I get into describing that how it's involved in ischemia reperfusion injury, I should tell you about this. As I said to you, in 1970, our laboratory discovered this enzyme calcium magnesium ATPase, which is activated by millimolar concentrations. And what happens that we also thought that we will, this is you can see that the ischemia reperfusion of the ischemic myocardium leads to very rapidly, within 5 minutes, some improvement is there. But it was only 30% improvement is there with respect to this thing. But here, the left ventricle and diastolic pressure, it is markedly increased from the ischemic myocardium, and some decrease in this also take place. And interestingly, you see, calcium overload is a concept which is a misunderstood concept. There was a German scientist who said that intracellular calcium overload is an important aspect. People have thinking that is the cytoplasmic concentration of calcium which is important, or is the total calcium which is important. I think it is the total calcium which plays a more significant role rather than the intracellular, because we did isolate the cardiocytes from the ischemic myocardium, and yes, the basal activity was basal calcium, which is a cytoplasmic concentration of free calcium. Yes, that was further increased under that situation. So here, why this is not working? So this ATPase is present in the sarcolemma, and we isolated a sarcolemmal preparation which contained the basement membrane and the plasma membrane. It had two components. So we isolated that aspect, and we showed that at that time, it was a different time, we showed that even cyclic AMP protein kinase, which is considered to be important aspect for anotropic action of catecholamines in this. Yes, even this enzyme activity was increased. Both calcium and magnesium ATPase was increased. Then I tell you this. You could do it for me. Yeah. So if you can do this for next slide. Next slide. So here, I always have this problem with these gadgets. I am always so scared that if I ever touch them, they are going to break. I don't know why. So that's why I never worked with my own hands in a whole from 78 onward. I never worked with my own hand. That's very sad, but that's what it is. I'm so scared of this. So there was a professor who visited us. He said he would like to find out if this enzyme is really important from a beat to beat. And he showed, very interestingly, he suspended the membranes in a cuvette and stimulated it electrically. And this we found that it was a voltage dependent as well as the impulse frequency dependence increase was there. So this enzyme has a very interesting concept. I won't go into the detail of these type of things, but next slide. This enzyme also, when we perfuse the heart with different concentration of calcium, there's a contractile force increases with different concentration of calcium. But we also found out that this calcium, when you expose the membrane to this calcium, both the calcium ATPase activity was increased and calcium binding was increased. And there was a very linear relationship under that situation. Next slide, please. Then we found out that the agent which are supposed to have effect of the calcium currents. They were the blockers of calcium current like nickel, cobalt, and manganese. They markedly inhibited this enzyme, this enzyme. And you can see that very interestingly. But some antiarrhythmic agents also inhibited this enzyme, but to a very lesser degree than these calcium current blocking agents. Next slide, please. This enzyme, the membrane, when we expose these membrane to oxy-radical generating system like xanthine plus xanthine oxidase, which generates superoxide radical or hydrogen peroxide, which is itself is a oxidizing agent. Initially there was a increase, and then there was a decrease in this. This was the experiment which was, and then in the OH radical production by hydrogen peroxide plus ferrous, when that was the membranes were exposed, it was decreased. It was opposite. So it had a both increase as well as decrease. It all depend upon what sort of radicals were being produced and what sort of radicals, how long they were, and what was their concentration. So both stimulatory and inhibitory effects were there with this enzyme. And this observation made me think that this enzyme may be involved in producing calcium overload. That initially there is all of a burst of calcium overload, and that then there is a depression. This may be the reason that they may be doing it. Next slide. Then we tried it in real calcium overload situation, which is seen as a calcium paradox. You know, I am honored that the president of the International Academy of Cardiovascular Sciences, Professor Varro, is with us. I think what an honor. I think you people should have a conversation with him after the lectures and all that. You will gain a lot. He is world's #1 electrophysiologist. And I just showed them that this enzyme was affected, the activation of this enzyme was affected by agents which reduce calcium currents, and now I am going to show that this calcium ATPase is also affected by calcium overload, directly by calcium overload. And the calcium overload was also in the form of a calcium paradox was suggested by some Danish people, and this was a very interesting observation because calcium overload was implicated by Dr. Fleckenstein for producing pathophysiological changes in the heart. And so I thought we will find out what sort of thing happened with calcium iron. When you briefly, it's very interesting, when you briefly expose heart with a calcium-free medium, and then you introduce reperfusion, there occurs a damage rather than recovery. And that calcium was because calcium overload occurs. And so here, when you low concentration of calcium, zero concentration calcium, both the contractile force does not occur, and then the ATPase was also reduced. And you know, depending upon the concentration, it was a little bit. So calcium paradox was inhibitory. Calcium overload was inhibitory to this ATPase. And you can see that duration of calcium-free perfusion, which was carried out if you carry out for 5 minutes, there is no force development. So I think it is with respect to time, different duration of calcium-free perfusion. This is contractile force decrease, and you can see that also that the calcium ATPase is depressed under that situation. And interestingly, next slide please. Interestingly, that there was a very nice relationship that the decrease in calcium, increase in calcium concentration lead to increase in resting tension in the heart and a depression in the ATPase activity. Depression in the ATPase activity, and also the agents which prevents interventions which prevent the occurrence of calcium paradox, like reduced temperature of the medium. They are low sodium were there. You can see that they not only prevented the contractile function, but they also prevented the depression in calcium ATPase activity. You can see that both these things were protective in nature. So there was no question in my mind that calcium paradox or calcium overload was involved in depression of calcium ATPase activity. Next slide, please. So, but calcium, you know, people have been thinking about that calcium overload occurs mainly through calcium channels or through sodium calcium exchanger system. So there was is a voltage sensitive calcium channel or store operated calcium channel. It's a very new thing has come up, and this sodium calcium exchanger produce an increased entry of calcium and development of calcium overload. We have proposed that this calcium ATPase is also involved. The activation of ATP is involved, because I have enormous maybe about 50 papers published on this, showing that this calcium ATPase is a gating mechanism, calcium gating mechanism. It let calcium, it is not anything to do with the channel. It is not a channel, not a transport ATPase, not a sodium hydrogen exchange or sodium calcium exchange mechanism, but it is a gating mechanism. And this gating mechanism, when the plug open, when it activated, it let calcium get in, and when it is shut off, it prevent calcium. The gates shut off, prevent calcium entry. So this was a very new mechanism which we have. So in fact, I was saving this, the next phase I'm going to show, I was saving that for doing a patent, but I think I'm too old to get a patent or anything. So I have started disclosing this information. So there are a number of mechanisms by which calcium gets in, and that's why most of the under most of the clinical trial in ischemia reperfusion have failed. That's why clinical trials have failed, because there are a number of mechanisms there, and one of them which we proposed is a calcium ATPase. So in order to show you that calcium, what are the characteristics of calcium ATPase further, next slide please. I thought we should isolate the plasma membrane. Plasma membrane, which is devoid of the basal membrane. Earlier I showed the sarcolemmal membrane, which had the basal membrane. This plasma membrane was even, very interestingly, was activated by concurrent con A. Con A activates this. You can see that both magnesium and calcium ATPase were increased in the presence of different concentration of ATP or calcium, or same as magnesium. So this was, we isolated the plasma membrane, which has shown that this enzyme may be a glycocalyx, enzyme, glyco, so it's a, so next slide please. So we wanted to find out if there is inhibitors, and we were very happy that there was a agent like germacidin S was inhibiting both the sarcolemmal membrane as well as the plasma membrane ATPase, both calcium and magnesium. It was inhibiting, and I thought we almost got a tool on our hand. But when we perfused the heart with germacidin, it was producing contracture. It was producing more contracture. And then we showed that why this contracture was, that was not due to changes in the calcium ATPase. That was, in addition to that, germacidin, as we found out, had a effect on sarcoplasmic reticulum. Had a effect on sarcoplasmic reticulum, calcium ATPase, it inhibits, and that's why cytoplasm concentration go up, and their contracture was taking place. That's what we showed by germacidin. So we failed in producing a proper thing. But then what if we can't find a proper inhibitor, what should we do? So I thought maybe best thing is to isolate this enzyme. And you can see, next slide please. We spent lot of time, manpower in trying to isolate this. It was most difficult enzyme to solubilize to begin with, and what to talk of purification. So this when we treated the sarcolemmal membrane, we found out it had two different enzymes. It had a calcium-dependent ATPase, which was not at all activated by magnesium, and this was also inhibited by sodium. So sodium was an inhibitor, but it had a 67 kilodalton molecular weight, and two molecular subunits were there in this. And this was, and the remaining, after trypsin treatment, after trypsin treatment, we found out that there was a calcium ATPase enzyme remaining there, and that was a 240 kilodalton, and it had 5 subunits, and very many things. This preparation was, this enzyme was then isolated from a trypsin treated sarcolemmal preparation. So we thought this is not a good idea. So we wanted to have something more definitive. So when we plasma membrane ATPase, we solubilized it by lysophosphatidylcholine and CHOP mixture and EDTA mixture. We were able to get that enzyme solubilized, and then we purified by sucrose density gradient things. It was unlike sodium. It was insensitive. It was a 2 unit. It had 180 K thing, and this was a 2 subunit of 19 K. 90 K was definitive. So here we had a pure isolated enzyme, calcium ATPase was obtained. Next slide, please. And so we thought we will only work with the purified form. And you can see the activity. Earlier the activity was showing per hour. Here I'm showing it per minute. You can see that calcium, magnesium, they were activating this enzyme very nicely. Next slide, please. This was the calcium, and it directly bound calcium. Directly bound calcium. And that was very interesting. Now you can see that calcium binding was there in this. Next slide. And also in ATP, different concentration of ATPs, you see it created a activation of this enzyme. And next slide. And it directly bound, this enzyme itself bound this ATP with this. So here is an enzyme. Next slide, please. Again, it was also retained the con A binding, so it also bound con A. So it was a glycoside carbohydrate associated information was residue were there with this enzyme. So this was very nicely done.
Sir,
so
time to conclude. Time to conclude.
Huh? Time is up.
Yeah, time ho gaya hai. Time to conclude.
All right, then I think I just next slide, please. So we localize this enzyme in sarcolemma by we produce anti-serum and antibodies. We also isolated. Next slide, please. So we found out that the ATPase activity was depressed both by different immune enzyme as well as the polyclonal antibody we made. It was depressed. Next slide, please. We found out, you can see that non-immune serum produced a very marked, had a, not a, the flow was, recovery of cardiac contraction was not enough, and this was, you can see that markedly increased. Next slide, please. So we also did that time course, different concentrations. You can see that there was different concentration. The immune serum was produced. Also antibodies produced the same sort of effect. Next slide, please. We also found out that it was a very rapidly effective in this situation. Next slide, please. We found out that the ATP was the only agent which it was blocking. So we did that ATP. You can see that immune serum ATP concentration was markedly blocked, and this was specific because the BK or KCL activated intracellular calcium did not change. Next slide, please. Same we found out with the antibodies under that situation. Next slide, please. So you can see that I have shown to you that calcium ATPase is inhibited by intracellular calcium overload. And I think this is what it is doing is that a burst of radical oxyradicals are formed and increase the activity, calcium gets in. And then it negative thing starts that it try to prevent intracellular occurrence of intracellular calcium. So I think due to his ability to inhibit this enzyme, this gating mechanism, they shut off this gating mechanism, and that's why there is a recovery is markedly improved under that situation. So in Prague meeting, somebody argued that it could be an ATP receptor involved, and I think it was not due to ATP, because it directly affects the enzyme itself. It directly affects the enzyme, it binds the calcium, it binds the ATP, and it has a direct effect on this gating mechanism. So here I have shown to you that it was possible to improve the intracellular recovery of cardiac flow due to ischemia reperfusion injury by the antibodies of this enzyme. And thank you very, very much.
Thank you very much, Professor Balla, for your valuable insight into cardiac function. There is time for one brief question if anybody has, you want an inquiry from Professor Dalla. Sir, what happens in sudden cardiac arrest?
you have to come near me and then tell me. What is the question? What is the question?
What happens in sudden cardiac arrest?
Not done that, but we found out that you see, sudden cardiac arrest is very interesting. That we proposed that sudden cardiac arrest, particularly death, is due to oxidation product of catecholamine. We did not test the effect of that yet, but it will be very nice to test this. I think sudden cardiac death is also arrhythmia problem. A massive amount of arrhythmia takes place and gets into fibrillation and all that. I think this enzyme could be, the antibody could be very helpful for that. In fact, there is a person in, he made some antibody. He is in California. He made some antibody and he could show that myocardial infarction damage was improved by that. So it's possible that maybe he was not talking of this enzyme, but he was.
Thank you very much. Please give him a grand applause to Professor Dhalla.
Thank you, Professor Dhalla, for that truly illuminating and high-impact plenary address. May I request our esteemed session chairs to kindly bestow upon our eminent speaker, Professor Dhalla, a token of our profound gratitude.
No, okay, no problem. No problem.
We wish to extend our deepest appreciation to our session chair, Dr. S.K. Kulkarni and Professor S.E. Sopti. Can I request President IPS, Dr. Babul, to please come on the stage and felicitate our chairpersons.
Please be here. So please remain.
अच्छा इसको ऑन कर दें, छोड़ दें, इसको ऑन कर दें, नहीं फुल स्केल करो. I think it call the chairperson for. करिए।
Now we're going to start with the Dr. P.L. Sharma oration. Dr. P.L. Sharma oration holds a special significance as it serves a powerful reminder of the intellectual foundations that support our professional journey. Dr. P.L. Sharma Oration is a distinguished academic honor established to celebrate the legacy of Dr. P.L. Sharma, an eminent pharmacologist known for his pivotal contributions to medical education and institutional development in India.
मेरा होने के बाद हो जाएगा, मैं 30 मिनट्स में खत्म करूँगा।
This annual oration honors accomplished scientists whose work has made a significant transformative impact on pharmacology, therapeutics, and biomedical innovation, providing a platform to inspire excellence and encourage scientific inquiry within the community. Chairing this commemorative oration are two individuals who exemplify academic excellence and mentorship. It is my pleasure to introduce the Honorable Chair for this session. We begin with the first one, Dr. B. Kalakumar, who currently serves as the Secretary General of Indian Pharmacological Society. A senior veterinary pharmacologist with nearly 3 decades of experience, he has authored over 75 research papers and a book on biomedical research. He has guided 5 PhD students and led more than 8 major government-funded projects. His current research focuses on nutraceutical, preclinical toxicology, and regenerative medicine. Dr. Kumar is also a recipient of the prestigious Telangana State Best Teacher Award 2020. I welcome you, sir. The second chair for the session, we have Dr. B.K. Roy, the former professor and chairperson of Department of Pharmacology and Toxicology at the College of Veterinary Science, Ranchi. He is widely recognized as the author of the textbook Veterinary Pharmacology and Toxicology, which is extensively used all over India. With over 100 research papers published in national and international journals and numerous successful supervisory role for MVSC and PhD candidates, Dr. Roy is highly respected academician who has various leadership roles. I welcome you, sir. Esteemed Chairperson, we seek your authoritative guidance to preside over and introduce the speaker for today oration, that is Dr. P.V. Devan, the Research Director, Central Research Laboratory, Belgaum. I request, sir, to please welcome Dr. P.V. Devan with a huge round of applause.
I will introduce about Dr. P. Devan, and he is an excellent scientist, was an excellent scientist also. Professor P.V. Devan, PhD, PGIMR, Chandigarh, is a distinguished pharmacologist and founder director, NIPER, Hyderabad. With over 300 publications, 17 patents, and mentorship of 36 PhD scholars, he has significantly contributed to pharmacology, toxicology, and drug safety research. A fellow of the Royal Society of Chemistry, London, and first Indian pharmacologist recognized as chartered scientist by the Royal Society. He has held key roles in FSSAI, IPC, and IICT, recipient of numerous awards, including the SS Mishra Memorial Gold Medal, and IPS Distinguished Pharmacologist Award 2023. He continues to lead as Research Director, Central Research Laboratory, Belgaum. Dr. P. Diwan, he is an excellent teacher also, orator also. Okay, you are welcome to deliver your lecture. Thank you.
Okay. Good morning to all of you, because I definitely expect a good reciprocation of good morning. Good morning to all of you. That will be the great spirit, because I am talking to a person who is a towering personality in pharmacology. That is my guru, Dr. P.L. Sharma. And what occasion I have today that I am presenting about my guru in the audience, where I would like to justify myself, as I have been his student and he has been my guru. And today, the title which I have put it is The Intellectual Who Shared Our Journey to Success, a heartfelt tribute to our guru, Dr. P.L. Sharma. When you start like this, I think always say, Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Parabrahma, Tasmai Sri Guru Namaha. With pranams, I would like to start, sir, Professor P.L. Sharma, with your blessings, I would like to talk about it. I have taken many of these things, the figures and everything, from Google God, so I acknowledge Google God to make it more interesting and enthusiastic. He has been a very good teacher, and he is not only a teacher, he is a researcher. And here, when the good teacher you are going to talk about, good teachers know how to bring other in the best for the students, and most of his students are doing excellently well. And many times we always feel that how we should get into a science. And he says the scientific research is one of the most exciting and rewarding occupation of a people. What a great honor to be a scientist. And as you can see here, he is the man, at the age of 93, he updates pharmacology. Why not we? What a great personality what you have. And this is just recently, March 2025, where you have seen he is the person who is on the dais updating himself for the science. And as far as the postgrad students are concerned, total number is 161, where he has guided PhD, then he has DM Clinical Pharmacology, MD, MSc, and M.Pharmacy. So don't you think that you can call him as a towering personality and a student-friendly teacher of PGI? And he always believed, number one is, success is a journey, is not a destination. Go on accumulating it so that wonderful things can come in your way. And he always says, academic success depends on the research and publication. If you combine both things, the outcome is going to be excellent. Now, what he has contributed for Indian Pharmacological Society? Number one, he has been a president in 1985, vice president, Lifetime Achievement Award, and fellow of the Indian Pharmacological Society, and he has hosted annual conference as well as many North Zone IPS conference, and he is awarded as recognized as a FMS from 1982. He is not only a teacher, he is not only a researcher, but he is a most individual who has helped most of the students, and I can give you many examples. His first student, Dr. Shankar Narayan, had a lot of difficulty because he was not getting his fellowship, and he is a man next day. He put him in some of the biophysics department, he helped him, and he's not the only one, and he has done many more things. Therefore, I call him as a person who is definitely going to help his students as an intellectual, and he is trying to help them in a much better way. Now, he never differentiated between the subject. Pharmacology is the same, whether it is a medical, veterinary, or a non-medical, but we have done it as a MSc, MD, or MVSc, which is not his criteria because all his students are from all these categories which I just now talked about. He is born in 1933, March 15, and his educational journey was fantastic, and all the time he has been a great researcher. He has done his MBBS from Government Medical College, Amritsar. Then he did his MD Pharmacology. He is the first MD Pharmacology student from All India Institute of Medical Sciences in 1960. You can just imagine from 1960 until today, he has been very, very active as a researcher. And apart from this, I would like to mention about this is he has done his PhD in a shortest time of 2 years, and he is a great inspiration for all of us. And he has done it where he has sent the project to the Queen Mary School at London, and that was accepted by ICI Research Fellowship, and he got the fellowship. And here I am honored to read the comment made by his professor. His Professor S.S. Stewart, who made a comment when he received the project from Dr. P.L. Sharma from India. What he says, I am very much impressed by his work, which is excellent in its planning, execution, and presentation. I feel the first ICI fellowship in London to a pharmacologist has been an unqualified success. I hope Dr. Sharma will publish many papers, and as long as he is staying in country, he is going to guide for experimentation for all the Britishers as well as for the Indians. As far as PhD thesis is concerned, as you have seen, his project was definitely taken a ride on the various things. And here, the mechanism of atrial flutter and fibrillation anesthetized dogs was submitted from India, worked independently in Mary's School of London, which is a unique character of Dr. P.L. Sharma. And he showed that the mechanism involved of aconite-induced ectopic focus is re-entrant than excitation and not induced automatically. He has already proved. What he has said is ultimately he has said the circus wave theory of electricity has been not automatic. It is mainly because of the electrically induced atrial flutter. What a great achievement he has done it. And all this work he has done in a shortest period of 2 years. And in the years of his all the career, he has published 250 papers. And apart from that, you can see 161 students who has guided from the various things. And today, we are very proud to say that he has really guided 56 students for a PhD. And I firmly believe, when I see all these things, I firmly believe that great minds do not just learn, they contribute. That is what Dr. Sharma has been doing for all of us. The academic contributions are the silent architect of tomorrow's achievement, tomorrow's innovations. That's how he feels about when he talks about the students. And he has completed in such a short time of 2 years. You can just imagine that too in London. And that is a great inspiration for all of us. And he has started his career as assignments, CMC Ludhiana, then All India Medical Sciences, New Delhi, then you have ICMR Fellow, then you have in the IFS College of Pharmacy, Moga, where he took care of my dear friend, late Manjit Singh, and at that moment, he was 80-year-old. You can just imagine the responsibility taking at 80 age is remarkable. And later, he has joined, he was already in Jami Hamdard, and later he has done some research work in Ranbaxy, which is really laudable. And here you can see, power of first, I think one should understand and learn from Professor Sharma. What he has done is, directly he was selected as a professor, starting from associate professor in PGI. See the assessment. He was not promoted as associate. Directly, because of his excellence in research and teaching, he was made as professor at PGI. And his major contributions, I told you in the morning, DM course in pharmacology, first in India, then PhD in pharmaceutical medicines, first in the world today, and organized North Zone conferences, plenty, and he was holding it, the clinical pharmacology, for the last 40 years. You can just imagine how committed and how dedicated Professor Sharma is. And the annual national conference was held in 2022, which is a mega event. And finally, new format for a PhD thesis examination was implemented in PGI. It is only because of him. And another thing also, because I had finished my PhD in 1.5 years, he made, to see that the PGI rules are changed and the minimum time for PGI was 3 years, and he made it 2 years, and I was the first man to get it as a PhD student of Dr. P.L. Sharma. And at that time, I still remember when he talked, when I went to the registrar office, he said, no, no, you have 1 more year to do. Then immediately Professor Sharma said, अरे यार मैंने तो कर दिया है, तुम क्या कर रहे हो? मेरे से भी बढ़िया काम कर दिया है लड़के ने, उसको PhD होना चाहिए, आप ले लो जल्दी. And you will not believe, Mr. Sharda was there. I still remember 1980. You can just imagine, almost 45 years back. What is the research contribution for PGI? Number one is, the Russian scientists have extended the work of Professor Sharma on anti-arrhythmic drug phenothiazine, and they have developed the ethimazone. Here they have done it, and later what has happened is effectively prevented the development of coronary cardiac arrhythmias, which was done by Russian. That means the clue was taken from Professor P.L. Sharma's work, and he has synthesized, developed, and patented a new beta blocker, which is known as PGI-12, and in a real good sense, you used to always say, without the knowledge of Professor P.L. Sharma, probably he will be knowing, we said, sir, you have invented an excellent beta blocker, why not make it as parallel? I think that is how we have done it. Probably today he will be knowing about it. And he is the man who has worked early on the optical isomers, where nobody has done it, on propranolol, nifenolol, and sotalol, and he has proved the effectiveness in the as an anti-arrhythmic drug. And he has worked on the rat uterus. Here I would like to impress upon you, he is the only man who has done animal studies as well as the human studies. You can just try to find out, because this is a very rare combination. Either you do clinical pharmacology or only do animal. And today the clinical pharmacology people, if they don't mind, I have to say, they have become aeroplane or air dashing scientists rather than doing the research. And here is the personality where he has worked in the lab, and I know I can show you some of the pictures later. Even at the age of 60, he was working in the lab by putting in the dogs and other things. And as you can see, what is his contribution? First and foremost, I would like to say the contribution, the research culture in PGI was just started by him, where here you can just see the human studies, then he has the animal studies, and he gave many importance, or most important, for clinical pharmacology. And these are the various things: clinical pharmacology, drug utilization, then we have pharmacovigilance, neuropharmacology and drug therapy, pharmacology and toxicology, then we have a cardiovascular pharmacology, then we have the traditional drugs, neuromuscular blocking agents, where I have done my studies, then we have the metabolic disorders, then arterial flutter, arterial fibrillation. You can just imagine what a type of activity he has done being a professor. Even at the age of professor, he used to work in the lab, and I had a chance to work in his lab. Anti-arrhythmic drugs, he is a class way of trying to do a research, and here he has done pharmacology of isomers of a beta blocker, where he identified what exactly is the difference, and he has done many of the in vitro experiments. And the inventor of beta blocker, I already talked about. He is a man who has been the great inventor, where Ramani Sharma was a student and always used to talk. He is a chemist, and ultimately he made it up to phase 1 trial. The efficacy was still there, but later I think it could not get into, but he is definitely an inventor of a beta blocker. Now, clinical pharmacology, what are things he has done for clinical pharmacology? He has demonstrated the neuromuscular blocking property of pancreonium. Parents during the who are undergoing orthopedic surgery, where he has shown the thumb contraction induced by the ulnar nerve. I think that is the first time he has been able to show that. The next one is he discovered the presence of active metabolite by studying the cardioselective beta blocker sponsored by May and Bayer of UK. The next one is established 26 beds in the Ranbaxy research ward, and that he utilized for a PhD as well as clinical pharmacology for many of students, and it was there, it was attached to Majita Hospital, New Delhi, 1994. And later what I am saying is, this is a collaborative work which has done with PGI. Number 1 is cardiovascular, endocrinology, anesthesiology, dermatology, general medicine, ophthalmology, orthopedic, pulmonary, clinical. Clinical and molecular pharmacology. As I said, molecular pharmacy is the first man to start, and here his student, Dr. Manjit Singh, we always remember him, the great personality in pharmacology, is the one who has started, and here Professor Sharma was guiding Dr. Manjit Singh for his PhD, and he was a professor, and from here the legacy has gone, and here you are able to see Harlokesh Yadav, who has been here today. He has been awarded the Fellow of Indian Pharmacological Society. What a great legacy. And here I would like to stress upon saying that unfortunately Dr. Manjit Singh died at the early age, and at the same time there was nobody to look after the students of Dr. Manjit Singh, and Harlokesh Yadav is the one fellow who was pestering Professor Sharma at the age of 80, and he obliged him. He came there and he guided all the students. What a great way of trying. It is not only a commitment, it is a dedication and helpful for the students. I think people will remember him throughout the life of every individual. Now, editorial experience, he was a member in the European Journal of Pharmacology, Indian Journal of Pharmacology, Journal of Pain, Drug Bulletin, and International Journal of Clinical Pharmacology and Toxicology. That means he's having a wide variety of experiences, and ultimately he proved not only as a researcher, as a teacher, but as a great administrator, and apart from that, he has been excellent leader. Now he is a founder of a national workshop in clinical pharmacology. Almost he was holding it for 40 years. Still it continues. And he is recognized as one of the pioneers in the clinical pharmacology of India. There are other UK states, other people are there. Along with them, he has been the pioneer as far as clinical pharmacology is concerned. And he is recognized as a stalwart of establishing clinical pharmacology in India. What a great achievement. What more you can require for a person like Dr. P.L. Sharma. The first pharmacologist as a council member of International Union of Pharmacology. Then he is a member of British Journal of Pharmacology, and he was the advisor for Indian Drugs and Pharmaceutical Limited, Hyderabad, where they were in doldrums. Then finally, he was a consultant for clinical as a clinical pharmacologist for the World Health Organization. And as you can see here, as a clinical pharmacologist, what he has done, he has taken a senior travel fellowship to go to UK as well as USA, Sweden, and Germany to see that many of the people will opt for clinical pharmacology, and Commonwealth fellowship to establish a clinical pharmacology department in London, Glasgow, Edinburgh, Dundee, and many more things. And you see the attainment what he has done as a clinical pharmacologist. I always feel he is the right clinical pharmacology man in India, and he is not an airport clinical pharmacologist, because many of the people will try to attend many of the conferences. I am not hurting the feeling, but they should get back to the lab and work like what professor does. Now my entry into PGI, and here is very interesting. I was all the time trying to find out who can be my guide. Ultimately, after 6 years, I found Dr. P.L. Sharma is the right man, where at 25 rupees at Jain Medical College, where I was only a lecturer, we were doing some work, and that work we had sent it for all India competition. At that time, we found that the National Academy of Medical Sciences has a competition, and where Dr. Chittani, director of PGI, was in the chair, and he said, yes, Prakash, you should get the prize. And I got the gold medal from Dr. S.S. Mishra Memorial Award, and at that time he asked me, is it your PhD work? I said, sir, I'm not that fortunate to have a PhD work. I've just, my master's have finished. Then immediately he talked about Dr. P.L. Sharma, and it was not only that, when Dr. Chittani went to PGI, he sent me the application. I got the application, I applied, but the minute I went to Professor Sharma, he has all the students, he said, no, whether director has told or somebody has told, I don't have space. I was there for 3 days, probably you will not believe. And he said, you go to Dr. Mathur, you go to Dr. Garag, you go so many things. But I said, I want to come with you only, otherwise what you all doing? He said, I'll go back. And that is how I entered. And main person is my own teacher, Dr. D.R. Kulkarni, who is no more today. And he is the man who pushed me for the PhD at Dr. P.S. Sharma place. And here, why I was more keen to work with Dr. Sharma, because when I looked into this, all the good qualities of a leader he has, and he is the one man, he is a quiet people, have the loudest minds, and that's how I found with Dr. P.S. Sharma. Then I said, I am with the right person, and that's how I continued my research. I took about 6 years, and this 6 years was really a troublesome for me because I was not getting the right. And when I got it, naturally, one day, Dr. Verma, he came from the anesthesiology department where he was doing neurosurgery by using sodium nitroprusside, and he found that when he is trying to give the D-tuberculin, instead of 30-35 minutes, this was going about 45 to 50 minutes. That means the activity was going almost for 45 to 50 minutes. Then he said, he came, and the next day, when he called me and he said, this is the problem, can you do the experiment? And I started doing the experiment at about 4 o'clock in the afternoon, and I finished early morning, 3 o'clock. Probably everybody will thinking, what Dr. Ivan is such a hard working fellow, but I had to work hardly after talking to Professor Sharma. See, the first experiment which I started at 4 p.m. in the afternoon and completed by 3 a.m. You can just imagine, I slept in the coffee club. Next day morning when I was going, incidentally I saw Professor Sharma. He asked me, what has happened? Sir, I have done an excellent experiment. He said, first go, get fresh and come back. When I came back, he did not fire. He said, if this is your attitude of trying to do an experiment, I think better you go back to Belgaum. What a great thing. And that opened my eyes. When I opened the eyes, then I said, sir, I will plan this. And this, you can just imagine, if you would not have told me like a mad fellow, I would have been working 24/7 to complete as early as possible.
Sir, sorry to stop your flow, but your time is only another
Yes,
2 minutes.
I'll try to finish.
Yeah,
And the
please.
3 minutes are there. Okay. And he is inspired particularly for completion of work, and I have finished in 2 years. And these are all the work which have been done when he was there. I was using polygraph, and you are able to get the result. And first paper we published in European Journal of Pharmacology. And here, sometimes when you are working in the lab, you always have to keep in the professor lab. So immediately he came forward and he said, okay, one person I'm going to give you, you can do it. And here you can see Professor Sharma at work, which I am already telling you, he is there. He has been working in the lab even at professor. And finally, you can see how much updating he is doing for his research work. And here he is a knowledgeable person and always keeps updating, and he has committed and is caring. And finally, he is a well-informed, there are no surprises. And finally, he has always the freedom for the students, and he always says that choose your research problems. If any difficulty, I will help you. And he has done that. And success, you know, this is how he has asked to see that we reach the success, but still it is a journey, it is not a destination. And here, mentoring is a class of himself. He has all the qualities of mentoring. And finally, the doctoral committee was certifying. I said, when the doctoral certify said, when I have to finish in 2 years, they did not allow me, but he is the man who took initiative, and he said, he has to be done, he changed the rules. And here, when you make a commitment, you create hope. When you keep the commitment, you create trust. And that's the reason the trust, the confidence which has made me, which is making me to stand in front of him today. And here you can see the family where has been honored. And here is a Dr. Manjit Singh. And here you can see he has been always there updating himself. And these are all the department. And here I had conducted almost for 1 month the webinar where he also participated. And today, with so much confidence, I will tell he is a star pharmacologist of the country. Let us give him a very big appreciation for all these things. And the best part is this is one oration where the main person is Dr. Harlokesh, who has collected the donation from all the students, and he has made it. This is the first of its kind in Indian Pharmacological Society. We should give him a really big hand.
So that was
Over
wonderful.
last, dedicated to my teacher and guide, late Professor D.R. Kulkarni, and credit of my success which has been read is the hard work of all my students who have been there. And I finally, Kalakumar, I'm thanking you also for giving me 2 minutes more.
Thank you, Dr. Diwan.
The selection committee.
Thank
because
you,
I was
Dr.
selected
Diwan.
to give Pale Sharma Oration.
Thank
and
you.
These are all the people who have helped me.
Thank
And
you.
I thank you. I thank Dr. Harlokesh. Once it comes, you know, it cannot stop. Thank you very much.
Thank you,
for
Dr.
listening.
Diwan, for delivering a nice lecture. And it was a good thing that Dr. Sharma is itself present here with his students, mainly Dr. Harlokesh Nayan Jadhav and all. Dr. Harlokesh Nayan Jadhav is also a student of Manjit Singh ji. So therefore, I appreciate Dr. Diwan for your nice lecture. Thank you.
Was it okay, madam?
Great, sir. Thank you so much.
We need to honor the speaker.
We really thank Dr. Diwan for such an informative talk and a very visionary address. Thank you so much, sir. May I request the chairpersons to kindly felicitate sir with a token of appreciation. Shruti, yeah, please come. Yeah. May I request Professor P.L. Sharma to please join on the stage for felicitating our guest. Sir, please can we have you here?
Thank you.
It's so tough for him to again, come over. But then, a huge round of applause for all of them. I request the dignitaries to felicitate our chairpersons for the session. Such a nostalgic movement. Yeah. So I think we can have him here because we PL oration ही शुरू कर रहे हैं. So we will have him here on stage. I request you, sir, to remain here on the stage. He's the chair? No, it is. Thank you so much to our speaker and to the chair for the session. Now we're going to proceed with the next scheduled oration, the prestigious Dr. G. Achari oration. Dr. G. Achari Oration is a prestigious academic honor instituted to commemorate Dr. G. Achari, a distinguished pharmacologist renowned for his significant contributions to medical education and research in India. The Dr. G. Achari Oration is an honor instituted to commemorate Dr. Achari, who is a distinguished pharmacologist. To guide this session, I have the distinct honor of inviting the session chair, Dr. Gautam Palit, and Dr. Y.K. Gupta. Dr. Y.K. Gupta couldn't make up for the conference. I would like to invite Dr. Gautam Palit over here.
लैपटॉप यहीं लगाते ना? हाँ
हाँ सर, अंदर देना
कहाँ से
लगा हुआ है।
चेंज कहाँ से करेंगे?
सर यहीं से करना आपको, आप बैठिए एक मिनट सर।
बोलना चाहिए था। अरे सब सरकार से यार।
मैं बोला था
To acknowledge their stature, I will take a brief moment to highlight the accomplishment of our chairperson. Dr. Gautam Palit, an eminent neuropharmacologist and academic leader, previously served as the head of Division of Pharmacology at CSIR. His award-winning research focuses on neuropharmacology, stress research, and R&D in drug discovery and development. We welcome you, sir. I would request, sir, to introduce our speaker, Dr. Bandyopadhyay, to take the forward session here.
हेलो ये नेक्स्ट है ये
बैक है
ये बैक था ये नेक्स्ट और ये वाला
Good morning, all of you.
ये वाला ना
It is my great privilege to introduce Professor S.K. Bandyopadhyay. I know him for a very long time. He's a very dedicated and hard-working pharmacologist. Hello. Yes. Hello. 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 Okay. So again, I just want to introduce Professor S.K. Bandyopadhyay. He is very known to me, and he was the president of Indian Pharmacological Society. Besides that, he was the Director General of Medical Health and Education in West Bengal, and he has published numerous papers. And what I find is that he is very dedicated in his work. Whenever there was a problem with West Bengal, I have seen that he has come out and tried to solve the numerous problems during this period. And he is a fellow of esteemed medical society. He has delivered numerous invited lectures in India. At present, he is the visiting professor in China. One thing I want to share with you, that we are having this oration, Dr. Govind Acharya. And was my privilege that he was my MD external examiner. In Lucknow, when I was appearing for the MD examination, Dr. Govinda Acharya came as my external examiner. What a nice person he was. He belonged to Patna, and his wife was also a gynecologist, and very soft-spoken, but full of knowledge. And besides, Dr. Govinda Acharya was one of the persons who has established, who have introduced Indian pharmacology. With few words, I will now request Dr. Bandyopadhyay to speak on this oration lecture.
Well, now it's afternoon, perhaps. Good afternoon, everybody. No, it's still morning. Good morning, everybody. Actually, really, it's my proud privilege to deliver an oration on a person. In fact, he is a father in one way, because in his hand the IPS was established in Patna, and during my student days in BHU, I still remember once I had the opportunity to receive him during MD examination at Mughal Sarai station. I was thinking this morning that today I will be delivering oration on his name. Anyhow, thank the organizers and the executive committee members for allowing me. So actually, I have chosen a topic that Winston Churchill once said, the further backward you can look, the further forward you are likely to see. Why I am telling this quote? The reason is that we shall have to look back if we are to know the present status of medical education, we shall have to know the past. And if we know the status to present status, we shall have to look forward for the future, because it is absolutely rotating, dynamic and dynamic. Actually, the history of medical education goes back to the era. Actually, there was a system that was called the Gurukul system during 900 to 1100 centuries, when there were the students were being stationed in the Gurukul, and the teachings were being done to the students, and you know, heard the name of the Sustita Samhita and all these about that when they used to deliver classes, the basic thing was mainly on didactic lectures. And then actually first in India, medical education came through Egyptians, and through then the Britishers brought the medical education in our country in 16th century. If you will look, that medical college was established in the year 1835, and it is during the British period they developed the idea, they had the idea that we shall have to educate the British youngs as well as the native young people, and through medical colleges. That was the establishment. And then in the same year, Madras Medical College was established in the same year, and the Grand Medical College Bombay, it was established in 1845. So in these places, the medical colleges were established in these places. And then, of course, the Sanskrit College was also established. And in Indian Medical Council Act was the first Medical Council Act was in 1933. And on the basis of that act in 1934, the first Medical Council of India was established. And then is medical education, the case started. This medical education was after independence. The Medical Council Act was established finally in 1956. Then the developmental era started actually first through Srivastava Committee, when the launching of rural health service started. In fact, we were in turn in those days that we had to move to the primary health centers for the training and other things during that period. Reorientation of medical education, the Rome program was very popular in those days, and Government of India was thinking in many directions to do many more things. Then the Bajaj Committee, the establishment of Educational Commission for Health Sciences was established. Medical curriculum before 2019 were basically on didactic lectures, that is basically on teachers who were active, and the recipient students were passive, subject centered, time based, focused on knowledge only, no possibility of any feedback. And I do not know how many medical students are here. Let me tell you one very funny story. When I had the opportunity once to go to China to teach students, and normally I used to teach students to Chinese and Indian people. And one day I found some Chinese students were sitting in my class, and I asked them, what you are doing, why you are sitting? Oh no, I heard about your name and all that, whatever it is. After the class, the students, the Chinese students came to me, and they were so surprised. They asked, that's how dare the students were, sir, asking you the question. And why? Then they told me, we are not supposed to ask any question to our teacher. Whatever the teacher will say, that will be finalized. That will be the final thing. So that was the status, not only in China, but also in our country. The same thing. The active was teacher, passive were students. And now there are certain advantages and disadvantages. So the time is short, so I will have to move fast. Otherwise, I could elaborate in detail. Advantage is structured environment for learning, focus on our foundation skills. Authority of teachers, definitely a positive point. Availability of resources, because why the resources are more? Because we get the information from the texts. So naturally, the resources are more. Has a proven track record. Assessment is easy, covers more content because we are providing the content from the text as a whole. And disadvantage, the first and foremost, practically no engagement of the students. So automatically a real world connection less, lack of personalization, contrast between memorization and understanding, not flexible, overemphasis grades, limited emphasis on life skills. And so across the ages, it formed like this informal apprentice, standardized curriculum, subjective integration. Then the most important thing which came in was bedside teaching. I will be trying to telling you as quickly as possible. This is now the order of the day, outcome-based learning, interdisciplinary team-based teaching, utilization of bedside teaching and the stimulation. This gentleman first discovered Abraham Flexner. Then this man, Osler, William Osler, he made the concept of bedside teaching, the medical residency and clinical clerkship. And outcome-based learning was demonstrated by Spady. So you see today's teaching is based on, when we enter, that's integration. Integer is a Latin word, that means the coordination. Integration is two types of integration are there. One is horizontal integration, another is vertical integration. Those I do not find much. Medical teacher is here anyhow. So subjective integration in medical education, inverted triangle. Nowadays, when we were students, we used to go to the clinics from second prof or second after the first semester or second semester. So, but today, from day one, they are sensitized, students are sensitized. You see 20% are in the first phases, 20% clinical, pre-para 60% and pre-clinical 80% in the phase 1 and phase 2. And then as it is advances, it becomes inverted triangle, 20%, 40% and 80%, just reverse. So from basic science to clinical science. This hardened spiral integration was there, by which these are all being demonstrated. Hardened ladder integration were there. Isolation, because isolation means single subject. Then awareness of the teacher, that is very important. Harmonization amongst the teachers is more important. Nesting, incorporation, alignment amongst the teachers, sharing, correct correlation, complementary to each other, the pre-para and clinical, pre-clinical, paraclinical and clinical. This interdisciplinary, and ultimately the subject identity gets lost when it becomes transdisciplinary. The basic difference between integrated versus traditional teaching. Integrated teaching, unifying topic, holistic learning, emphasizes on understanding of current problem and concepts, more clarification of concepts, less confusing, learning basic sciences. And in traditional teaching, the high degree of compartmentalization of curriculum, fragmented learning, that is the problem of this thing, emphasizes on examination and result. So, when we were students also, our main motto used to be how to pass. No question of how we will be a good doctor. There was no such question were there. The main motto were there, how to pass the exam. So examination oriented teaching would be there. Lots of confusion in students. So naturally, students are thoroughly confused, different information on same topics, and while learning clinical and other things. Outcome-based learnings I have already discussed because the time is going short, that is becoming a big problem, so I will have to hurry. Now after 2016, National Medical Council came, and then this NMC Act was enacted. NMC Act was enacted, and it was then totally the competency-based undergraduate curriculum for Indian medical graduates started. What were their basis things? Foundation course. Today, in undergraduate curriculum, foundation course is a must. Early clinical exposure, I have told you from day one, students are exposed clinically. Electives, alignment and integration, I have already told you. Learner-doctor method of clinical training. Role of an Indian medical graduate. So, if we see that the role of a medical graduate should be professional, researcher, a communicator, critical thinker, leader, lifelong, clinician, professional, ethical, responsible and accountable, patient, families, colleagues, community, analyze patient information, problem solving, informed decision, and leading the health team, that is also leader. Leadership is a very important part of the Indian medical graduate at day 2. So this is also teacher centric. Now self-awareness, this is also very important, interdisciplinary, collaborative, problem-based learning, small group learning, project-based learning. These are the order of the day. And now different technologies are now has enacted in this today's modern system of medical education teaching. And actually not today, it has started from, if you see, that photography slides were established in 1819, far back. Then film strips were there in 1910. Overhead projector, in fact, I could tell you many stories, but the same problem, time constraint, I cannot go in detail. Anyhow, multimedia approach started in 1980, multimedia approach. Then simulation has become a very, very important role in medical education curriculum today. In 2000, cloud-based role, then artificial intelligence everywhere, everywhere and everywhere. I will tell you in a very short period, and this AR and VR. So, newer methodologies, simulation-based teaching, this is applicable in pre-para as also in clinical. This team-based teaching, so no isolated team-based, always the teaching system. Flipped classroom, do you know any idea about flipping classroom, flipped classroom? Flipped classroom is that pre-prepared teachers, lecturer there in the computer, and students before entering the class, they will go through this and they will learn all these things time and again, this flipped classroom. So that what will happen, they will get themselves more oriented. Problem-based learning is now order of the day, and definitely very important has become, particularly after COVID 2019, that this distant education, e-learning, that was I was going to tell you, easy access, self-paced, personalized learning, increased flexibility, reduced expenses, resource reusability, immediate feedback, access to expert knowledge, and global collaboration. So these are the advantages of e-learning, which has become now very popular nowadays. Those who are still in teaching, you all know that how this e-learning has been done, and effect are these: one, actually accessibility, then lifelong learning, then customization and personalization, then evidence-based practices, then addressing knowledge gaps, then access to expert knowledge, and global collaboration and networking, quality assurance and accreditation. So in healthcare professional, this is the present scenario in classrooms, that what is we go. Forget, but still these chalk dusters, still even today, blackboard. You just remember we started our career with chalk duster and blackboard. And now the order of the day is AI in medical education. The question is whether how much we will depend on AI. That is becoming very important, not only in medical education, but in every aspect of life. How much? Should we depend to that extent that we become dependent on AI? That becomes a very important thing that is coming. Now, blending learning, human and technology. Because technology has become so fast, so much on it. If you see, the technology, mobility, structure, tracking and control, self-study, reduce cost, global research, global reach. And human was always there, motivation, personalization. What I want to emphasize, that human touch should not be deleted. Always, whatever AI we go, whatever AI we do, we should always remember that the human touch should always be there. Now coming to the future directions. So future direction says AI supported individual learning, AI supported, then student driven learning, virtual and augmented reality, simulation-based learning. We are all doing in, I believe those who are teaching the simulation, not only in pre-para, but also in clinical practice. This simulation has become very important part. So that is going on continuously. Stimulation-based learning, digital health literacy, humanistic care and ethics, community-oriented and longitudinal integration. So these are the future direction. As I was going to tell you that what should be the future direction of the medical education today. Now summarizing, medical education is a pivotal juncture requiring continuous evolution to meet the demands of modern healthcare. Evidence support the benefits of integrated curriculum, hybrid instructional models, diverse assessment strategies, early clinical exposure. This is very, very, very important. Now it's has become mandatory, early clinical exposure, because ultimately it will become a medical graduate. When it becomes pass out MBBS, it become medical graduate. By embracing evidence-based reforms, medical schools can optimize their curriculum to produce competent, compassionate, and adaptable physicians who are prepared to meet the evolving needs. Medical education is at pivotal. So, thank you very much, and the change is the law of life. and those who look only to the past or present are certain to miss the future. So that was told by John F. Kennedy, and I believe that change, that is the most important thing. Suddenly hall has become quite scantier because perhaps the star campaigners have left. Anyhow, thank you for your patient hearing. Thank you very much.
Thank you, Dr. Bandyopadhyay, for completing all the whole thing in a very short period. Thank you for your presentation. Thank you.
Thank you so much, sir, for such an enlightening talk indeed. I would request our chairperson to felicitate the speaker of the day, Professor Bandyopadhyay. I would also request the IPS core committee to please grace the dais and felicitate our chairperson, Professor Babul sir, Shiv Prakash sir, Devan sir. Can we have you here? Thank you. Thank you so much, sir. So now is the tea break time. We all are going to assemble here after 15 minutes. Please take care of the time. We have to assemble back here after 15 minutes. Thank you.
Welcome back. We now commence Symposia 1, focused on translational frontiers, bridging molecular insights to clinical innovation. I request Dr. Shiv Prakash and Dr. S.K. Bandopadhyay to kindly preside as chairs. You have already been acquainted with Dr. S.K. Bandopadhyay, who is a distinguished pharmacologist with over 40 years of teaching and research experience. To jointly steer this prestigious session, we have Dr. Shiv Prakash, a highly distinguished leader in pharmacology and drug discovery, currently serving as president of IPS, chief advisor. A prominent academic and industry figure, Dr. Prakash is a former chief editor of Indian Journal of Pharmacology and past vice president of IPS. He has authored over 100 research papers, and a book holds multiple patents and is a recipient of prestigious awards, including Udyog Ratna and Entrepreneur Excellence Award. This symposia features 3 distinguished speakers presenting clinical and molecular breakthroughs. I would request honorable chairpersons to introduce our eminent speakers for the session.
Okay, good afternoon, everybody. Our first speaker of this symposia is Dr. Anil Gulati. Dr. Anil Gulati, Dr. Anil Gulati is an eminent pharmacologist, innovator, and entrepreneur, recognized for his pioneer contribution to translation drug development. He is the founder, chairman, and CEO of Pharma Corporation and holds eminent emeritus position at Midwestern University and University of Illinois in Chicago. A graduate of King's George Medical College, MBBS as well as MD, he earned his PhD in pharmacology and therapeutics from Erasmus University, Rotterdam, and is certified by the American Board of Clinical Pharmacology. Professor Gulati's groundbreaking research led to the development of Centraquin, a novel resuscitative agent for hypovolemic shock, and sovatildide and endothelin beta receptor agonist for treating cerebral stroke. His innovative approach of stimulating dormant regenerative cells to repair damaged brain tissue has opened new frontiers in neurotherapeutics, receipt of several prestigious awards, including the International Ranbaxy Research Award, Paul R. Dawson Biotechnology Award, and Little John Award. Professor Gulati has over 300 publications, 60 patents, and has mentored countless students and physicians worldwide, exemplifying excellence in scientific innovation and leadership. With this brief introduction, I request Professor Gulati to deliver his lecture.
Hello, can you? Yes. Thank you, chairpersons, and it was almost 8-9 months ago when Professor Anil Kumar approached that you should be coming here. So, and Chandigarh happens to be my in-laws' place, so I said, yes, I'm coming 100%. So here I am, and it's always a pleasure to meet everyone. Although my trip is short, but it is going to be sweet because meeting everyone is old memories which come into picture. So I have been professor almost throughout my life, and then I became emeritus. During my inventions, the inventions are disclosed to the university, and then I started a company to develop those as a drug. So this company, Pharma, was founded in 2010 I'm the founder, and then now it has grown to the extent that we have several products which are in market, at 2 of them in market now in India, and phase 3 in the US. One is for acute cerebral ischemic stroke, and we have partnered with Sun Pharma. They are our sales and distribution entity. Other hypoxic ischemic encephalopathy, phase 2 is going on in India. Alzheimer's disease, phase 2, 80 patients completed in India. And the product which I am going to talk about is Centhaquin, which originally is from CDRI, where I worked initially after my graduation. Hypovolemic shock, it has launched in India, and phase 3 in the US. ARDS, acute respiratory distress syndrome, we have a phase 2 IND approved by the US FDA. Septic shock is another indication which we are pursuing. And so I'll focus more on Centhaquin today. And the uniqueness of this is that this product is free of arterial constriction. It is marketed under the brand name of Lifaquin. So it's a new paradigm in the treatment of shock because it is free of arterial constriction. I just want to emphasize again and again. So how does it increase the blood pressure? This will be a very interesting story as we go along, that in spite of no arterial constriction, rather it has little bit of arterial dilatation, but still it can increase the blood pressure in a patient with shock. So patients in shock where there is excessive blood loss or septic shock, there is very high mortality, somewhere between 15 to 20%. Even in some of the underdeveloped or partially developed countries, this mortality can go up to almost 35%. So what happens is decrease in cardiac output, hypoperfusion, multiple organ failure, and death. That is the critical. So basically blood pressure goes down, oxygen level goes down, and organ failure, and ultimately death it takes place. So the current treatment is patients are given fluids, crystalloid, colloids, and blood products and all that, and fluid, if it's not enough, vasopressors are added, which are arterial constrictors. Some norepinephrine, we all know, is for ages, it has been used. Then there is vasopressin, angiotensin was recently launched. So all of them are arterial constrictors. So arterial constrictors, they actually reduce the tissue blood perfusion. There is a lot of beta activity and other kinds of cardiac arrhythmias. They are another problem, so they have to be titrated very carefully. Fluid extravasation and vasopressor infusion requires careful titration, and in US most of the time these have to be given through a central line. So that means a small procedure has to be done, and so then the central line is put in the big vein, and then the infusion is done. So this is the first experiment which we did for Centhaquin, which was very informative. So I always use this slide. So here is the blood pressure, then the massive blood loss is produced. This is the Vickers model where there is blood loss, so the blood pressure goes down. This is the mean pressure. Heart rate, you can see that once blood loss is there, it goes down. When we give Centhaquin, look, the blood pressure is going up and heart rate is going down. So this observation was very alarming to us, that blood pressure is going up and heart rate is going down, and most of the arterial constrictors or vasopressors used today, their heart rate also goes up, not down. So that was, so we did pressure volume studies, and Dr. Manish Lavale is here. He is now the managing director of Pharma's India. So he did these experiments way back many years ago, where this width gives us the stroke volume, and you will see that in the next slide, this is the sham pressure volume loops, and here there is blood loss, This is vehicle, this is Centhaquin, and you can see that the stroke volume significantly improves. Here it's going back and ultimately death. There was no animal survived till 240 minutes. So these studies were done in Greece independently by Professor Theodore Xanthos, and what he found was in a swine model 50% of blood volume was taken out, and we can see that the fluid administered in vehicle was close to 2.2 liters, while in Centhaquin it was only 300-400 ml. So without much of fluid infusion, the resuscitation could take place, and 2 hours later in vehicle only 2 animals survived, while all of them survived 2 hours, and even 24 hours 9 out of 10 animals survived. So these were very positive results which led to our further studies now to see the concept. So you can see that the cardiac output, when there is blood loss, it goes down, and in Centhaquin cardiac output is significantly improved. While what happens to vascular resistance, it is decreasing. So cardiac output is increasing, vascular resistance is decreasing. When vascular resistance goes down, the blood pressure should fall, but the blood pressure is going up. That means the major contribution is coming from cardiac output. So lung wet dry rate, these findings were also positive, that 4.8 and 3.08. Horowitz index also significantly improved. Mortality also, you can see that swine, it was quite a big difference between the 2 groups. So all of these were pointing us to something which we thought that let us explore further, particularly cerebral blood flow, and you can see when blood loss is taking place, there is decrease in perfusion, and with Centhaquin, the perfusion is increasing as we go along. So now you can see that quite a significant increase in cerebral blood flow. Now this is important because brain has very intense auto-regulation. In spite of that, the blood flow is going up in the brain. So free of arterial constriction, cardiac output increase is the dominant effect which leads to an increase in blood pressure, and vascular resistance is decreased. So the new concept of resuscitation was put in. Now the idea was that there is 30% of the blood is on the arterial side, 70% is on the venous side. So venous blood pools very rapidly, and when a patient goes in shock, this pooling further increases. So already 60-70% of the blood is on the venous side. When shock occurs, it further goes up. Centhaquin, what it does is it moves that blood towards the arterial side. So veins which are compliant can accommodate, and large amount of blood is on the venous side which can be moved towards the arterial side. So Centhaquin, where it acts, so we did a lot of studies, and various receptors were identified. Ultimately alpha 2B and 95% of alpha 2B receptors are on the venous side. So it is constrictor of these, and then there are alpha 2A receptors in the central nervous system which are decreasing the sympathetic drive. Therefore there is decrease in vascular resistance. But the key thing is increased venous return to the heart. That will lead to increased cardiac output, and heart pumps more blood per beat. That means stroke volume is increasing, and predominant effect is cardiac output increase, which is leading to increased blood perfusion. So this is a human study in which cardiac output and inferior vena cava diameter was measured. So you can see that there is very good correlation between cardiac output in humans with hypovolemic shock and inferior vena cava diameter. So these findings have been published now, and you can see that inferior vena cava diameter 0 minutes, 60 minutes, 120, 300 minutes in humans, it is gradually increasing. So what we did was we tried to correlate or regression analysis between stroke volume and inferior vena cava, and you can see a very, very good correlation between stroke volume. So in humans also, besides animal models, in humans also we are proving that it is the stroke volume which is contributing towards an increase in blood pressure. So here with blood pressure also inferior vena cava diameter, it is correlating very well. So there is venoconstriction by synthoquine, and that venoconstriction leads to an increase in cardiac output, and in alpha 2A activity in the brain leads to a decrease in vascular resistance. So we did phase 1, phase 2, phase 3 in India, and ultimately the drug has been launched. So these are the phase 2 results which I'll show you, and you can see that the demographics, they were similar between the two groups. I won't go in those details. The amount of vasopressors infused in the first 48 hours was from 9 to 3. So there is quite a decrease in the use of vasopressors, and we know that if we use less of arterial constrictors, the patient's adverse events are much less, and survival also is way better. Time in ICU also goes down. It is not significant, but there is a trend that it is going down. Hospital stay, ICU, then time spent on ventilator from 1.9 to 0.89, that also the trend is that it is going down, but because of error it is not significant. Blood pressure, you can see that in a patient the green is synthoquine and red is standard of care, and we can see that the blood pressure in synthoquine group is much better than in so systolic blood pressure and similarly diastolic pressure, both are improved. Base deficit, which is an important indicator for mortality, we can see that in synthoquine group it becomes base positive instead of deficit. Lactate levels, very important, which are very key indicator of mortality in a patient with shock. We can see that huge decrease in lactate level. I think Dr. Manish was one of the, when he was doing those experiments, he constantly noticed that lactate level goes down, and that led to the discovery of filing patents and ultimately launch of this drug. So in individual patients, we see the data that lactate levels in a control group p-value is 0.29, while in synthoquine group it is 0.028. Now there were, I think there were two patients which were very well matched between the two groups, and this is patient 10 and patient 12, patient 10 in the control group and patient 12 in synthoquine group, and both patients were ectopic pregnancy which went bad and massive blood loss took place. So the age is 24-year-old female, 31-year-old female. This is in the synthoquine group and this is in the control group. You can see that blood loss, hemoglobin level went down to 9.3, and here it is 3.6, and blood lactate level from 11, and here it is 17, which is very, very severe. And this patient could not survive, while the synthoquine patient did survive, and almost 40 milligrams of vasopressors were also given. So we had 2 deaths in phase 2 study in the control group, while 0 in the synthoquine group. These findings were published in this journal, and then we embarked on phase 3. Phase 3 we did, there were 2 groups, and block randomization was used. Because the results in phase 2 were so promising, it was decided that it will be 2:1 ratio, that more patients will receive synthoquine than the control. So basically 2:1 ratio was followed. So these are the hospitals where the trials were done, and you can see the basic baseline hemoglobin. This is synthoquine green one. It is equal but little bit less. Hematocrit also a little bit less, and blood pressure in phase 3 also, it is the same trend which we were finding in phase 2, that the blood pressure systolic as well as diastolic both are improved compared to the control with standard of care. Shock index here which we measured, this was also quite promising in the sense that with synthoquine, the shock index statistically you can see that within matter of half an hour it started reaching the level of significance, and then it is significant all the way down. So very significant improvement in shock index once again, and shock index in the early 6 hours is one of the most important index for survival. So lactate levels, as we found in phase 2, once again they are decreased. Number of patients with less than 1.5 lactate is also better in Senthaquin compared to control. Base deficit, same finding which we got in phase 2, that number of patients showing base deficit improvement is statistically significant. ARDS, which is an important indicator in shock, also you can see that it reached the level of significance in Senthaquin, while in control it was not. MODS, which is another indicator, Senthaquin, there is MODS, or shock is the patients are recovering much better than in control. So what happened was in phase 3, all the primary endpoints, 4 primary endpoints, which are blood pressure, systolic, diastolic, blood lactate and base deficit, they reached the level of significance which was statistically less than 0.05. Mortality, 28-day mortality in control was about 12%, while in Senthaquin it was about 3%. It did not reach the level of significance 0.07, but a very big difference in absolute mortality. So we did further analysis of, because phase 2 and phase 3 data, inclusion-exclusion criteria were similar. John Louis Vincent, who is world-renowned person in critical care from Belgium, in his editor of 4 or 5 journals, which are all above 30 impact factors. So no pharmacological intervention consistently reduced mortality, and Senthaquin did show that when we did meta-analysis of phase 2, phase 3 combined, that the p-value did reach the level of significance. So there were adverse events. There were total of 9 adverse events in phase 3, 4 there were deaths reported in the control group, 2 deaths reported in Senthaquin group, and there were 2 events with creatinine level increase, which resolved without any issue. There was 1 event of vomiting, so not much of adverse event in a critically ill or dying patients, which was observed. These findings have been published in the journal Drugs, and so to summarize, this is the concept, which is Senthaquin, when it is administered, it has multiple 2 predominant effects. One is that venous pressure goes up, venous return goes up, ventricular filling, and Frank-Starling's law, more blood comes to the ventricle, more is pumped out of the ventricle. So ventricular contraction improves, stroke volume goes up, cardiac output goes up. Heart rate decrease, which is because of CNS effect, also will lead to increased diastolic time, which will lead to increased filling time, ultimately contributing to ventricular filling. Simultaneously, fluids are given in a shock patients, that also will increase blood volume and ventricular filling. So overall, you can see the schematic is that it favors an increase in cardiac output. However, since Frank-Starling's law is involved, we have to be cautious that patients with heart failure, the efficacy may be much less. So in other words, the schematic is alpha 2A activity in the brain leads to arterial dilatation, which decreases the afterload, while alpha 2B activity, venous return, and that leads to increase in cardiac output. And because the afterload is decreased, preload is increased, all that contributes towards improved tissue perfusion. So it is easy, it comes, we just 10 ml vial, we put according to body weight, the volume, and ultimately infused over 1 hour in 100 ml of saline. Now what happened, we took all this data and went to US FDA. So we submitted this phase 3 IND for US FDA, and we were That happened first time that not a single patient was done in United States. And US FDA approved our phase 3 trial. And this is the design of the study which US FDA has approved. It will be a randomized, double-blind, and primary endpoint is all-cause mortality at 28 days. Secondary endpoints and exploratory endpoints are mortality 60 days, ventilator-free days, more of patient-oriented endpoints which are FDA looks for. So all those are in place now. We have formed a committee to look into the trial. So the difference between the US FDA approved study and the India study which we did, the primary endpoint in India was blood pressure, lactate levels and base deficit. Here it is mortality, and those blood pressure and all that will be secondary endpoints. Inclusion criteria is exactly similar. When a patient comes in an emergency with massive blood loss or in a shock, then the blood pressure, if it is systolic blood pressure goes below 90 and lactate level is above 2, the protocol kicks in for resuscitation. In India, there were patients with massive fluid loss also besides blood loss. In US, the FDA asks us to, etiology should be, if it is not available, then those patients should be excluded. 430 patient size and 7% reduction if we assume, although in India we got closer to 9-10%, then the drug will be approved in the US. Randomization 1:1, futility analysis is there. So treatment, these are all ages old drugs which are used. There is nothing new which has come up. So standard of care is more or less similar between the multiple countries. So ultimately, one major difference is that for Sentaquin, since it is not an arterial constrictor, it can be given through the peripheral vein. While all other arterial constrictors, because of necrosis, it has to be given through the central line. So central line and peripheral, it makes a very big difference because of surgical procedure, and almost an hour is lost putting the central line, and that 1 hour can be very, very critical in a dying patient. So we formed a world-renowned investigator. So Professor Jean-Louis Vincent agreed to be on my committee as an advisor, Daniel DeBacker from Brussels, Matthew Legrand from UCSF, Jan Bakker from Erasmus, Marlene Osterman from London, Ashish Khanna, who comes here, and his father was here in PGI, so he has a lot of attachment to Chandigarh also. So they are our committee. And
now, in the future, I may add this slide. Sentaquin has a very interesting profile as an alpha-2b stimulating agent, and it has a totally different mode of action. But the idea of vasoconstriction, I believe, is an excellent idea that could help to limit fluid administration and perhaps limit blood transfusion, or at least maintain a better hemoglobin level, because it's the patient's blood which is put in the circulation. And there is no vasoconstriction, as we heard, and there could be a small decrease in heart rate. So these are a number of potential advantages. And so in the future, in a few years from now, we may actually put it at the very beginning of our management. We could say, okay, start fluid and give already some.
So takeaway from his message and from the committee is that very different mode of action compared to current vasoactive agents. Venous constriction, very good idea, and it is the patient's own blood which is being increased, which is used to increase the circulating volume. So hemoglobin levels are much better maintained than in infusing fluids. No arterial constriction, decrease in heart rate, and his advocacy is that begin management of shock patient with the start of fluid and synthroquine. So now, where are we right now? So we know that FDA has approved. We formed the committee and we are planning to embark on this study. In the meantime, we also have a phase 2 IND from US FDA approved for ARDS, and it's a 80 patient study. Professor Landoni is the leading person, and this we have already funded the trial, so it will be done in Italy, and he'll be coordinating all the activities. So 15 patient study for cardiac output was done, and that is the data which I showed you, where the very good correlation between inferior vena cava diameter and stroke volume. Phase 4 study, 400 patient study is ongoing in India, out of which 344 patients have been enrolled till date. Then in Turkey, there is another study. This has been completed. We are about to get the results from this study. And then there is a septic shock study which is being started in the Erasmus University in Brussels. So a lot of coverage takes place, and thank you very much. I will be leaving soon, but my emails, university emails and company email, they are all working. So please do not hesitate to contact me because as soon as I'm done, I have to leave back to Delhi and then to Bombay. So thank you very much. Any questions?
Hello. Yeah. Thank you. Thank you. Thank you very much, sir. There are two more excellent speakers in queue. We will allow one question. Anybody, one question. Please.
Yeah, I think that compound is still in early stages of clinical trial, and the concept is a little bit different. There is more of volume preservation rather than increasing the blood pressure through resuscitative measures. So that concept is more of volume preservation, that the substance, when it is giving, it leads to preservation of the volume and not extravasation of fluids and all that. So a little bit different from, it can be used complementary down the line.
In one word, I will ask you just one question. Will you consider it as this drug anthem as a cardiac stimulant or a cardiotonic?
Yeah, so I will consider more of a non-stimulant, more of a cardiotonic, but there were initial studies in CDRI wherein higher doses. Yeah, it is more towards venous side. That is the whole concept. So in higher doses, it was shown, Dr. Shrimal, he did some experiments in cat model where he found that in higher doses, it can increase cardiac output through contraction.
Thank you very much, sir.
Thank you.
Now I request our session chairs to graciously present a token of appreciation to Dr. Gulati. We can now start with the second speaker of the symposia.
We have the second speaker. It's my honor to introduce Dr. Nicola. Is a full-time professor of pharmacology at the University of Angers, specializing in molecular pharmacology, nanomedicine, and translational therapeutics. He obtained his PharmD, biochemistry and molecular biology, PhD in physiology and pathophysiology, and habilitation to direct research. His postdoctoral and academic career spans prestigious INSOM and CNRS research units, with progressive roles from temporary research associate to full professor since 2022. Dr. Nicola research focuses on endothelial plasticity, tumor microenvironments, nanomedicine, and cardiovascular pharmacology, with over 1,985 citations and an H index of 20. He has authored more than 35 high-impact publications, contributed to 2 patents, and serves on editorial boards of leading pharmacology journals. He has successfully supervised multiple PhD and master students and secured substantial research funding, including ANR, IR, SPR, and European Co-Fund Breathe. In education, he leads master's courses in nanomedicine, cellular interactions, and therapeutics, and has authored foundational pharmacology textbooks. Administratively, he directs the Angers Postdoctoral Center, participates in national scientific councils, and contributes to regulatory advisory boards such as ANSM and ANSES. They are French regulatory authorities. He is also an active member of scientific societies, including the French Society of Pharmacology and Therapeutics and the European Association for Cancer Research, demonstrating leadership in both research and academic governance. With this introduction, I request Dr. Nicolas Claire to deliver his lecture. Thank you, sir.
Thank you very much. Thank you very much for your invitation. Today, I would like to talk about the endothelial cells differentiation to better understand its role in tumorigenesis and in drug resistance. To introduce my presentation, I have chosen to draw inspiration on part of an editorial written by Montserrat Rojo de la Vega, an editorial member of Cancer Cells. She wrote her editorial on 2023, and in its editorial, Montserrat described an holistic view of cancer. She described the role of cancer cells in an environment composed by different cells. She wrote that tumor cells do not exist in a void. The tumor microenvironment is a complex yet highly structured ecosystem. She concluded her editorial by a very interesting sentence. She concluded by this sentence, therefore, to understand the one, we must understand the other and recognize their interconnectedness. The tumor microenvironment has been described by Douglas Hanahan in different reviews. Douglas Hanahan described the hallmarks of cancer, and Douglas Hanahan described the hallmark of cancer by identifying cancer cells, cancer stem cells that can be differentiated, and these cells are in an environment composed by cancer-associated fibroblasts that are involved in tumorigenesis or in drug resistance, endothelial cells and pericyte that compose the vascular structure, and immune cells such as macrophages, lymphocytes, or dendritic cells. From disease discoveries, different molecules have been commercialized, such as immunotherapies or targeted therapies, such as tyrosine kinase inhibitors. While these molecules are very good to treat the cancer, different resistance have been discovered. The origin of disease resistance have been described in 2024 in a paper published by Rozowska. Different origins have been identified. The first origin is the tumor heterogeneity. In fact, cells during the tumor development, cells acquire genetic alterations that generate genetic diversity. The second hypothesis is correlated with the first, because if the tumor grows low, the tumor cells can acquire genomic alteration and then can acquire drug resistance. Tumor cells can also acquire genomic drivers, undruggable genomic drivers that can induce drug resistance. Among these genomic drivers, we can cite MYC or TP53 that are known to be involved in cell cycle. Another hypothesis is the selective therapeutic pressure exerted by radio or chemotherapy that can induce drug resistance. And finally, drug resistance can be explained by the cells that compose the tumor microenvironment. Among these cells, endothelial cells play a key role in drug resistance. Endothelial cells are at the crossroad of different pathophysiological processes. In fact, in tumorigenesis, endothelial cells can be involved in angiogenesis. Angiogenesis has been discovered by Julia Folkman in 1971, and different other works have demonstrated the role of angiogenesis. Angiogenesis is defined by the formation of new vessels from pre-existing. Angiogenesis is very important to explain the metastatic process, for example, and angiogenesis from the data from Folkman and Peter Carmelit, different molecules have been commercialized to target VEGF or its receptor and to treat different solid cancer. The second process is vascular mimicry. In vascular mimicry, endothelial cells are indirectly involved in this process because vascular mimicry is an epithelial cell differentiation in an endothelial compartment, an endothelial environment that is in an environment in which angiogenic factors are expressed, are mainly expressed. And the third mechanism is endothelial to mesenchymal transition that first discovered in fibrosis, in lung fibrosis, and discussed in cancer. Endothelial to mesenchymal transition is endothelial differentiation induced by different mediators. During this process, endothelial cells lose their properties. For example, they lose their cell-cell junction or their polarities. Endothelial cells lose also their endothelial markers, such as CD31, VE-cadherin, or von Willebrand factors. These differentiated cells acquire new properties, such as mesenchymal properties, as an enhancement of migratory properties. These cells acquire also mesenchymal markers, such as N-cadherin, alpha-smooth muscle actin, SM22-alpha, vimentin, or others. In a recent review, we compare disease endothelial to mesenchymal transition to sprouting angiogenesis that favor the production of cancer-associated fibroblasts involving the extravasation and metastasis, so tumor growth. As previously said, different molecules induced endothelial to mesenchymal transition. TGF-beta, hypoxia, Wnt, chemo or radiotherapy. And we evaluated the role of oxidative stress. In fact, oxidative stress is mainly expressed in solid tumor. ROS and ADPH oxidase are mainly expressed in different solid tumors. And the first part of our project was to describe the role of oxidative stress in endothelial to mesenchymal transition. This work are conducted by Valentin Platel during his PhD, and Valentin has evaluated the ROS production from conditioned media called CM during this presentation by evaluating DCFDA fluorescence intensity by flow cytometry. Interestingly, we observed, after 48 hours and 72 hours, an increase of ROS production when the cells in cancer cells, and we evaluated the role of NOX1 and NOX2 by using 2 inhibitors, and interestingly, we observed after 24 hours, 48 hours, a decrease of ROS production, and a significant decrease of ROS production after 72 hours confirmed the role of these 2 enzymes in CM-induced ROS production. Then we evaluated the role of these 2 enzymes in tubulogenesis. Tubulogenesis is the capacity of UVEC to form capillaries on matrix gels. Then we observed a significant decrease of capillary length when the UVEC cells were treated with CM. And we observed, interestingly, after 24, 48 and 72 hours, we observed that the co-treatment with inhibitors against NOX1 and NOX2 prevent the decrease of capillary length. So we confirm that inhibiting NOX1 and NOX2 prevent CM-induced endo-MT. We discovered 2 enzymes that are able to induce endo-MT. And then in the second part of this work, we evaluated the content of the CM by proteomic analysis. And we identified, Diane Le Chevalier, during her Master 2, identified a protein, spark protein, known to favor the tumorigenesis. We evaluated the role of spark in a clinical study, and we quantified the plasma level of spark in a cohort of 40 patients with stage 3-4 melanoma, and we confirm a correlation between the level, higher level of spark and the BRAF status. So we identify a correlation between BRAF mutation status and plasma spark concentration in melanoma, in metastatic melanoma. We then evaluated the endothelial to mesenchymal transition in non-small cell lung cancer. That is an aggressive cancer with a 5-year survival rate less than 20%. We evaluated the role of endothelial to mesenchymal transition in this cancer, and Clara Bourreau, during her PhD, has evaluated the role of endothelial to mesenchymal transition. First, by immunochemistry study, we showed that cells, UVEC endothelial cells treated by different CM from NSCLC, the treatment increase the actin stress fibers and decrease von Willebrand factors and endothelial markers. So this is results suggest that CM induced morphological change in UVEC. Then we evaluated the migration of disease differentiated cells, and we observed interestingly that UVEC cells treated by each CM are able to induce, to enhance their migratory properties. And interestingly, after 72 hours, we observe an enhancement similar that observed with TGF-beta and EL1, the positive control of our experiments. Then we discussed the phenotype of the treated cells by flow cytometry. And on this slide, I present only 2 cm, and we observe a significant decrease after 48 and 72 hours, a significant decrease of the double staining von Willebrand factors and alpha SMA, and a significant increase of cells that expressed alpha SMA. So this is results confirm a modification of the phenotype of endothelial cells, and then CM are able to induce the transition of treated UVEC. Finally, we identified the content of the CM, and we observed 5 clusters for each CM. And interestingly, we identify a correlation heat map with proteins that involved in matrix remodeling or epithelial to mesenchymal transition. And we identified osteopontine as a protein involved in endothelial to mesenchymal transition. And interestingly, we showed that osteopontine is correlated with less prognostic of lung cancer, and osteopontine is inversely correlated with CD31, an endothelial marker We realized all this experiment in 2D model. But a paper from Kim in 2019 has described the role of 3D model in endothelial to mesenchymal transition, and he showed that treatment of endothelial cells with medium from 3D model enhanced the endothelial to mesenchymal transition with a higher alpha SMA and a less CD31. So we designed different spheroids, and Eva Martin, during her PhD, designed different spheroids, monocellular spheroids, multicellular spheroids with UVEC or Schwann cells. And this slide shows live cells in green and died cells in red. And interestingly, we evaluated the endothelial to mesenchymal transition, and we showed that VEGF-R, von Willebrand factor, or CD31 are significantly decreased in endothelial cells in the 3D model, and we observed a significant increase of SM22, vimentin, 2 mesenchymal markers of endothelial cells. So interestingly, we have shown that endothelial cells, endothelial to mesenchymal transition is an important process in tumorigenesis. In fact, there is different mediators that induced endothelial to mesenchymal transition, TGF-beta, Notch, oxidative stress, and different molecules decrease endothelial to mesenchymal transition, such as VEGF, miRNA, or different chemical inhibitors. Different molecules are able to decrease endothelial to mesenchymal transition. Imatinib, a tyrosine kinase inhibitor, hydrocortisone, or spironolactone. But all the experiments described by Mann in 2019 were realized in vitro assays. So it's very important to confirm these results in vivo or ex vivo models. Finally, endothelial to mesenchymal transition could be interesting to treat different diseases. In fact, endothelial is differentiated in mesenchymal cells, and then mesenchymal cells could be differentiated in different other cells. These other cells can be used, for example, in tissue engineering to treat different disease, and maybe these cells could be interesting to treat, for example, cancer. To conclude, I would like to thank Eva Martin, Shreyade. Shreyade is a PhD student from India who arrived in our lab at the beginning of October. Valentin Platel, Clara Bourreau, Diane Le Chevalier, Flavien Vessaguet from Mitovask lab, Professor Ludovic Martin from the Department of Dermatology, Dr. Lucas Treps and Dr. Isabelle Cor from the CRCI du HENA lab in Nantes, in France. To finish, on behalf of the French Pharmacological Society, in which I am part of the advisory board, I would like to express my sincere gratitude for the excellent welcome, my gratitude to the Indian Pharmacological Society, to Dr. Sandeep, and to all organizers of this meeting. It's a pleasure for me to be here. Thank you very much.
Thank you, Dr. Nicola. And we need to keep up the time, so we will allow again one question to be asked to Dr. Nicola Claire. Anybody, one question? Okay, if not there, thank you very much, Dr.
Thank
Nicola.
you.
It was wonderful, listening to you.
Thank you very much.
I hope this is a last speaker of this session. The speaker is Dr. Suresh Chandra Tyagi. Professor Suresh Chandra Tyagi is a distinguished biomedical scientist and educator currently serving as Professor of Physiology and Biophysics, Stockgill Endowed Chair in Biomedical Sciences and Vice Chair for Research at the University of Louisville, USA. Trained in India and Ireland, Dr. Tyagi began his career as a biophysics scientist before joining the University of Missouri at Columbia, 1992-96, and later the University of Mississippi Medical Center, 98 to 2003. Dr. Tyagi research focuses on cardiovascular remodeling, vascular dementia, cancer, and brain microvascular diseases with sustained national funding support. He has published extensively in leading journals including American Journal of Physiology Biochemistry, an active member of American Physiological Society, International Society for Heart Research, and American Heart Association. He has served in numerous leadership and review roles, including as a regular member of the NIH MIM study section. He also serves on editorial board of AJP and JMCC, clinical and experimental hypertension, and molecular and cellular biochemistry. Professor Tyagi's work continues to advance understanding of cardiovascular and neurovascular pathophysiology. Dr. Tyagi, please.
Thank you, Mr. Chairman, and thank you, Dr. Anil Kumar and organizing committee for giving us opportunity to present our work. I'm going to talk about morning heart attack. Many people have high cholesterol, high lipidemia, diabetes, hypertension, aging, everything, but you don't know why it's a morning time heart attack. So I'm going to connect with epigenetics, and there's a hypertension called nocturnal hypertension. That's a hypertension means when we sleep normally, healthy person, there's a dipping in blood pressure, say 120, when you sleep it's about 105 or 110. So the dipping is very important. Some people don't get the dipping, so they have a nocturnal hypertension, and that hypertension can compound on a pre-existing thromboembolic situation, like acute thromboembolism plus nocturnal hypertension, and you will see more morning time heart attack. And epigenetics means gene plus modify a gene. Like when we have embryo, when baby is developing, this finger and this finger, what's the difference here? Here DNA is a stop making protein. Here DNA is still making it. So when we in biochemistry, we have chromatin relaxation, means acetylation. The chromatin open up. Chromatin compactation, that's chromatin close it. So methylation is close it, acetylation open. So methylation, when you do methylation of the gene, methyl group is when we take the food, we have a lot of 24 amino acids, but methionine, especially in red meat, is very high. I mean, about almost 1% of, so 1% of one amino acid is very high. So when you have to take methionine and take a methyl group, put on DNA, what you will make? You'll make a homocysteine. That's why during pregnancy, you unequivocally you give folic acid. I mean, no default. So it will make you, so what it will do, it will recycle back that homocysteine back to methionine. So it's cycle. And this methylation or demethylation is a dynamic process. And especially in histone 3, lysine 4, the methylation, demethylation is very important. And that's where there's an enzyme called, which hydrolyzes homocysteine. They work as a clock gene. Clock is a ball transcription factor, and it can disrupt that aspect. And incidentally, the homocysteine, when we sleep, our excitatory neurotransmitter like NMDA are down. Inhibitory neurotransmitter like GABA is up. So that's why we sleep. But homocysteine agonize NMDA, inhibit GABA, and that's why the melatonin goes up in the nighttime, and that keep you balanced to sleep. So this is the overall picture in our lab we're doing. That's the clock. These are clock factor. BAL1 is a one important transcription factor, and the clock. It's like a yin and yang. It's a BAL1. This is the transcription factor which controls sleep and wake, and the part 1 and part 2. So one goes up, one goes down. That's how we sleep. But here with BAL1, and there's an enzyme called S-adenosine homocysteine hydrolase, it works as a heterodimer, especially in chromatin 3, histone chromatin 3, lysine 3. And here, this is just overall picture that how this anxiety, depression, soldier combat, sleep, they can all cause to sleeping problem, especially the BAL pathway. Now here is my lab focusing in this aspect. Here BAL1 and SHS making homocysteine and NMD, as I just explained you. And here, this has to be methylation, demethylation. The DNA methyltransferase, that is hydrolase, so it is a rhythmic process. And if you get disrupted, you accumulate homocysteine. Usually homocysteine get transsulfuration with this pathway, cystathione beta synthase, CBS, and this is mercaptotransferase, this is mitochondria. If it's also disrupted, you will have more accumulated. And another, the homocysteine, when it hydrolyzes, it's adenosine with this another editor. In fact, this is gene writer, eraser, and this is editor. These are all work on DNA and RNA. Now, if you this one, you can hydrolyze and make uric acid, and acutely when high uric acid is called cardiovascular problem. And these are other factors with methionine, high methionine diet, or this one carbon metabolism. This is the thing we invented in our lab, and this is whole cartoon how this methylation, demethylation work. And it is said that MMP13 is a one in rare rodent we call 13, but in human it's called MMP1. And what is designed the tissue remodeling, collagen, elastin and laminin in the nucleus. They're all with this enzyme is very important in processing the tissue structure. There are some references here to show that there's just more references where there's in female and nocturnal hypertension and blood pressure, the homocysteine is related. Especially the homocystinuria and abrogated sleep blood pressure, there's few information, but the mechanism was not clear. So there's association with homocysteine already in sleeping, abrogation, sleep dipping blood pressure causing nocturnal hypertension, but there's no mechanism proposed. And there are some more papers showing that, in fact, this one we show the NMDA related and this more time dependence, this stroke volume, all these things, they're all associated with homocysteine and morning time event in the cardiovascular disease. And this is one paper we show that the NMDA agonize, homocysteine agonize NMDA receptor, antagonize GABA1 long term. So this, the other paper related to same aspect, epilepsy and just to cover the background here. So here is the paper which got interested that homocysteine hydrolase, which I call SAHS, and BAL1, they work as a heterodimer on histone 3H1. And that's where that's what the first slide I showed, how the dynamic process. And this, in our situation, the SAHS control this BAL1. So you will sleep or not sleep, it depends how this BAL1 is active or not active. This is a very original data, and this is telemetric blood pressure, means conscious blood pressure monitoring when mouse is sleeping or wake. We have a catheter in the back of the neck in aorta, and you can see the continuous blood pressure monitoring. And here, all 24 hours, but later on you will see how the data. But this is a this is wild type, and CBS means, remember I was saying cystathionine beta synthase, that's the enzyme, and it's heterozygous. So usually we have two copies, father and mother, but this mouse has only one copy. So that means it already has high homocysteine. So it will have blood pressure, but whether nocturnal or not nighttime or not time, that's how I'm going to show. And comparing this wild type to this wild type and CBS knockout. So this is the data from the previous slide. In wild type, the blood pressure in wake and sleep, dipping, and it's significant. But in CBS, remember CBS already have high homocysteine. CBS, we have shown unequivocally and many other levels shown. CBS are a little bit moderately hypertensive. But sleep time blood pressure is not as different as here. So it shows that in those mouse, sleeping time was not as dipping as it was in normal. So our hypothesis based on this slide, and verbally here, that what we want to do, the activation of this SAHS enzyme, which enzyme hydrolyzes homocysteine from methionine, it can cause sleep and dipping and cause cardiac remodeling and heart failure. Remodeling is by all nature is designing the tissue when we restructure and remodeling. And the heart failure, I'll measure the physiological parameter in the diastolic systolic function. So we'll have two aims. One is a remodeling aim, again just structural aim, and one is a more functional aim. So this is that's a model we use. So what we do, usually mouse sleep in light when there's a light. So it's other way like human. Human is sleeping when there's dark, but mouse sleep when it's light. So, but regardless, I just call them wake and sleep. So what we do them, usually we have 12-hour light or a day, but in these mouse, what we just make them stress. We can keep them dark for 20 hours, so they are just walking, waking, only 12-hour night. So they sleep only 4 and 8. So this is a stress situation. And then we measure all the functional and structural parameters. So this is the data. This is the preliminary data on these mouse. And again, wake mouse, male and female, wake 24-hour blood pressure, wake sleep, wild type, wild type mice, 54 blood pressure, wild type mice sleep, wake, then cystathine beta. Remember, this mouse already have high homocysteine, and it's 24 hours sleep and wake. You can clearly see that wild type sleep and wake has nice, blood pressure that's active because there's a GABA activation, so there's blood pressure. But here, this blood pressure is not different. They're high and it does not change with sleep and wake. Now, same thing happened in female, but a little less extent than male. So both male and female, similar way, there's a blood pressure with homocysteine, but it's not different when it is high homocysteine already, and male and female are similar way. That's it, again, just to show up, because I measure some mitochondrial enzyme called CK, creatine kinase, and this is a whole cascade of energy metabolism in the mitochondria. You know, all the glucose pathway was pyruvate pathway, but fatty acid, heart is more utilized fatty acid than glucose, and this is one enzyme involved. And there's some amino acid also involved to making ATP. But ATP is cyclic, and this enzyme we measure, this is a marker of how weak or strong muscle is. And this side shows all the epigenetic aspect of what I was telling, the opening of chromatin and compacting chromatin, that this is all enzyme involved in this pathway. So this is first data showing the CK, creatine kinase activity, a marker of muscle injury. And you can see here the 24-hour blood pressure, 24-hour injury wake has more because they're more active than sleep. And this is all male and wild type. So this is a normal situation, and the same thing in male and female. But in homocysteine mouse, you said you have a little bit less change. I mean, more change as compared to, you see here. This here, this you have less, but if you see in this one, you have more. So when you already homocysteine injury, you compound more in those mouse, and it's similar. I mean, it's a little bit different, but not much. But both male and female, we have similar way. This is the structural part. Remember, MMP, matrix metalloproteinase, we design and restructure the connective tissue or the laminin in the nuclei. Now you can see if we use different substrate, there's a substance called gelatin in the gel. It's not like you're an SDS gel. If you put casein, based on this substrate, you can differentiate which kind of MMP it is. So with gelatin gel, you can see MMP 9 and 2. With casein, you can MMP 9, 13, remember, or 1 in human, and ADAMTS1. So they're all similar. But the biodata showing that in male, sleep and wake, this MMP 9 goes up, and it's more goes when you have high homocysteine, and both male and female. But in male, MMP 2, all similar way, and same thing in MMP 9. Then we have a different other substrate. Here we try to measure this enzyme called NGEL. NGEL is a neutrophil gelatin associated lipokaline. It's a new enzyme. It's a marker of a lot of inflammation or regeneration tissues. And incidentally, we can measure this on top of gel because due to the lipokaline, gelatinase don't go into the gel as usually MMP 9 and 2 goes. So it stays on the top of the gel called NGEL and MMP 9 here, and same thing here with casein gel. And bar graph showing the next slide that male and female, wild type sleep, wild type wake, again because they are more active, and the same thing is CBS, which is high homocysteine, and female, similar way, and homocysteine. In fact, in those mouse, homocysteine level in wake and sleep, in sleep a little bit high, but in wake was less in male and female, and same thing here. So to see direct effects, so we're knocking out the gene of SAHH. So to get SAH, we have a Cree mouse, and with the flag with this SAH mouse, we crossbreed, so we can knock out this SAH gene and use these mouse compared to, we use one drug also which inhibits SAH, but just to show direct effect that if you knock out this gene, you'll have a less abrogation, sleeping and dipping pressure. And this is just a characterization of these mouse. Knockout mouse and the Cree control. In Cree control, you have all normal SHH, GABA, and MDA. But in knockout, we knock out SHH, and GABA was increased, and NMDA was decreased in this incident. And in the DNA methylation and BAL1, they were all both improved with knocking out, and numbers shown here. So first thing we measure again CKBB activity is in neuron, and you can see the sleep when we sleep deprived. This is a knockout mouse. I mean, this increase control. Sleep deprivation, it has a more injury to the neuron. Now, when a knockout and sleep deprivation, that injury has been is reduced by the marker of CKM, creatine kinase. Same thing MMP. Now, here crazy control, you can call it wild type, but it's a crazy control. Now, a sleep plan dipping, you can see MMP goes up. With knockout and sleep deprivation mouse, you don't have that much activation. Same thing with MMP13 and ADAMTS. And MMP12, here we'll use gelatin. Gelatin it can recognize metalloprotein, which cause special degradation is elastin. And you can see here, again, in sleep deprivation with Cree control, sleep deprivation goes MMP12, which is going up, and with knockout is mitigated. Now, here the cardiac hypertrophy is based on heart weight and blood pressure. And you can see SD1 means 2 weeks sleep deprivation. This ST2 is 4 weeks sleep. So both way, you can see chronic increase in hypertrophy in this mouse. But if you use knockout at 4 weeks, you can mitigate this hypertrophy in this mouse, which is hyporecardic muscle. Now, blood pressure in control, you can see wake and sleep. You have a nice difference in the male and female. Now, control blood pressure and deprivation blood pressure. But in this female, you have more better dripping. But this in SH knockout, sleep deprivation did not, in fact, much compared to this. So it was less in this. The deprivation was improved with this with knockout. Cardiac hypertrophy, I show the structural aspect, and I mean there's not robust, but there is a fibrosis, especially the perivascular fibrosis. When we 4 week sleep deprivation, this mouse, so there's more perivascular hypertrophy. Maybe it's more constriction of the vessel, and maybe causing the blood pressure. But again, wild type and sleep deprivation in the wild type. But in SAHH, you don't see that much blue. Blue is marker of fibrosis, and you can see here compared to here, there's less. I mean, not very obvious, but there's less, and maybe we might have to go a little bit more. But there was a fibrosis when you have a sleep deprivation in this mouse, and it was mitigated when we use a drug. This is a drug for inhibitor of SHH called aldehyde dehydrogenase. It's an inhibitor of this SHH enzyme. So both knocking out plus using drug, we can mitigate the structural remodeling in this mouse by sleep deprivation. The cardiac echo, again, this is when these two join together, there's a systolic good function, and there's more gap. But if they don't join, there's a systolic dysfunction. Both join is systolic, cavity is diastolic. So both systolic and diastolic function were bad in these mouse when you sleep deprivation. With ejection fraction, you can see the number here. But when we did knockout did not have as bad as this, and with the knockout with this sleep deprivation plus inhibitor, we can mitigate a little bit, again 4 weeks, so we might have to go longer. But cardiac function was also improved, which was associated with SASH inhibitor. So in summary, what I have shown you, that inhibition of SHH can mitigate sleep and dipping in blood pressure, such as nocturnal hypertension, and it can also mitigate the cardiac remodeling got induced with sleep deprivation and nocturnal hypertension in those mouse. And in summary, maybe we can use some of the people who have hypercholesteremia, diabetes, hypertension, and they have more chance of having this. Maybe we can put some aldehyde dehydrogenase to inhibit SHH, and which is safe, so it might be avoiding the nocturnal hypertension. I mean, this is not my group, but this on weekend I play with these folks here, and they're all good people, and I like it. Now, by the way, this thing, you got to be interested. I have a question. If Alzheimer is a beginning of incarnation, because when we die, we lose the memory. So some people use slowly, some people right up when they die. So maybe And because there's an incident, some baby born and they recall their old history. So recently this artificial intelligence, if we can put these data, all this incident we see on Google and all these things put together, maybe we can find a mechanism how the reincarnation is happening. I mean, that's artificial intelligence and also some of the documentary of this, some baby born and they recall their previous life and put it in regard, so that's just the idea. Thank you very much.
Thank you, Dr. Tyagi. Maybe, the Alzheimer's is the new beginning rather than reincarnation. And anybody can ask one question to Dr. Tyagi before we break for the lunch. Okay, if nobody is asking any questions, we'll stop here. Thank you, sir. And
Thank you, sir. Now we would like, sir, excuse me, sir, please. Now we would be felicitating Dr. Tyagi. We would also like to thank our eminent chairpersons who have seamlessly conducted the session. We'll now break for lunch and we'll resume the session in 20 minutes. Thank you, everyone.
A very good afternoon to all of you. I welcome all of you back to the post-lunch day 1 session of IPSCON 2025. Our next oration session is Colonel Ramnath Chopra oration. For this, I would like to have the chairpersons on the stage. Professor Dhalla has taken his seat over here. I would request Professor Babul to please take his seat on the dais. Colonel Sir Ramnath Chopra, revered as the father of Indian pharmacology, was a pioneering medical scientist whose vision established pharmacology as a rigorous scientific discipline in India. A Cambridge and London-trained physician, his transformative work began in 1921 as the first professor of pharmacology at the Calcutta School of Tropical Medicine, where he modernized the scientific evaluation of indigenous medicine. A champion of self-reliance, he founded the Drug Research Laboratory in Jammu and served as the founding president of the IPS in 1969. The Colonel R.N. Chopra oration honors his enduring legacy of scientific excellence and national advancement. I would now request our chairperson to introduce the speaker, the orator for the day, Dr. Gautam. Over to you, sir.
Okay. The third oration, Colonel Ramnath Chopra oration, will be presented by Dr. Gautam Palit. He is the Profession Head, Department of Pharmacology, Saraswati Dental College and Hospital, Lucknow, and former Senior Deputy Director, Scientist G, and Head Pharmacology Division, CSIR, CDRI, Lucknow. With over 4 decades of expertise in neuropharmacology, gastric pharmacology, and stress research, he has made significant contributions to drug discovery and translational pharmacology. A recipient of prestigious awards including the UMBAS Gold Medal, IBRO and INSA Fellowship and ICMR Oration Award, Dr. Palit has authored over 100 papers in leading international journals and developed a patented anti-ulcer compound currently under commercialization. Before we start, Dhalla sir want to speak something about a little bit about Colonel Ramnath Chopra.
I think with Mr. President, I am so honored to be with you in this for conducting this session, Dr. Palit. I believe that you are one of today's most lucky man to be honored with a Colonel Ramnath Chopra oration. And I tell you why. You see, Colonel Chopra was the first person in India who laid the foundation of pharmacology. First person. A book which he wrote for the Indian herbs, it was a very nice. He actually thought that it will be nice that Indian people should produce something out of these herbs, because he believed in that Indian medicine, our ancestors used to use the various types of herbs, and there is something big in that. I think I wish the government of India should pay more attention, and the government, the young people should to undertake the challenge of that things. It's a very nice, so we are truly honored that you are receiving such a recognition. Thanks.
Thank you.
Dr. Palit, please proceed.
Thank you very much for your kind word, and what I really happily appreciated, because I am honored to stand before you to express my view about the topic. Before I go about it, I would just like to say about the when I start my career in pharmacology in KGMC under Professor K.P. Bhargava. He is one of the pioneer neuropharmacologists, and beside that, he was one of the founder members who have established the Indian Pharmacology Society. With this, little bit about the work which I have done it, and what work I have done in the case of Indian medicinal plant. Already we have heard so much about Professor Ramnath Chopra, and we already has been told that he is the father of it, and his only aim was that we should have the was that you should be self-sufficient in drug resources, because before that all the drugs which we were getting were all of European drugs. So he was the most interested, his work was more on Indian medicinal plant, and his vision was that we should be self-sufficient in more than 300 books he has published, and number of books, papers, along with the books he has, the glossary of Indian the plant, medicinal plant, all things. And what I think I may tell you that he was the honorary physician to his Majesty King George V of the Great Britain in 1935. Beside that, he received knighthood in 1941 from King George VI of Great Britain. And beside that, he was a president of Indian Science Congress, which was held in Patna in 1948. He established the institute that is known as Regional Research Laboratory, which is now renamed as the Indian Science Institute of Integrated Medicine. As already told by just now, that he was the founder president of the Indian Pharmacological Society in 1969, and Chopra Memorial Oration in 1956 was instituted. I am quite lucky, I may tell you, that in my career to have this, deliver this lecture. And his birth on 17 August was Sunday as a National Pharmacology Day, and Indian Post and Telegraph issued a stamp in 17 August 1983. And what we see that in the last 40 years, still we remember Professor Sir Ramnath Chopra with great honor, and everybody, whosoever you ask, they have some knowledge about this, such a learned person. With this, I am starting my career. And my topic, little bit about the work which I have done. Now, when we have started it, in 1973, I was a student of Professor K.P. Bhargava, and that time we are trying to find out the receptors, central receptors in the vomiting, and we do the operation in the dogs. Ablation of the CT zone was done. My time is 60 minutes, na? 60 minutes? 40? Okay, just because okay, fine. Now this, so I will cut it short. So this was done, and we tried to find out the histamine receptors in the center, in the vomiting, the thermoregulation. Then we shifted my work in the CDRI. And at that time, we are working on to study the behavior effect of primates, the rhesus monkey in the social colony. Both the social solitary behaviors were observed, and this is like a zoo type of atmosphere was there, and with a camera, rotating camera was there, something new. This is, I just want to tell to the youngster that time we are working on the rhesus monkey to study the behavior in the colonies of this thing. And there you see, this is another thing where the monkeys were seen, and there is a very typical behavior observed in the monkey that time. Always the female used to stay together, and then we try to see the effect of different CNS active drugs in the monkey, and this was the only lab, I think, where the social colony were there. And here how they are drinking the water, I am just showing you something which is. Then further we start studying the MPTP-induced Parkinson's model in the monkey, and you see the rigidity of the monkey. We are standing nearby, but they maintain it. For close observation of the monkey, we put a camera, we observe from the next room. So these are some of the work which I have done in CDRI. Then we come to establish of a neuropharmacology lab in CDRI, so that we can not only study the CNS active drugs, but the models anxiety model, depression model, schizophrenia model, and Parkinson with using different parameters. Different instruments were used for gross behavior, for depression, for anxiety, and we try to find out the mechanism of action by doing the brain section, the neurotransmitters level. And one of the most important model which we have studied that time to develop a chronic psychosis model in the rodents. Because there was no such model for there, we do only, because we are quite familiar that the schizophrenia has a positive, negative, and the cognitive disorders. So, positive you can show it by these behavior parameters. But so what happened? We take the ketamine. This is a dissociative anesthesia, and it has been observed those who are given this anesthesia, they have a psychosis type of symptom, or they aggravate the psychosis. So with this lead, we start with a chronic model to develop it and then see it and then study the different drugs, whether and this model has well established. With this, now I come to my topic. As I have told you, that is the drug discovery, novel approaches in development lead from Indian medicinal plant for peptic ulcer disease. Now we are quite familiar that disease, the peptic ulcer is the most prevalent disorder with multi-factor etiology affecting 10 to 15% of the population. Besides that, it has got a number of complications and 15,000 more people died. It is the died is due to the infection, either perforation or bleeding, which take place in the peptic ulcer disease. And so there is a strong need of major therapeutic strategy. And what happened, we see that whenever there is a pathophysiology of the peptic ulcer is a disbalance between the aggressive factor and the defensive factor. And that's why we suffer from peptic ulcer disease, and there is a aggressive factor goes above. And what we observe is that the thing which we have observed, that the aggressive factor, when the acidity, the pepsin, and there is a H. pylori infection is there, followed by decrease in the defensive factor. So our aim is that to decrease this parameter and increase this parameter so the patient can suffer. And what we observe that when we do a endoscopic examinations and for putting the pipe into the stomach or into the esophagus, duodenum, you can see this is white patches, which shows there is an ulcer develop in the, when the patient, we do it, and we observe this thing is there is a very marked ulcer is present in this. So we try to develop this type of model in animals to find out the healing. And here when this probe goes further into the duodenum, there you see this type of lacerated wound is seen. With this we further go to it. So what is the problem? Why we need an indigenous drug? There are so many side effects with these two limitations in the clinical observation. With H2 receptor antagonist, there is a rebound hyperactivity, relapses take place, and the proton pump inhibitors, there is a chlorhydria because there is 100% decrease in the HCl. So there is a bacterial overgrowth and the development of the diarrhea. Now recently it has been observed that those who are taking proton pump inhibitor for a prolonged period of time, what we observe is that they produce, most important is that, you know what happened there, if you ask any patient, how have I been taking for the last 6 months? Doctors has told me I am taking, I am quite okay. But they never think that all of a sudden they go to the bathroom and there is a fracture. There is a fracture is there, so such important increased risk of fractures. Low serum magnesium level, there is a muscular spasm, all this thing take place. There is a vitamin B12, and recently it has been observed that there is a worsening of the developing of chronic kidney disease. So we have to be more precaution if the patient is a patient of CKD. With this, so in order to overcome this advanced effect, investigation has been extended for search of a new and a novel molecule from Indian medicinal plant, which can show better protection with the lower rate of incidence of relapse. With this aim, and we are quite familiar because previously I was working in the CDRI in the Department of Pharmacology, and our aim was to find out a plant's original drugs. So CDRI is working toward the establish of a scientific basis for the use of indigenous plant in various clinical condition, and we have identified a number of Indian medicinal plants showing anti-ulcer activity in the preclinical stages. With we will go, and we are quite aware that the uniqueness of Central Drug Research Institute is that every factor, every department is there under one umbrella, from botany to the post-market separates, pharmacology to your computer chemistry and the natural medicinal chemistry. So all things are under one department. And we are quite aware that when we get a plant, it's a very basic thing. I know that lots of people know it. But for the youngster, I may tell you that not only that you take a plant, you make a drug. You have to go different parameters of it and how to do it. We start with the collection of a plant. The botany department, they collected, there is a botanical authentication, the voucher maintain is done. Then the extraction was made, a different type of alcoholic extract, then bioactive extract, then bioassay guided fractions and active principle were identified. All these things are tested in the biological screening, different models, both pharmacological and the biochemical and the molecular mechanism you have to try to find out. And then screening is done to find out, and then further when the active molecule is come out, that has to be tested for different. So we do it, and then the drug development and preclinical studies are carried out. Now, our aim should be when you are studying with the Indian medicinal plant, that the pharmacological class of test drug must be identified. Second is that mechanism of action, whenever possible, be established. Both pharmacological, molecular, biochemical, you have to find out the mechanism, how the things are occurring. And the third thing is that comparative studies should be performed with reference standard to determine the potential advantage and the disadvantage. You are not making a me-too drug. Your aim is to make something which is superior to the previous drug, superior to having no side effect, and is more powerful. So with this aim, we do is it. Now, how we proceed? In pharmacology, for screening of a drug for peptic ulcer disease. Now, what happened, you see, the scientific basic of anti-ulcer drug is that we start with the ulcer model, and in ulcer model, you have to do it in a number of model, like cold resistant ulcer model, pyloric ligation model, alcohol-induced ulcer model, aspirin-induced model, and histamine-induced duodenal. So we covering both the gastric and the duodenal ulcer model. We are having two animals, rats and guinea pig in this model. When we have tested it and we find out the score, I will show you. Then we do the parameter to examine the alteration in different ulcer model. And with this, what happened? We do gastric pathology, where we score is done for the gastric ulcer model. Then we do the acid security, because acidity play a free acidity, total acidity, pepsin is involved. Then we try to find out the role of proton pump inhibitors, whether they are able to have effect to cure it. Then we stool because histamine is also play important role in the gastric secretion. So gastric histamine level, the plasma gastric level. Then we do the mucoprotective effect, because aggressive and defensive I have told you, and there we see the mucin estimations, then followed by prostaglandin estimations which play important role. Then we do the, then we come to the chronic gas ulcer model for healing purpose. And in this, you know that you have to develop the model first. When you are confirmed that like a human being, the ulcer has been developed, Then you challenge it with different drug in different different days. You sacrifice animal and measure the percentage of healing take place. So we do the chronic gastric ulcer model in acetic acid induced ulcer model. I will show you the diagram. Then we do molecular label. And in this molecular label, the first is the inflammatory marker, the molecular target, then expression analysis, then pro-anti-inflammatory cytokines, the growth factors. These are the parameters to study how they are mechanism of action. In the expression study, gene expression study is done where we do the pro-inflammatory cytokines, anti-inflammatory cytokines, and COX-1 and COX-2. Besides that, the growth factor play an important role for healing. So whether they have any role in the ulcer, so we do the protein expression by the growth factor, epithelium growth factors, the vascular endothelium growth factor, and basic fibroblast. So these are all studied. It's not necessary that you have to do everything. Your screening method should be a primary, secondary, and tertiary. As per your demands, you can see, do you not have to come. If you having interesting data, you go on increasing your parameter to find out a paper, and there is a collaborative work should be done. I know that my limitation is there, but if I make a hand this way, I talk with the histopathology, I talk with the electron microscope, and then we study the chemistry and all. So you will have a very good paper of good impact factor. Now you see, now here you see that the normal stomach, when we open it, here you see. On the other hand, here you see this ulcers, red blood is there. This is the cold Western model is there. Then you see the alcohol index. This red band you can see, these are the hemorrhagic band. And here in the acetic acid model, when you compare in the same rat, we do it. I am not going into detail. Here this is a normal. On the other hand, this ulcer, which I have shown you in the human being, and the area of hemorrhagic lesion observed under tricolor stereo zoom microscope and measured by a BIOS image analyzer. So this is the way that this thing is done. Besides that, what we do is we do the histopathology. One thing is okay, the ulcer this there. Then you have to find out the histopathological and to see whether how much the erosion of the mucosal and submucosal take place. Now here if you see the normal, and here you see the rupture of the mucosal and submucosal area, and there is, so it proves that and how much take. So this is the histopathological changes. Then another condition, very important is the reflex esophagitis. That is a burning sensation. Sometimes you take a chili food or something, you have a burning sensation. Or there is a salty water come out, or there is a chest pain, and we cover it into a cardiac arrest or something. That is the reflex of the acidity take place in the esophagus. So there we do the same parameter. Here you see, this is the, here you see. There is a band of this take place, which is a very common and very notorious disease, reflex esophagitis in human being, and sometimes it occurs in the night time, and you have to take this. So we developed this model also, and then we challenge with the drugs which has got an anti-ulcer or something, and here we do. And the plant identified with anti-ulcer activities, or the different plants which we have gone through our institute out of this, and beside that we have also studied the plant from the CSI coordinate program. And one about the Ossimum sanctum I want to tell you. I have got 40 minutes, na? 40 minutes, okay, fine. Huh? 20 minutes, okay, fine. Then I can ever the what is the likely, okay, fine. These are the plants which we have already identified, and we publish a paper to find out the mechanism of action. Different models were used, and we compare with omeprazole, which is a standard anti-ulcer agent, and the graded doses of Ossimum sanctum, which has a very powerful medicinal properties were tested, and what we observe is that they have a very good effect in the different acute model of peptic ulcer. Then you can see yourself appreciate that in the, if you see this, this is the normal ulcer regions, and when we pre-treated with Osimum sanctum 100 milligram per kg, they markedly reduce. They markedly reduce the hemorrhagic bed, and so it shows that they are effective in the ulcer model induced by alcohol. Similarly, in chronic model, you see that we develop a model of chronic, and after 10 days, when you are sure, on the 10th day, we sacrifice animal and want to see how far. This is the ulcer region in chronic, and here you see that they have reduced, and here also they have reduced the omeprazole, which shows that this has got an effect not only as an anti-ulcer, but as a healing effect also they reduce it. Histopathology, we have done it, and there you see that their tissue is regenerating and they are able to see it. Similarly, we studied in the proton pump also, and it has showed a significant inhibitory effect on enzymatic activity of proton pump, and it shows that they have effective on there also. Then the expression studies we have done, and what we have shown, there is a down regulation of TNF alpha expression on the chronic ulcer model at 10 days. Similarly, the upregulations of the growth factors, and there is a upregulation of, here you see, when you compare it, there is a upregulation of this thing take place. And beside that, we try to find out our medicinal chemistry group. They are very dedicated scientists and CDRI. They give not only the extractions of the different, they try to find out the structure, which I have told you how they do it. The structure of the Osimum sanctum which shows a very powerful effect. We are able to identify the compound, and their formula was done. Another very interesting, just one word I want to tell you, that CSIR has got a program where 10, 11 plants were used. Then we reduced it to 5. And then we studied in different models to see it. It is a all India programs was done. And significant increase in the mucin secretion. They significantly inhibit the effect of enzymatic activity. They have a molecular mechanism of action by downregulation of the pro-inflammatory cytokines and upregulation expression of the epithelium growth factor receptors were done. And most important thing, which when you are doing with the plant, is that the TLC, that the thin layer chromatography profile of different batches collected over 6 to 7 seasons from 2 geographical regions indicates similar characteristics. That has to be done. Not only that you take it a plant and you see, and every time, every year, the geographical, there is a different character of that plant. When the seed is take place, when flourishing is take place, so you have to take it and to identify whether they have got a similar and in the different regions of the geography. That has been done with the help of the TLC. Then we done the safety regulatory studies. We indicate wide margin of safety, toxicity studies, no adverse effect. US patent granted was done, and we received the US granted. We identified the IND, and RDA Vatsala Kerala has taken this product for commercialization and marketing. So this way the graph goes from the collection to identify it and to find out the things. This was the things we done it. Now still I have got something I would like to tell you. Now what happened? Another area which I have not touched just now is that the role of plant in the different stress research. We are quite aware that stress is playing a very important role nowadays. And the stresses can be anything. It may be insomnia, it may be a financial problem, unemployment, disagreement, loss of loved one, from weather, chronic illness, and all these things take the biological traction, and followed by that lead to any disease you mentioned. Now everything come to a conclusion that it is due to stress. It may be a diabetic, it may be alopecia, loss of hair, to cardiac problem, anxiety, depressions, the skin conditions से लेकर के asthma. So all conditions is led to the different stress disorder. So why not we find out something adaptogenic activity? So we again do it. We have studied it, the plant identified with anti-stress activity. Again we take the Osimum sanctum, Brahme, the Bacoba manura and other plant identified of anti-stress potential of Osimum sanctum. The extract, the fraction, a pure compound were identified whether they, and we go into a detail. Now, if you see this diagram, the Tulsi was taken. We start with the ethanolic extract, and the graded dose was used against the acute, I will tell you, the acute and chronic. Then fractionation was done, and in the fractionation, N-butanol and aqueous, this was inactive. The butanol was effective in the dose of 200. Then we further isolated, and at the 1/4, 5th dose of it, at the different compounds were studied. Out of this, 2 were have a very good anti-ulcer, anti-stress activity. Now, what happened? You see, if you go through this plan, and I'm just telling you that you can do it. There's nothing, anything, and it is a very potential area. Start with a small, and then start with using the plan of work, evaluation of anti-stress activity and the mechanism of lead molecule form Osimum sanctum. Now, what happened? We do it in the acute stress and chronic unpredictable stress. Chronic unpredictable stress is very important in the sense that we don't know what will happen next. You are going, there is a traffic jam, you come to home, there is no light, and something, you go to office, your boss misfire you. So these are the things which is unpredictable. So acute, we know, some stress, we know, yes, my boss will say something every day. I am prepared. But if you have something which is changing every time, that is unpredictable. And this, so were the unpredictable. And the parameters were studies, both the peripheral and the central one. We start with the gastric pathology, then adrenal hypertrophy take place, then we do the plasma glucose, plasma cortisol play a very important role, then the neurotransmitters level, the oxidative stress, the protein express gene express. Some of them we do it by HPLC, UV, and with the EC factor. So you can give it an idea about what are the neurotransmitters are involved and what are the metabolites playing and what is the crosstalk between the various neurotransmitters, which is abnormal. I wish you see my paper, some of our paper, and you will able to identify it, and you please, those were the youngster I may tell you, this is such a burning topic. You try to develop it and do something, whatever, and what I think is the best is the corporate, collaborative work. If you do not have a HPLC, EC, it's a very, you contact with somebody like CDR or something or other, where they are doing it. So that will be collaborative work for them. Or you don't have a electron microscope or something, you go with them. I also work, I talk with the pathology department, I talk with them. So your paper, your weightage of the paper will be very high. You will have a good impact factor when you are combining all this thing. So this is the way that we do it. And from there we have identified the structure of Osimum sanctum, which has got a adaptogenic activity. And whatever you see that the structures were elucidated and confirmed by spectroscopic technique. It is my colleagues who are sitting on the other side of it, and they have done it with the ultraviolet absorption spectra, infrared spectra, NMR spectra, mass, and these are the factors where they have done it, and then they do it, all the structures were taken out. So this is way we proceed in our lab. Now comes to the, now we come to the last portion of it, the lacunae of the existing knowledge. roughly 50% of the new chemical entities introduced during the last 2 decades are from natural products. Despite this success, research into the natural products in the pharmaceutical industry has declined, still looking for as holistic rather than scientific. If you see that every 3rd day in paper, there is something published, that some new drug has come out for the anti-cancer or something cancer or Alzheimer or something that, whether they are such a fruitful. Why there is a failure? Why it is not coming? They publish it in the paper and we are very eager, and the layman don't know anything. They are saying that something has come out and they will run after. The bone healing take place or something like anything. So still looking as a holistic rather than scientific manner. Challenges in natural products based on drug discovery is that inadequate documentation. We don't have a library. Identification and authentication. Purification and identification of active compound is quite laborious and non-cost effective. Improper purity assay. We do not know how much is the contaminated the prestige dyes along with the this microbial contaminations with assay studies. And GLP is good laboratory practice, good clinical practice, and heavy metal detection. Number of plant you have seen that it has gone to USA and it has returned back because it contained heavy metals. Because that was not studied properly. Neither they have studied the purity of the compound, the ash was there or something, microbial was there. So that is most important. Insufficient quantities of the pure compound to meet the market demand. So naturally you go in a shortcut way. Lack of quality control and standardization. That is also very important. We don't have very good labs everywhere. For a promising future, what I think, it requires a multidisciplinary coordinate approach, plan scientific strategy at each stage of drug development. That is most important. Besides that, development of good agriculture and collection practice, GSCP, which is missing. You have to start from the root level, from where the plants are coming out, what are the cultures, what are the agricultures they are using, what are the pesticides they are using, is it free from any organic pesticides has been sprayed. So that is the development of a good agriculture and collection practice and GMP manufacturing practice, good compliant technology of drug production. It is quality control and self-life studies also is very essential. So we really need a high throughput mindset to do this broader spectrum of activity. If safe and effective herbal formulations are developed in accordance with the stringent regulatory guidance, we hope that the convenient skepticism against herbal may slowly win. We have a very bad idea, I may tell you. We have a very bad idea. Some लोगों के अरे ठीक है कोई बात नहीं है अरे करने दो. But we have so much potential of Indian medicinal plant, and they are far better off the. So this is as global market demand. A standard of international standard, Indian medicinal plant may offer new drugs with enhanced performance in terms of cost, safety, and efficacy. So thus, this is the last slide, thus the Ayurvedic knowledge supported by modern scientific approaches is necessary in isolation, characterization, and standardization of active constant from plant source. And last, you see that if you see this slide, the right approaches to drug discovery is there should be a very good partnership between the academia and the basic evidence-based research, along with public-private partnership, which is a very important, and then the drug research. So there should be a relationship between the academia and the drug industry, along with the basic evidence-based research, and public-private partnership. And we have to take care of marketing. You maybe whatever research you do it. But if your big brother is not happy, so then your research will be flat. So marketing play a very important role to take your product to the market, to take it to public. So this is the 4-5 parameters if you go the right approach for the drug development. So my journey starts from King George's Medical College, where I have started my career in 1973 under the leadership of Professor K.P. Bhargava. He is a world-known figure as a neuropharmacologist, and he has taught us everything. So I cannot know how many, and one thing I may like to tell you, he was the student of Goodman Gilman. We read Goodman Gilman, and he has done his MD and PhD from USA, and he teaches us everything. So what I am today is all due to the Professor Bhargava in King George's Medical College. Then I shift to Central Drug Research Institute, old, then the new, and at present I am a professor head in the Saraswati Dental College and Hospital. Besides that, I have been linked with the Sanjay Gandhi Postgraduate Institute of Medical Sciences. For the last 5 years, I am in their ethics and other committees, and also I am in the ethics committee of Indian Institute of Medical Research, ITRC in Lucknow, where we do some contributory ethics point. So my acknowledge is my two partners. First is the medicinal chemistry. Those who has helped, they're isolated, they find out the structure. These are my all students. They play a very important role. And what I think, these are all my students. What I think myself, I got this chair to sit is all due to my postgraduate students. Either if they don't do the dedicated work today, I would have not done anything. So I give my full credit to my students for their dedicated work, and all are in the top universities, top places in the world. So I again repeated that it is due to them I am getting and sitting in a chair. Thank you very much. I think we have, and thank you. This is our Lucknow. Please do come and have a Romani Dawa.
So thank you, Dr. Palit, for finishing before time. And really, it's a challenge in natural product-based drug discovery. Those postgraduate students who are present in today's session, they'll be utmost benefited by this lecture. I hand over the mic to Dalla sir for his comment.
Excellent. Very nice exposure of your science. I'm very pleased to see that. But I would like to, search your brain a little bit. Do you think that the one active principle which from a given plant you have isolated, or other people are isolating, maybe there in the same plant, there may be some other component present which modify, either potentiate or do modify or act on some other targets. Reason I'm asking this for you to let us know that that combination therapy is becoming more and more accepted, because most of the present available synthetic drugs act only on specific target. And disease is any given disease is a very complex process. So maybe one target may not be sufficient. Maybe in the same plants, this could have some other chemicals present there. Have you considered that? It's a very different type of thinking which I'm trying to search from you.
Sir, one thing, sir, I will tell you that we are able to identify one compound which has shown, when you compare with the other component, I have shown you the anti-stress. What it has showing the maximum effect. If you see that Brahme, also it is a CDRI product, and there were number of products, out of which the Bacoba A, was the most potential for as a Alzheimer or memory inquiry. So we compare with it. There also, there are a number of compound interactions will take place, all these things. But out of maybe some delay, so we identify it and we found that Bacopa A is the best one which has gone to anti-dementia. And that's why the drug has come out from there. And what I say here also that we are able to add, this is the just a starting pathway I am telling, that how to approach. And further work they can do, and that you are told me maybe that the other compound which is in the second line. And that can be used if it is failure, that can be done. So thank you very much.
Thank you, Dr. Palit. And for the information to the audience, this Colonel Ramnath Chopra, as is being introduced, for the first time in the history of IPS, we have started his birthday to be observed as a National Pharmacology Day. And for the first time, it was organized centrally in AIMS Guwahati this time. Next, Dr. Professor Hota has invited to observe it in AIMS Bhubaneswar. So this is for your information only. Thank you, Dr. Pali.
And one thing I may tell you that during my MD, there was a one question, half a question on scientists. And we have to read about Sir Ramnath Chopra, because in my MD also we have know that one question will be there. So that time I am talking about 75, 76. We have to read everything about the scientist, world scientist, and in which in India one, that is Ramnath Chopra. So I am honored to speak on his words. Thank you.
Thank you so much, sir. I would request the chairs to please felicitate our speaker, Professor Gautam Palit, sir. To felicitate our chairperson, I would request Professor S.K. Kulkarni, sir, and Professor Kavalji Chopra, ma'am, to join in. Thank you so much, all of you. Now we have a tea break for 15 to 20 minutes, and we are going to assemble again in the hall at 4 o'clock. Thank you, all of you.
Good afternoon, good evening, सत श्री अकाल. Please come in the front. आप लोग पीछे सामने आकर भी चैट कर सकते हैं. आइए सामने आइए सब लोग. हॉल बहुत बड़ा है, कोई नहीं दिख रहा है यहाँ से.
Welcome back. Our final session for day 1 is Symposia on Biologics and Biosimilars. This session would explore the cutting-edge landscape of biopharmaceuticals from clinical development to regulatory standards. Following our previous discussions, we turn our attention to the crucial interface between academia and industry. We have a comprehensive program lined up with 6 distinguished experts from the industry. To chair this session, I would request Professor Debashish Hota, clinical pharmacologist from AIIMS Bhubaneswar. Sir is current editor of Indian Journal of Pharmacology and he has worked in PGI Chandigarh for more than 12 years. Our next chairperson for this session is Dr. Yogendra Kumar Gupta, who is a renowned pharmacologist and former professor and head of pharmacology at AIIMS New Delhi. Dr. Gupta has contributed extensively to neuropharmacology, toxicology and drug safety and played a key role in establishing India's pharmacovigilance framework. So I request our chairpersons to kindly take their seats on the dais. Now I would request chairpersons to introduce our first speaker, who is Dr. Shubhadeep Sinha, Senior Vice President and Medical Director for Hetero Group.
No need for introduction, I am fine. I'll पढ़ लेंगे.
Hello? अब आ रही है? Yeah. Namaskar to everybody. And if somebody has to introduce to Dr. Shubhadeep, it's a very difficult thing because कहाँ से शुरू करें, कहाँ ख़त्म करें, ये एक difficult चीज़ है. So Shubhadeep is MD Pharmacology and he is a Senior Vice President in Hetero. And his expertise is what is called as a contemporary science, biologics and biosimilars. And if I say that maybe after 10 years, majority of the drugs, majority of the diseases will be treated by biologics. And of course, it is important to know how the biosimilars are made, what are the regulatory avenues for biosimilars, because I have been dealing with biosimilars and biologics in the regulatory perspective for a couple of years now. And the cost factor is one of the major important deterrent, and that's why biosimilars are being made. And today, any pharmaceutical company which is very progressive is making biosimilars, whether for arthritis, whether for psoriasis, or whether for any immunological disease, and for cancer, and every disease will be having an answer in biologics maybe after 10 years. So I appreciate Shubhadeep's effort to create this symposium on biologics and biosimilars, and he has been able to knit very effective speakers into this session. And I compliment, and he has also supported this, I understand, this Indian Pharmacological Society conference in a big way. So I would say we should give a big hand to Dr. Shubhadeep. Over to Dr. Hota.
Thank you, sir. Dr. Shubhadeep is a basically medical doctor having done MD Pharmacology degree. Now he is serving in the industry, and his area is, as Professor Gupta has said, biosimilars, biologics. So biologics will be the future drugs, but now India has progressed a lot, and although we are one of the largest manufacturer of variety of biologics, only few are very, very successful, some are partially successful. And now what are the roadblocks and what are the advantages, disadvantages that Dr. Sinha will present. And I request Sinha specifically to cut down your presentation to 30 minutes.
That's right.
Because of constraint of time. Thank you.
तो इससे पहले कितनी देर का था?
उतना ही था.
1 घंटे का? नहीं, 30 minutes is good.
30 minutes, yeah. So, thank you very much, Professor Y.K. Gupta sir, Professor Debashish Ota sir. It's a privilege standing here before both of you to conduct this symposium. I again feel like a student giving his viva presentation, and I always feel so when I stand in front of Professor Y.K. Gupta, whether professionally or personally. Now, why are we speaking on this? I'm going the reason, as they mentioned, that almost the top 10 of the drugs worldwide are biologics. The largest selling, in fact, the largest selling drug is also a biologic. Now, because the duration of development of biologics is very long, the costs are also very high, and that because it is becoming an essential drug in a lot of therapeutic areas, particularly in chronic life-threatening illnesses such as cancers, inflammatory diseases, immunological diseases. Biosimilars had to come where the copies of biologics, as they call, but not a true copy. That's why it's called similar. Had to come in to reduce the cost. However, as you will see that it's not that easy to even develop a biosimilar, because again the duration of development is also quite long. For this we have speakers. We have 4 speakers. The 5th one has not come, Dr. Praful. So what I am going to give you is a brief overview of how biosimilars get developed, what are the various clinical and safety considerations, and then Dr. Shefali will take care of the bioanalytical part. Dr. Soumya will take care of the preclinical part, and the new biologics called the antibody drug conjugates will be taken care by Dr. Pankaj Thakur. So I have actually 2 sessions, the clinical and safety, because the safety speaker has also not come. So I will take some additional time. Yeah, so anyway, so I'll try to keep it. So the key aspect of biosimilars is not necessarily to re-establish the efficacy of the drug. It is to establish the safety and comparative abridged efficacy data. So, but the safety becomes a primary goal for any biosimilar to be approved by the regulatory agencies. Now, the regulatory agencies are almost like the Game of Thrones. The reason being that they all behave differently. Same guidelines, different guidelines, same guidelines, different approaches, different interpretations. So, therefore, one study in any country will not suffice in other country. But one global study again will also not suffice in most countries, because there will be lack of sample size in each of the countries. So therefore, it becomes a very complicated task. And however, if you look at you can still divide the EU-like country, where the Australia, New Zealand, Argentina, Mexico, they all, if you have done studies in the EU, they are often accepted in these countries. The US-like country, the guidelines are similar, the US and Brazil, and in between, we don't know what is happening here. So Russia, China, India is now very well stabilized, because with the 2025 May guidelines, 2016 was also a good step in that category, but still there is a lot of unpredictability in these countries, but that's the rule of the law. Now, what are biological products? Biotherapeutics, these are active substances that are derived from biological source. Common terms you have heard of: hormones, enzymes, monoclonal antibodies, blood-derived products, and animal-derived products. But monoclonal antibodies are the targeted therapies, and that is the one where biosimilar development is also the most. Often used for chronic illnesses such as diabetes, autoimmune diseases, cancers, and certain neurological diseases, even for myocardial infarction. So what does biosimilarity mean? So definition wise, it means a version of the active substance of an already authorized reference product in the European Economic Area, where there is similarity in terms of quality, biological activity, safety and efficacy based on a comprehensive comparability exercise. Each term is important. Comprehensive comparability exercise means comparability through and through the development from the cell bank to the final, even in the phase 3 studies, everywhere there is a comparison against the reference product. In the US it is called a follow-on biologic, which is, they recognize there would be differences, but these differences should not be clinically meaningful. There can be minor differences, but they should not be clinically meaningful. India also calls it similar biologics, similar to what Europe defines it. Now coming to the most important biologics and also biosimilar is the monoclonal antibodies. These are large complex glycoproteins. So glyco and protein both are important in terms of characterization. However, this has two portions, the antigen binding portion and the FC portion, the complement binding portion, which is the effector function. These are the two important characterization endpoints. And then you have the safety endpoints where there are when the protein degrades, a lot of molecules get released. So there also characterization is required. This you have studied in the pharmacology textbook by the hybridoma technology. But when you, so I pity my son who's studying MBBS. In our days, it was much simpler to remember the names. So we have, say, pembrolizumab. By the time you forget what the question was. Now today, so many biosimilars with biologics with such names becomes difficult. But there is a way why the nomenclature has happened. You can see there is the source, whether it is murine or human or humanized. Accordingly, you have, if it is murine, it is OMAB. If it is chimeric, it is rituximab. If it is humanized, it is trastuzumab. And if it is human, it is adalimumab. So accordingly, there are some other portions, but this is the reason why such names are there. And then there is also subsystem circulation. Rituximab we mentioned, CMAC because circulation. And that's how the naming is there. Look at the market forecast for the 10 years. Europe were the first to enter into biologics, first to enter into biosimilars. They still lead and they will continue to lead in terms of the development. And oncology diseases are the most favored in terms of biologics and biosimilar development. Monoclonal antibodies among the other biologics becomes the dominant position. And then you have oncology, and then we have among the oncology you have the breast cancers, the solid cancer, the breast cancer is the maximum development, then you have the lung cancers, and then then you have gastric cancers, and among the liquid cancers, the blood cancers, you have CLL and NHL are the two most important therapeutic areas where biologics and biosimilars are getting developed. Biosimilars are developed after the product patent expiry. As you can see, so many products are undergoing product patent expiry. And 2017, if you look at all the products that are there, they all have biosimilars in India as well as worldwide. Similarly, if you look at 2025, certain patents are expiring, and all the companies have started developing all these molecules. And I'm sure Professor Gupta, in his role as RCGM, you would have gone through some of these molecules such as pertuzumab, which is one of the most favored molecule in terms of development. Denosumab, which is already first biosimilar will be launched in India, and then there are others. And if you look at the life cycle of development, a lot of time you have to find a equivalent host cell clone, cell bank clone, then fermentation, purification reaction, manufacturing scale up, and then characterization. The characterization part is the most difficult and most time consuming. where the quality of the product is, so the product is the process in this case. And then you have the non-clinical and the clinical entities. So the biosimilar programs, now the one big part about biosimilars is something called as extrapolation. So usually most of these products, especially in oncology, they have multiple cancer indications. In case of biological innovators, you will have to undergo phase 3 studies in all those indications. Whereas in biosimilar, you will have to take care of one lead indication, establish the surrogate efficacy, and then there is, based on mechanism of action and receptor, there is extrapolation to all other indications. And thereby, if you look at the development pathway, the clinical studies are minimum in biosimilars, whereas the characterization, analytical characterization is the maximum. It's a stepwise approach so that a totality of evidence is accepted by the FDA. So does EMA. This is the guidance where this guidance was meant for an affordable biologic for the US population. But then if you look at the US approval pathways, there are two pathways for a biosimilar. Either you go as a new biologic altogether, called the 351A pathway, where phase 1, phase 2, phase 3, everything has to be redone. But if you go by the 351K pathway, the biosimilar pathway, then highly similar to you have to show the high similarity, especially in terms of analytical characterization. You have also the EMA guideline, 2015 guidelines. EMA is typical for not only an overarching guideline, but also product-specific guidelines. And you can see there are multiple guidelines, and there are guidelines on the monoclonal antibodies. And this is how again, the Europe defines it as, you can see the reduction in the non-clinical, reduction in the clinical, and of late, the biggest thing that has happened is the waiver of the phase 3 studies in certain molecules. Complete waiver of phase 3 studies only with phase 1. And it has happened with pembrolizumab with two companies, Sandoz and Pharmacological, which is one of the most important landmark events of 2025 in terms of biosimilars. And there are other relevant EMA guidelines on immunological and non-clinical. This is the 2016 biosimilar guidelines of India, and then you have to 2025. The author is right there. The May 2025 guidelines, draft guidelines. So there is full chemistry and characterization data, physicochemical characteristics, biological activity, purity and impurities. Now, microheterogeneity, which means that when the protein disintegrates, the sulfur pairings, there is deamidation, there is oxidation, there are glutamine residues that will come out during the manufacturing process. That has to be kept under control and has to be characterized vis-a-vis the reference product. It must fall within the acceptable range, and there has to be batch-to-batch consistency. There's also aggregation, there is excipients, there is syringe, all of that needs to be seen. These are glycoproteins, so glycosylation becomes extremely important because it may affect the pharmacokinetics, safety, and the efficacy. And there could be even a new patent that might come out because of the glycosylation. But most important is the safety. And then we have to characterize the protein structure. As you know, it's multiple levels. You have up to a quaternary structure. Every structure needs to be compared against that of the innovator. So there's attributes relating to the amino acid sequence, secondary, quaternary, and tertiary structure, biological and functional activities, kinetics and thermodynamics of binding, quantitative levels of impurities, as well as stability, and then the properties of finished drug product. So all of these need to be done. Further, the target binding, target neutralization, complement dependent cytotoxicity, all of these needs to be characterized vis-a-vis that of the innovator. It's almost like a fingerprinting that is to be done against that of the innovator. Structural characterization, functional characterization, as well as activity characterization. So the critical quality attributes are defined for each such protein, and these are some of them. I'm not going to details of that, but again, then follow that with in vitro studies. These are very important, that the complement binding studies, these follow the ICH S6 guidelines. Tissue cross-reactivity studies are not necessarily required. Further, in vivo studies, In vivo studies are only required if there is no, the characterization is not complete with in vitro studies. Certain critical relevant quality attributes have not been detected in the reference product, but have been detected in the test product, or in different amounts compared to that of reference products. Further will be taken by Soumya on the toxicity studies, but then toxicity studies are still required. Again, there have been issues of waiver. Quality differences may affect the between the biosimilar and the innovator, may affect the immunogenic potential and potential to cause hypersensitivity. That's therefore it is extremely important to have a highly similar product and highly comparable product. Immunogenicity assessment is not predictive what is happening in animals versus human, but it can give much needed window that there is a possibility of, so therefore anti-drug antibodies are also one of the endpoints of the preclinical toxicity studies. Others which are required for new drugs such as safety, pharmacology, reproductive toxicology, mutagenicity, carcinogenicity are really not required because these have been already established for that of the reference product. Local tolerance may be required in some cases because these are the injectable preparations, and therefore some local tolerance is often required. Now this is an overall picture, but there are guidances in different countries. There may want more, some additional studies, and one set of studies may not suffice for every country. Now in case of clinical trials, biosimilar clinical trials almost is like a iceberg, the tip of the iceberg. When we do these, we do phase 1 and phase 3 studies. No phase 2 studies because no dose have to be found. Doses are already quantified. But they are in only one indication, limited data. There are, and thereby this cannot predict the safety of the product in a larger population. So for when we do extrapolation of indication, we have to be very careful. There might be differences in the efficacy between the indications. However, this is still allowed, and sometimes the questions are raised based on the mechanism of action. New immunogenicity data, when it is used in large population, real world studies have therefore becoming more and more important, and new safety data, new risks, and hypersensitivity nobody can predict. So it's like a tip of the iceberg when we actually get the approval of a biosimilar product, because most of the data will still needs to get generated in the real world scenario. So therefore, there is phase 1 studies, which is not really the phase 1, it is comparative PK studies. There is no single ascending dose, multiple ascending dose, doses need not be defined. Phase 3 studies, comparative clinical studies, which is again a comparative against that of the innovator, and then the phase 4, extensive phase 4 studies are required. However, no phase 2 dose finding studies are required. Equivalence and non-inferiority, both designs are acceptable. Safety studies, again, separate phase 4 efficacy and separate phase 4 safety studies are required. Pharmacokinetic studies, now depending on the product, you might conduct the phase 1 study in healthy volunteers or in patients, depending on the toxicity of the products. And however, healthy subjects are more sensitive to provide the differences between the test and the reference. In certain patients, certain biologics, you cannot do that in healthy volunteers, so you target use the patients. Because these are half-lives are very, very long, it is impossible to do phase 1 studies in a crossover manner, because you cannot completely wash out the anti-drug antibodies. Thereby, usually it's a parallel design and with a standard bioequivalence criteria. Some innovators have different product in Europe and different product in the US. So you may need a 3-arm phase 1 study, 3-arm comparative PK studies, and with large sample sizes. It could be a single dose PK studies. For example, in denosumab, we would only do a single dose PK, but in certain cases where there are chronic usages, bevacizumab, pembrolizumab, tocilizumab, there are long-term therapies. Thereby, you need to do a multiple dose PK as well for steady state conditions. Certain endpoints may be characterized, certain endpoints may not be characterized. Where it is characterized, that is, for example, VGF in bevacizumab, it's an anti-angiogenesis molecule. CD20, we know that it will act there and it reduces CD19 and CD20 values. adalimumab reduces IL-6 and TNF alpha values. This is characterized, this is also becomes one of the primary endpoints in the phase 1 studies. Often these are based on laboratory tests. Combined PK/PD studies can be done. So parallel design is the most acceptable design. I think the route of administration, the same route of administration should be there for biosimilar and reference innovator. So it could be either, so primarily it is the parent most sensitive route is a subcutaneous route, which is used for the PK comparison. It can also provide the potential PK differences that during the absorption phase in addition to distribution and elimination phases. And there is also sensitive, also important for sensitive assessment of differences in immunogenicity in PK. So the immunogenicity anti-drug antibodies are also secondary endpoints in phase 1 studies. Dose selection, most sensitive doses are used. Now if the study is in a patient population, we have to use the same dosage that we use in therapy. For example, in bevacizumab, the therapeutic usage is 5 to 7.5 milligram. If we were to do a PK study in patients, we have to use the same drug for PK comparison. However, if we use a healthy population, the lower dosages give better PK/PD comparison, and we might use a lower dosages. Example, even in adalimumab, the therapeutic dose is 80 milligram, but for PK studies in healthy volunteer, we use 40 milligram, a lower dosage which will have a better concentration effect relationships. This is an example of pembrolizumab where we have been told to do these studies in PK, a randomized double-blind parallel study. So there are two tumor types. There is malignant melanoma and non-Hodgkin cell, non-small cell lung cancer. Now we were told that the metastatic melanoma is more homogeneous population. Therefore, phase 1 preferred that in malignant melanoma. Now, phase 3 studies, most of these drugs are, as we mentioned, in cancers. So survival benefits are important for when the drug is being developed for the first time. So once survival benefit is established, for a biosimilar, it is the surrogate endpoint, which is the response rate, complete response, partial response, stable disease, etc. are the most important endpoints. Survival need not be again proved, again compared. So it is the surrogate endpoints which are there in the innovator study becomes the primary endpoint in the biosimilar study. There are various reasons why there are challenges in clinical development. Some of them have been highlighted, and those are the ones we will discuss. Then, because there are multiple indications, which indication to choose? The indication with the highest placebo-adjusted response rate. For example, adalimumab rheumatoid arthritis, it is also used for psoriatic arthritis. But rheumatoid arthritis is a better indication because it is a better placebo-adjusted response rate. In bevacizumab, again, there are multiple indications. Colorectal cancer and NSCLC are the best, most sensitive indication. They are chosen. Also, they are chosen based on the disease characteristics. Now, as I mentioned, bevacizumab is useful in both colorectal cancer and non-small cell lung cancer. India, colorectal cancer is better, so disease patient availability will be much better. The survival is much lesser with NSCLC, and thereby colorectal cancer becomes the most choicest indication for bevacizumab. Extrapolation is possible in multiple approved indication inside the therapeutic area. So one cancer extrapolated to another cancer. But in case of rituximab, which is approved for both cancer and rheumatoid arthritis, you probably have to do more than one study. That is a cancer study as well as a rheumatoid arthritis study. And always standard of care has to be the background therapy in case, and it is never the case that in phase 3 the drug is used as a monotherapy for comparison against the innovator. Also, primary tumors who are treatment naive tumors, they are better, provide the better efficacy and safe response compared to that of the relapsed tumors. So they are the ones which are chosen for the comparison. Now, immunogenicity again becomes very important. Most of these drugs are biological products. Definitely they will produce, they are expected to produce anti-drug antibodies. They are proteins, and the host antibodies will be directed against that therapeutic protein. There could be product related factors, treatment related factors, patient or disease related factors. This is very important because it is there in preclinical studies, phase 1 studies, as well as in phase 3 and phase 4 studies. Again, these will be taken care by Dr. Shefali. There are multiple analytical methods. Reference products, again, if there are 2 reference products for the same, rituximab is Rituxan in US, Mabthera in Europe, you probably have to do comparison against both the drugs in the clinical study. And although equivalence design is most preferred, but it often becomes impractical, and therefore non-inferiority trials are smaller in size, because the ultimate goal is to get the product quickly to market and at a much cost-effective way. So non-inferiority trials are smaller in size. It has to be defined well what is the non-inferiority margin. There are poor, so because these are long-term studies, there are difficult to retain patients, poor compliance and poor patient retention in long studies, patient consent. Why should they use when all the innovator products are available? In India especially, it becomes very difficult to consent such patients. High placebo response rate, certainly in rheumatoid arthritis, you might get a 30% placebo response rate. So in that case, we may have to look at alternate designs. Sometimes there is a patient-reported outcomes in rheumatoid arthritis, especially when the efficacy criteria are there. ORR is also subjective based on the radiologist interpretation, and thereby there is a lot of subjectivity in the nature of outcomes are non-optimal, and lack of coherence among regulatory bodies, rapidly changing regulatory guidelines, and standard of care also changed. So when we did the rituximab study, we had a CHOP chemotherapy as the background chemotherapy. By the time it got launched, mini-CHOP became the standard of care. Now what do you do in such case? So in phase 4 studies, we probably have to do additional studies with the new background therapy. Now this is very important. The EMA guidance on the tailored clinical approach on biosimilar development essentially means if there is a highly similar biosimilar with a very well characterized product, it has undergone the basic toxicology studies, it has undergone a very effective phase 1 studies, phase 3 waivers have been granted. And this is also shown in the US FDA guidance. Again, you can see that appropriately designed human pharmacokinetic study and assessment of immunogenicity may be sufficient to whether there are any clinically meaningful difference, which is the basic definition of biosimilar. And this is the recent, and this is a stream. So this has led to 2 companies, Sandoz and Formicon, getting phase 3 waivers in both US and Europe. And the product which would have taken another 3 years to get the first biosimilar approval has come in 2025. It was targeted in 2028. Thanks to these changes in the guidelines in the US and Europe. This is also there in Indian guidelines, this waiver guidelines. And however, it has never happened till date that it was there in 2016 guidelines, is there in 2025 guidelines, but it has always happened that we will had to undergo a phase 3 study besides the phase 1 study. Extrapolation of indications, main thing, if the drug which is active in NSCLC has the same mechanism of action in colorectal cancer, in head and neck cancer, you will get the extrapolation based on the studies which have been done till date, analytical characterization which has been done, and thereby those extrapolation of safety data, if it is, you can rationalize that, and extrapolation immunogenicity data which if can be rationalized. So it is there in even in Indian guidelines, it was there in 2016 guidelines, is there in 2025 guidelines. It is, so extrapolation is possible if there is similarity with respect to quality, non-clinical assessment, mechanism of action, involved receptors are the same. Phase 4 approval studies, phase 4 efficacy studies are required. as well as in India, post-authorization safety, post-authorization studies is unique that it combines efficacy and safety studies, so no separate. But as if you follow the NDCT 2019 guidelines, you also have to do a active post-market and surveillance studies besides the efficacy studies. There's also one more concept of interchangeability, and again, it means that when we have a biosimilar, can you use it interchangeably with a reference, because it's a long therapy. So the innovator may not be available. So can you interchange with the that of the innovator? For that, interchangeability studies are required, switching studies as well as the alternating studies. However, this has also been waived by the FDA. There is no more requirement for interchangeability if again the analytical characterization is appropriate, phase 1 study has been done, and these requirements there is a FDA guidance on, and in only the FDA required such interchangeability studies in the past. This year this has also been waived. Now this is the other.
Your time is up, please.
Yes, sir. So my time is up. There is also safety section of Dr. Neetu Sinha, so I am taking that part also. Yeah. There are only 10 minutes for this. So the pharmacovigilance certain concept traceability from biologic to, so when the multiple drugs are being used, the innovator, the biosimilar, there should be traceability, and so for that traceability, batch number, GVP requires batch number, brand name, and active substance with every prescription. So there could be traceability in terms of the, you can trace whether this adverse event has been caused by that of the biological product. Everything else is same in terms of pharmacovigilance, except that batch number becomes the 5th essential element in terms of the adverse reaction, minimal essential events. Labeling has to include safety data of both the reference and the test product. And as you can see, if the flow chart batch, if there is no batch number, you cannot process the case in terms of the biosimilars. Interchangeability can cause this causality assessment issues, because uncontrolled switching from originator biosimilar needs to be appropriately taken into account while there is a causality. So you have neutropenia after the first cycle, after the third cycle, but you had an innovator, then a biosimilar, and again a second biosimilar, then you have neutropenia. We don't know where the causality have happened. So that traceability is extremely important. Immunogenicity also adds to the complexity of the safety. So way forward is antibody drug conjugates. It will be taken care by Dr. Pankaj Thakur, and I will end my lecture here in terms of the so summarizing all of it, in biosimilars, clinical studies are mandatory in all regulations across all countries, are comparative between biosimilar and innovator. Phase 1 and phase 3s are required. Again, there's an encouragement on terms of phase 3 waivers in one product, but it will be case-to-case studies from the future, and there you will see more and more instances of phase 3 waivers. Phase 4 studies are mandatory across all countries, both post-authorization efficacy and safety studies. Phase 3 studies are there in only one indication, and then extrapolation is done. Interchangeability is a US FDA specific definition, but even this has gotten waived. Immunogenicity is required from preclinical phase 1 and phase 3 studies. Safety, naming, traceability, specific approaches to case processing, PSURs and RMPs are needed for effective pharmacovigilance, where batch number is the most important characteristic for pharmacovigilance. Thereby, it is important that the biosimilars must get developed, more and more companies should come forward, because now the science is more or less established how to develop a biosimilar, and various governments and regulations are encouraging waivers of phase 3 studies, waivers of preclinical studies. Thank you very much.
Thank you, Dr. Sinha, for a comprehensive presentation about biosimilar and biologics and role of India in developing and marketing it. So, since phase 2 is not required,
yes, sir.
So active PMS you have mentioned that
yes,
used to be done, and second thing is there will be no crossover study.
No crossover.
It can be only parallel because the long half of the molecule.
Not just that, sir. You can never wash out an anti-drug antibody. You cannot ever compare.
What are the current developments in India that will be more promising in the near future that is going on?
So right now, developments on two things are happening. The new age biosimilars, pembrolizumab, pertuzumab, the PD-L1 inhibitors, and nivolumab. Then you have the ADCs, antibody drug conjugates. Already one product is trastuzumab emtansine is in the market from Zydus, but there are at least 12 to 15 ADCs that are coming up. Brentuximab, vedotin, and then further trastuzumab, deruxtecan. Those will be the most important development. Then there is bispecific antibodies, where there are one antibody will have multiple actions. Those are the things that are the most promising, and because these biologics are already there will be biosimilars of those products. Yes. Challenges will be the cost, but again I'll tell you a story of rituximab. Rituximab was 1 lakh per vial. Today it is available at few thousands per vial. Because with the more usage and more biosimilar companies coming in, competition has become so crushing that the cost comes down drastically. And India will be the example how the biosimilar can be marketed at the most effective rates.
I think Shubhadeep has covered two talks in one session. Wonderful. Starting from what is the basic understanding of biosimilars, biologics and the biosimilars and the current regulations. Just one point is, in Indian scenario, the interchangeability, how we look at interchangeability, because if the two biosimilars of the same biologic is available at a two differential multiples, 50,000, 80,000, 1 lakh, and therefore people will think of interchangeability. Is it interchangeability must for doctor to prescribe, or it is the regulatory requirement only?
Sir, I will extrapolate from what US FDA, interchangeability definition was only available in the US FDA at one point of time, because they believed that no biosimilars can have the same efficacy and safety. But over the years it has been seen that all the biosimilars have similar efficacy and similar safety. It is not the cost, it is the safety and efficacy, and interchangeability therefore had to be proven to get a biosimilar designation in the US. That was the rule. In Europe, there is similar biologic. Now it is becoming encouraging that they are not only, there is no interchangeability rule, but also phase 3 is also getting waived. They believe that the analytical characterization, if that is done properly and highly similar biological product is produced, in that case you actually do not need any clinical studies beyond a phase 1, well done phase 1 studies. So in that case it is believed that the product is a similar biologic as we define in India. So there is no question of interchangeability even in India. Yes, cost of interchangeability in terms of usage, in terms of cost, it might be different. Yeah.
Because of time constraint,
Yeah.
we have to wind up your session.
Yes.
It's very motivating and interesting. So next speaker will be Neetu Sinha.
That I have taken.
Neetu Sinha's talk.
Okay.
I have covered that also.
You have covered that?
Yes.
Okay. Okay, Dr. Shefali Gupta.
Thank you, Dr. Shubhadeep. Can we request Dr. Shefali Gupta to please come on stage? And I request chairpersons to give a brief introduction of the speaker.
Good afternoon, everyone, and thank you, organizers, for.
Let me introduce you. Let me. I have the opportunity to introduce Dr. Sefali Gupta, who is the Director and Head of Clinical Pathology at Clientha Research. So she is a Senior Director of Lab Services in the Clientha Research, and her expertise is much wider.
Thank
you. Introduce yourself.
So basically, interestingly, I am a pathologist. So that is, I think, would be an introduction to me. After pathology, I entered, after a journey in the pathology labs, I came to Clientha Research 15 years back, taking care of their clinical labs, which are CAP and NABL accredited. But I also started large molecule bioanalysis because immunoassay is usually a stronghold of pathology. And so I've been doing large molecule bioanalysis since in the last 15 years, and we've grown beautifully. So this was, so I'm actually thankful to the organizers to have me over here, and feel genuinely honored and privileged to be speaking amongst Sir Professor Y.K. Gupta, Professor Debashish, and all of you. Thank you so much for this opportunity. And today I'll take you through this journey of biosimilar bioanalysis, which actually is a cornerstone of pharmacokinetic and pharmacodynamic equivalence. As we all know that global biologics today, the market is over 40% of the entire pharma revenue. And with the biologics patent expiring over the years, biosimilars now play a very vital role in providing accessibility of treatment to the patients. And but the success of this ecosystem does not only lie in the clinical outcomes. What is very important also is that the bioanalytical processes have great accuracy, precision, and robustness with scientific rigor. So, as we said, bioanalysis would mean proving the pharmacokinetics, the PD, which is what the drug does to the body, the immune response, because these are such large molecules. And basically, this bioanalysis is a bridge between the characterization that we do, the clinical studies results that we do. And these together form the totality of evidence and form the cornerstone of the therapeutic equivalence that we would eventually prove. So when two biosimilar candidates have an overlapping PK and PD profile, a PK profile and a PD response, that is when they're called biosimilars. Now, if you were to understand, they are obviously, as we understand, they are not biosame, which is what small molecules are. They are biosimilar. And why are they biosimilar? Because a protein structure is extremely complex. There is a primary, a secondary, a tertiary, and a quaternary structure. So the way they fold, which is very unpredictable and which cannot really be controlled. So we don't know which epitopes come in first, and therefore what the how they would, those minor structural and the glycosylation, the changes that would come up on the upper part of that would be exposed in a molecule, as to how they would influence the PK and the PD. So if we were to compare small and large molecules, the small molecules, if it was a Parle Gluco, factory, biscuit factory, a small molecule analysis would be like making Parle Gluco biscuits, whereas large molecules could be compared to making cookies. Even though you may use the same ingredients and the same processes, the outcome, the exact outcome, may look very different each time. So how do we measure biotherapeutics or large molecules? It is by ligand binding assay. Now, what does that mean actually? Ligand binding assay, what we are measuring here is not the size of the molecule, which we would ordinarily do when we are measuring small molecules. What we measure here is the binding, the ligand that is that is formed between the antigen and the antibody. So if the antigen-antibody pair that we have chosen is good, then we would have much higher values versus for the same concentration of the drug if it was a different antigen-antibody pair. So so these antibodies, the reagents that we use are very critical in case of large molecules. There are various platforms, and each platform, whenever we see the word immunoassay, it means it's a ligand binding assay, and therefore the complexity, the challenges remain. There are various platforms which are all listed here. These are the different types of ELISAs. They could be, the different that we could use in order to assess or measure the therapeutics. Now, as we said, what the regulatory looks at is the totality of evidence, including the analytical characterization, the PK/PD, the immunogenicity monitoring. ICH M10 has done a great job of harmonizing a lot of these validation requirements so that there is, a similar language that is spoken across continents for a particular validation or a particular analytical procedure. When we look at bioanalysis in the lab, there are various steps. Reagent procurement is as important, assay development and validation, sample analysis, and then is the reporting. When we start with the development, we have to ask a lot of questions as to what needs to be measured, because biomarkers, when we go, there are a lot of them. Which assay platform that we use, this depends on what are the reagents that are available, what is the sensitivity we are looking at. And therefore, the critical reagent selection, the antibodies, the calibrators, the quality controls, all these points, we'll just look at it fleetingly as we go across. What is a curve fit? What are the various requirements? What is a hook effect, etc., which remain challenges for large molecules. So antibody heterogeneity, both in the reference standard, there is a lot of lot-to-lot variation, and the lot-to-lot bridging is very important. ELISAs per se have a very narrow calibration range, and therefore we are looking for newer platforms so that we can widen the calibration range. There's a lot of matrix interference. LCMS typically has extraction procedures wherein from the matrix, from the plasma, all the interferences are removed. Whereas this is not really the case in large molecules, and matrix, lots of antibodies, non-specific antibodies can really interfere with the measurement. As we said, it's like that elephant, the story of the blind man looking at the elephant and defining it. A reference standard, which way you go and which part of it you look at defines it. And therefore, if you have one antibody and you're measuring it, you may measure one epitope, whereas when the other person has developed this assay, he's not looking at that particular epitope, and therefore the same reference standard would look very different to him, because it depends on the antibody you're using to measure that reference standard. So they poorly characterized properties. There's lot-to-lot variation as well. There's a sigmoid curve. So when we measure, it's not a linear curve which we look at in usual assays. Now, these are the various, so we have to, before we start the assay, we need to choose as to which curve that we would use in order to back calculate and report the values. If we look at this graph, we see that for the same reading on the y-axis, there can be two concentrations, because after a particular concentration, the curve starts to dip down. So you never know when you've got the reading. You have to ensure that it is not the prozone, the hook effect. We need to dilute the values and then ensure that the values were actually not high concentration values, but they were on the linear part of the calibration curve. So there is a lot-to-lot comparison, because these studies tend to be very long sometimes, and the reagent stability may be 6 months. So the next reagent, the next lot that comes in would have different properties. So we need to often, store a bulk of quality controls initially at the start of the study, then compare it with the new lot, use a correction factor if needed, if the lot is very different. As we said, absence of sample cleanup is a very important property of immunoassays, because there are a lot of non-specific antibodies, and there can be very different methods that acid dissociation, and there are lots of methods that are needed to change that. Immunogenicity assessment is 3-tiered. Now, immunogenicity can be very challenging. PK was still easier because we have a reference standard. Here, each one would have a different type of antibody. So we don't have reference standard here. If you don't have a reference standard or calibrator, to measure that gets difficult. And what we do is, a cut point is calculated, and then we report it as yes or no, presence or absence. Now it is a 3-tiered approach, which means there is a screening assay, there is a confirmatory assay. Even after the antibody is there, you don't know whether the antibody is actually attached to some part of the antigen which is not interfering with its attachment to the target receptor. So even if there is an antibody, it may not be a functional antibody. So there is the third assay, which is the neutralizing assay. And then there is titration. So the validation parameters, there are numerous of them. There is drug tolerance that needs to be done. There is selectivity. There's minimal required dilution. So there are different validation parameters. The challenges include presence of pre-existing antibody in the sample, and therefore which may interfere, which we need to be aware of when we are reporting the PK levels as well, and looking at the drug in its totality, and redefining cut points as to we need to ensure that the cut point is not too low or too high, because then we would either report false positive or false negative values. There is the NAB assay, NAB as neutralizing antibody assay. Here, US FDA would expect us to use a cell culture lab, a cell-based assay for most of the times, but it depends really upon the method of action of the drug. So the endpoints can be different. In this case, this is a case study in which we used beads for extraction. This was done on an MSD, and we see that the range increased so much, increased more than twice. The reproducibility improved, and the sensitivity had increased of the assay when we used a different platform. The risk-based approach for immunogenicity study design would depend on what we are expecting. If we are expecting a higher titer, we would go in for a longer follow-up. So the study is designed that way. The way we would interpret the immunogenicity assay data would depend upon a lot of things, whether the antibodies were present, how long were they persistent antibodies, were they transient antibodies, what is the neutralizing capacity of the antibodies, and the patient population and its properties. The quality assurance remains a very important cornerstone of these studies. If we were to look at advanced assay technologies, there is MSD. There are hybrid LC-MS assays. There are microfluidic immunoassays, which is a Gyros platform, which is also microfluidic automated immunoassay. There are AI-assisted data validation. And there's, interestingly, digital ELISAs, which is SIMA, which is a single monoclonal assay. So bioanalysis today is transforming from a confirmatory discipline to a predictive science, this predictive immunogenicity. So it is gaining in importance, so that, and it ensures both molecular sameness and therapeutic reliability. This is about an MSD. MSD is, this is how it looks. It is an electrochemiluminescent assay. It increases the sensitivity tremendously. We've seen a 10 times increased sensitivity and an increased calibration range. This is again a case study which shows from our lab, which shows how much the calibration range increased and the drug tolerance improved and the reproducibility also improved. This is a Gyros platform which increases wherein very little amount of sample is required and it is quicker, it is fully automated, increases digital traceability, improves reproducibility considerably. So if you were to compare, it again comes down to the same thing: increased precision, increased dynamic range, increased sensitivity. In India, more than 80 biosimilars have been, I'm sorry about the figures, approved till now. And India is becoming a very important global hub for this because of its alignment with the regulatory guidelines and awareness with the lot of collaborations that are coming in. Future directions include increased predictive immunogenicity using in silico methods, using computerized models, real-time data analysis, and a global harmonization of bioanalytical methods. And it is this harmonization and innovation that would improve our trust in biosimilars and biosimilar regulation. If I were to just introduce to you what we, so I come from Cliantha Research, and we, so vaccine studies is another place where we do immunogenicity. Vaccine studies, how does immunogenicity differ there? Because those are the antibodies we are looking to produce, and often there are ELISA techniques. There is Gyros platform that we may use. These are the platforms that we work at in our lab. And a huge, we've done studies, regulatory studies, submissions for PK, immunogenicity, and NAB assays for numerous MABs. Thank you so much for all your attention. Thank you so much. Neutralizing antibodies, sir. Neutralizing antibodies, sir, can be very, very challenging because it's cell-based assays. So there is variability factor increases so many folds. The assays are very long. They spread over 3 days sometimes. We are growing cells, the cell lines, whether they grow well or not. The graph that it's a sigmoid graph. So the antibodies, all these that we have mentioned, and it takes a lot of time, by the time you reach there and then then you realize, oh, it's not working. Sometimes the lot changes and then you realize that the method that you had developed is not working for this reagent lot. So you go back to square one and develop the entire method again because there's so much of lot to lot variation.
Method development and standardization.
Yeah, is a huge task in cell-based assays, sir. Thank you.
Shefali, just one question in the public interest. See, when you talk of a generic drugs and then in market you have NSQs, not of a standard quality. If you talk of a biosimilars in the market and something doesn't work, how we assess the NSQ, not of standard quality? Is there any guideline? Are there any parameters when suppose somebody complains that ये तो biosimilar काम नहीं कर रहा है, नकली है या अच्छा नहीं है, that is called as NSQ. So we have been debating that what should be the guideline, what should be the reference labs for NSQ biosimilars. Any idea about it?
So it has to do with the efficacy study only. I think we need to go back to doing, if we can do the clinical study again and see the data there as to how it behaved. And many times, sir, the antibodies can play a very important role. I think we should go deeper into immunogenicity, interpreting the immunogenicity data, and correlating it with the PK data and seeing where the difference lies or the cut points. So
maybe you can suggest some points, guidelines to the government, because we are debating this, how to decipher, because the more than 100 biosimilars have already been approved, and there are a lot of possibility that market may get complaint that this is not working. So we have to create a guideline for NSQ identification, reference labs, and so that's a very difficult thing. But since you are doing it, you can take leading role in this.
Rightly said, the clinical trial will be the answer. Agreed. But for every product, clinical trial may not.
It cannot be the answer, sir. And so there's so much of lot-to-lot variation.
Can be tested at a lab so that you can get this product is of quality or this is of not of standard quality.
And sir, what the lot that may have been approved, that was used for the clinical study, with the one that goes into the market would be different. And the lot-to-lot bridging is a very big challenge in large molecules. So that lot would be different, and there is no way to completely comment on it or understand it until you have some data with that lot.
So think about it and suggest the government of India that how we can mitigate all those issues. Thank you.
मेरा फोन नहीं है ना
ये हो गया ना पंकज ठाकुर अच्छा ये कट गया सर ये भी आपकी मर्जी ऐसे कुर्सी बोल नहीं सकता ज़्यादा so next is Pankaj Thakur. The next speaker is Dr. Pankaj Thakur. So General Manager of Hetero Labs, having vast experience of 20 years in pharmaceutical and CRO industries, and his specialized interest is clinical research, NCE development, biosimilar development, and played key role in managing clinical trial, medical affairs, regulatory compliance, contributing significantly to hetero drug development program. So, Dr. Thakur, please start.
Thank you, sir. It's my pleasure to be here. Thanks to IPSCON 2025 organizing committee. Thanks to Dr. Shubhdeep Sinha taking the the kind of industry and academia together in a conference like IPSCON. Thanks to our beloved sir, Dr. YK Gupta and Dr. Debashish. Thank you, sir, for chairing this session. I am glad to discuss about the ADCs, the new generation of biologics in this IPSCON 2025. We have already discussed and Dr. Sinha has already elaborated about the biosimilars, what biosimilars mean, and how we are progressing in terms of biosimilar developments as far as India is concerned. I will be covering today the next generation biosimilars, so-called ADCs. So we'll see the ADC paradigm, how they work, what is the mechanism of action of ADCs, and the ADC landscape. Mainly we'll focus on Kadcyla. Kadcyla is one of the ADC.
Audience may please maintain little silence. Presentation is on. Thank you.
Thank you, sir. So we'll be discussing about Kadcyla. Kadcyla is the first ADC which has been developed, and it is available in the Indian market as well. And we'll see what are the future perspectives as far as ADCs are concerned. I will try to stick to the timelines. I know that there is a cultural program after this, and after this there is one more session by one of my colleague, Dr. Soumya, on preclinical studies.
Try to truncate and don't miss the key points. So the organizers advised me to restrict you to up to 10 minutes. So we can give only 1 minute extra, 11 minutes maximum.
Sure, sir. Sure, I will try. So we are already aware that as far as the oncology treatment is concerned, we have a traditional chemotherapies, but we have certain challenges related to the chemotherapy, and mainly because of the side effects of the chemotherapy. What we have seen, that the patient is already in the miserable condition, and when we start with such a toxic chemotherapy, there are a lot of serious adverse events. So lack of specificity we have seen in terms of chemotherapy, which turns to be more toxic than the treatment, dose limiting toxicities, and narrow therapeutic windows. So these are the some challenges and critical limitations with the traditional chemotherapy. While we have ADCs, ADCs are known to be a magic bullet concept, where you have a combination of the antibody plus linker, and that is attached to a payload. So this seems to be highly effective because it directly attacks on the target, and that's why it's called magic bullet. So what are ADCs basically? ADCs are nothing but it represent a transformative class of targeted cancer therapies that combine the specificity of the monoclonal antibodies. We have seen in the earlier presentation about the monoclonal antibodies. So in this ADCs, we try to bound ADCs along with a chemotherapy class of drugs, and through this combination they are linked with a linker through the structure, and these ADCs aim to selectively deliver the chemotherapy directly to the cancer cells while minimizing damage to the healthy tissues. So this is the beauty of the ADCs. So these are the three main parts of the ADCs. The first is the monoclonal antibody, and then we have a chemical linker with which the monoclonal antibody is attached with a cytotoxic payload. So this shows that there are three parts of the ADCs as anatomy of ADC, and all these three parts are equally important. First being the monoclonal antibody from the biosimilar part. So how does these ADCs work? So it's a step-by-step guide. Basically, in the first step, it's antigen binding. ADC selectively recognize and binds to the tumor-associated antigen overexpressed on the cancer cells. Like in case of HER2 positive patients in metastatic breast cancer, there is a overexpression of the HER2. So it directly gets associated with the antigen overexpressed on the cancer cell surface through the high affinity of the antibody-antigen interaction. So this is the first step, antigen binding. Second step is the receptor. So mediated endocytosis, ADC antigen complex undergoes internalization via clarithin mediated endocytosis, forming early endosomes that mature into a late endosomes. Then third is a lysosomal payload release. In this step, the chemotherapy agent that gets released, and then the fourth is the attachment to the target cell. Instead of harming the other healthy cells in the body, it directly targets where the cancer is present, and it directly attacks there. So basically, these are the engineered targeting and control system and antibody design criteria. This we have already discussed about how it works and what are the linker technologies that has been tried. So these are few examples of the ADCs which are available. We have already discussed about Kadcyla. Kadcyla is the adotrastuzumab. Trastuzumab is already available in the market as a biosimilar. In adotrastuzumab, we have an emtansine attached to the trastuzumab, and this has been used in HER2 metastatic breast cancer patients where they have been already treated with trastuzumab and failed to the trastuzumab. After Kadcyla, we have a FAM trastuzumab deruxtecan, This is the another classical example of the ADCs where trastuzumab is attached to the deruxtecan, which is a chemotherapeutic agent. And if you see like that, we have one more sacituzumab govitecan, which is a triple negative breast cancer patient. So if you see here is a classical classification of the metastatic breast cancer, where you have a HER2 positive, then you have triple negative breast cancer. So like that, you can try for an individualized treatment for the metastatic breast cancer by using a right candidate of ADC. So this we have seen already about the antibody component trastuzumab, how it is linked to the cytotoxic agent, that is, in case of Kadcyla, it is emtansine, while in case of trastuzumab deruxtecan, it's a deruxtecan. So this is about the dual mechanism of action of the Kadcyla, where trastuzumab mediated effects, it directly attacks to the HER2 signaling inhibition, and that blocks the downstream of the pathways. And then we have a cytotoxic drug DM1, which is directly attached to the trastuzumab. So we have seen in clinical trials, one of the classical clinical trial is the EMILA clinical trial, which has proven the superiority in metastatic breast cancer after using trastuzumab emtansine over the other chemotherapeutic agent, or in fact as compared to the biosimilar trastuzumab. So in one more trial, Catherine trial, where they are changing the standard in early breast cancer, adjuvant therapy for the residual disease post neoadjuvant treatment. Here also we have seen that there is a 50% reduction in the risk of reoccurrence or in case of death. So Kadcyla has shown good results in more than 1500 patients randomized to receive either TDM1, that is a Kadcyla, or versus a trastuzumab for 14 cycles. So these are the two clinical trials which have shown excellent results of Kadcyla over trastuzumab. So if you see the Kadcyla safety profile and management, there are common adverse events which we have seen, like fatigue, gastrointestinal issues like nausea or vomiting, and so that these are the classical adverse events which has been reported with Kadcyla, and that requires a critical monitoring of the patient during the treatment phase. Advantages of Kadcyla are it's a targeted delivered system which gets directly target the HER2 cells, minimizes the systemic exposure to the other healthy cells. It has a proven efficacy and distinct toxicity profile. While the limitations are, there are resistance which has been seen in patients who has been treated earlier with trastuzumab and then with emtansine, trastuzumab emtansine. Then we have a limited CNS efficacy of this molecule, and hepatotoxicity risk has also been seen with Kadcyla. So these are the key challenges in the ADC development. We have seen that a lot of biosimilars are getting developed in India as well as in other developing countries, but there are very few ADC candidates which are in the development phase. And one of them is Kadcyla. We at Hetero also, we are in the development phase for Kadcyla. But these are the challenges in ADC development. It's a target related challenges, tumor heterogeneity, variable antigen expression within and between the tumors, antigen escape, intermediate requirements, and it's very complex for manufacturing complexity. We have seen that small molecule versus large molecule, and in ADCs you are trying to combine a biosimilar with a cytotoxic drug. So it becomes more and more complicated as far as the manufacturing of ADCs are concerned. With this, I will stop here. We have 1 minute more in case.
No, thank you. So this is a very brief and very comprehensive presentation. So ADC, antibody drug conjugate, so you get dual action, definitely it will have a higher therapeutic efficacy. I just want to ask you one question. What about the safety aspect of this? Is it safer than the two drug combination, or the ADC is considered safer than this?
ADCs are considered safer from the mechanism of action because they are not harming our healthy cells. They are directly targeting on the cancer cells. The chemotherapeutic agent is directly attached to the monoclonal antibody through a linker. So we have seen a slide on mechanism of action, how it gets attached, and then how the chemotherapeutic drug gets released, and how it directly, target to the cancer cells. So in case of traditional cancer treatment, chemotherapy treatment, we have seen lot of side effects. But in this way, the cytotoxic agent is same. While it gets attached to the monoclonal antibody, it gives an additional safety profile to this kind of, I would say, a fixed dose combination, where it attacks to the directly to the target cell with minimal loss to the other healthy cells in the body, and it gives the required therapeutic effect.
Wonderful presentation, Dr. Pankaj. Just one
Thank you,
thing,
sir.
how clinically you forecast that this is a antigen negative clone? Is it possible? Or you see only on the non-responder, then you say that this is antigen negative clone?
Yeah, so basically we have preclinical studies, where we have a next presentation from my colleague Dr. Soumya. He would be able to touch base on this. But during a clinical trial phase also, we try to do a screening before we enroll those patients in the clinical trial. So while we do screening, we try to see whether those antigens are present in that particular patient or not, or they are getting developed over course of treatment. So that comparison is still there. But we have a data available for every candidate which is available in the market, either in the Indian market or a Western market. So from that data, we know what kind of behavior of that candidate is, and how it is going to produce the antigen effect in human.
Thank you.
Thank you. Thank you, sir.
The next speaker is Dr. Soumya Raut. Where is he?
Jacket do.
She is again in the preclinical drug discovery team of Hetero Labs, Hyderabad. And she has also very long experience of 18 years in IND research and drug discovery. That is what India is lacking. Hetero is taking a very big initiative. So, Dr. Soumya Raut.
Good evening, everyone. Good evening, sir. This is working now. Good evening, everyone. So, okay, I have 14 minutes. I'll try to touch actually what are the essentials in the preclinical development of biosimilars. Most of these previous speakers, they have already covered what are the requirements. I'll not go into the details. So when I say preclinical development, it includes actually, I don't want to touch this biologics, small molecule, it's all done, covered by others. And the regulatory guidelines, whatever is there globally and right now in India, this is a snapshot when it all started. And Dr. Sinha has already covered the requirements in the clinical, non-clinical requirements for the novel biologics and the biosimilar. So we need to develop actually most of the data during the preclinical stage so that the clinical development part can be reduced.
I would request the speakers to just please stop for a minute. And my request to those who have entered this hall for gossip, please leave the hall. Please leave the hall. Those who have entered for gossip here, please leave the hall. Otherwise, we will see that you leave the hall.
This is a scientific presentation. Please maintain the decorum, please. Thank you. Yeah, please.
Yeah. Okay, when we say preclinical development, here we will be covering two things, and hopefully after the end of the presentation, we'll be able to get answers to a lot of questions that has not been answered as of now. So in the preclinical, there are two things, the structural as well as the functional characterization and similarities with the reference product and the biosimilar that is being developed. When we say the similarity, what exactly does that mean? So there should be a particular standard which you need to define from the beginning of the research and say, okay, this is the standard that I need to meet for my biologics or for my biosimilar, so that I can claim that I am one biosimilar product or I have developed one biosimilar product. So that is what we call as the critical quality parameters or targeted quality parameters. But how will we develop it? Different, as Dr. Shefali Gupta was mentioning, that lot-to-lot variability and all. Why this happens with the biologics? Because of the method that is used to manufacture a biological product. It's a living system, and in the living system there is always one variability. Whatever the precautions you take during the development, there will be a variability. So that is what leads to lot-to-lot variability. Not only the lot-to-lot variability, even if in the same lot also, when you are doing the manufacturing, if there is a difference in the temperature or pH during the process of manufacturing, that can bring the changes. The same brand name, different countries will have different parameters. I'll just give some example. Here, this is a lot-to-lot variability. Same drug, US lot, Europe lot, same brand name. So, but you have actually, I have not given the lot number, this is an arbitrary number. There will be change in the glycan part, and there will be a change in the FC node also of the product. So what, and again this acidic part, basic part, there will be a difference. But what we need to do as the developers? So that is the quality target product profile or critical quality parameters, how we can do that. So while matching the QTP or the critical quality parameters, we as developers need to bring the reference products sourcing from all the parts of the globe where the product is already approved and that is having different lifespans, beginning of the manufacturing, end of the shelf life, mid of the shelf life. Bring those products and do the testing, then establish what should be the range. Unlike the small molecules, here we cannot have a particular value. Okay, the percentage of X map to be 10 mg per ml. That is really difficult. Though we write it 10 mg per ml, but there is always a range. And we, with the help of the statisticians, we need to find out what should be the X plus or minus 10. So in normal practice, that plus or minus is normally taken as a 3 standard deviations. So you have a parameter plus or minus 3 SD. Why 3 SD? I'll not be able to answer right now because that will be a long topic that we can discuss later on. So normally that is taken so that you get a range, and when you do the structural similarity or the functional similarity of your product with the reference product, you have to ensure that your product lies within that range. Hope this answers to the question Dr. Gupta has asked to Dr. Shefali, that what can be done as the NSQ. As regulators, that needs to be defined what should be the quality parameter of a particular monoclonal antibody or peptide, and if there is any adverse event observed of one mAb or one biosimilar available in the market, that lot can be sent to a central lab to be tested to identify whether that falls within that range or not. If it is already there within that range, then yes, there is no issues in the product quality. Maybe during the shipment of the product or by use of the product, something has gone wrong. Because of that, only the safety issue has come when the patient has used it. It might be storage at the patient level, maybe at the pharmacy level, or maybe at the warehouse of the manufacturer also, that can happen. So that is what we need to define as a standard quality parameter. As Dr. Sinha has mentioned earlier in his presentation, that lot of animal studies or the toxicological studies not required, that will be defined by the expression system that is being used by the manufacturer. If there is a minor change in the expression system, the monoclonal antibody or the biosimilar that we are manufacturing, it will significantly change from the reference biologic. And also this expression system see, we can produce by using, when we say microbial, we can use the yeast, we can use any other microorganism also to develop the same peptide. That can be done with the development of the science to reduce the cost. Sometimes we make the changes in the microbial expression system, cell expression system. Like if we take MT2 cell and MT4 cell, both are actually similar in nature. So we can utilize both the cell lines to develop a similar product. But because of the change in the nature of, there is minor difference in both the cell lines, so your finished product nature might change. So for the structural similarity and functional evaluation, in the function, we may not need to do the in vivo PD studies always, until unless we find that there is some change in this amino acid sequence of the biosimilar from the reference product. It is not mandatory. Specifically, if it is a peptide having less than 100 amino acids as in the sequence, you don't need to do it, because you can easily sequence all the 100 amino acids and match with the reference product. Yes, in case of MAPS, there is high possibility that there will be presence of impurities in the process as well as in the finished product, which you may not be able to detect even if during the analytical process. So in those cases, yes, we might need to do the in vivo or the pharmacodynamic evaluation. And as it has been mentioned, structural assessment, it's pretty easy. Primary structure, specific the amino acid sequencing, the post-translational modifications that can happen during the process of manufacturing, then higher order structures, the secondary, tertiary, and quaternary. The most important is actually the protein size and heterogeneity and the aggregation that can happen with the biologics in the process of manufacturing. That needs to be identified and matched, because it will happen with the reference biologics also. Similarly, so this is the example how you should match the structural similarity when you say there is a similarity in the structure. Then comes the functional similarity. As I had mentioned earlier, we don't have to do the PD evaluation always, but there is always a requirement of the toxicity studies. Specifically, I'll skip this one. These are all functional assays to evaluate the PD, because I have left with only 4 minutes. This is how actually your PD evaluation look like. May not be 100% superimposed, but it has to be superimposed, if not 100%, most of the places. Specifically, when there is in the S curve you have the straight line, that place it should match. Then comes the important part is the toxicity studies. This is not required always. Most of the toxicity studies, the battery of toxicity studies that we do, that is not required, but we need to do a repeat dose toxicity study with comparative PK, and during the same study we should be able to define or determine what are the antidrug antibodies and neutralizing antibodies that can occur. And to determine that, the most important thing is that what is the animal that we are using for the study. So the animal that should be used, no doubt we use most of the cases rat or mice, considering that mice is the most sensitive species, and rat it is easily available and we can do it, but that should not be the right thing always. We should select those animals which are more sensitive to the drug, and the innovator has used those animals to establish the ADA and NAB as well as the PK. If we take those animals, the result what we will get for the biosimilar, it will be very, very same with the reference product. And even if during the functional assays, as I mentioned, if we are doing the PD assays, similarly as I mentioned earlier, for the structural similarity, you have to take batches from different regions, batches with different shelf lives. Even if for the PD also, we should do the same. How that will help? Once you have a range fixed, you can always negotiate with the regulators saying that, see, this range or the quality parameters we have decided on basis of batches with different lifespan, different regions. So our spec for our product is the most robust one which will meet or match with any biologics or any reference product you take from any region. That you can always negotiate with the regulators to get your product approved. So I'll summarize actually, these are all the toxicity requirements. PD, yes, it is always, it's not mandatory, but it is recommended to do it. And in that, even if in the PD studies also, we can determine the anti-drug antibody and neutralizing antibody assays also. Here also we need to determine what is the difference. We should not claim the superiority or something, but we should be able to prove non-inferiority in the PD assessment. If it is matching, yes, it's done. Repeat dose toxicity, yes, it is recommended. And during the repeat dose toxicity study itself, we can do the PK evaluation because the half-life is very long. So it will be there always in the systemic circulation. We can determine that, the PK parameters. Then specific concerns, if there is any, like local irritation and all, though it is not mandatory, if there is a difference in the products, then you should do it. And these concerns can be addressed in the same repeat dose toxicity study. So we don't have to repeat the studies several times. Then routine toxicological studies, that is not required in the preclinical assessment. That's all. So this is the key message. So biosimilar that provides additional treatment option to the patients that we have with a cost-effective manner. State-of-art techniques needs to be used, though I didn't get the time. I had mentioned actually other techniques to be used for the structural similarity determination and physiochemical properties, in vitro in vivo biological assays, PK and PD properties, and preclinical in vivo safety and toxicity. These are the things that we need to do to establish the similarity. And as I mentioned, from the beginning of the research, we need to define what is the quality attributes or what are the critical quality parameters, QTPP, that needs to be defined from the beginning itself, so that at the end of the research, at the end of the development of a biosimilar, we have a quality product which will match with all the biologics or the reference products available globally. Thank you.
Yeah, very compact presentation, and it is about how to develop a biosimilar in preclinical stages in a nutshell.
Thank you, sir.
So how far India has progressed in developing biosimilars and what are the challenges?
Yeah, no doubt. In India, we have really good scientists who can develop biosimilars similar to all the global companies they are doing. No doubt, Biocon and Hetero are the two companies who are actually leading in developing biosimilars in India. Yes, Biocon has launched its products globally as well. The major challenge what we are facing here in India is sourcing of the reference products, because the reference products are really costly, and getting those products cleared at the customs itself, even if we are ready to pay for it, getting the clearance of the customs to get the reference products takes time. Yeah, that's what actually I am directing towards him.
Help you.
So that is where actually the challenge is. And the major challenge is we are lacking in one thing. Frankly speaking, our guidelines says, okay, 3 batches of the product you take and establish. Is the 3 right number? I am really confused. Last 12, 13 years I'm working in the biologics and biosimilars. I'm really not sure whether 3 batch is right or not. So that needs to be defined in the properly in the guidelines. Maybe that will help us.
Is that the last presentation of this session? So thank you very much. And I have 2-3 things to say about this session. This is very apt session for the theme, empowering young minds to transform pharmacology for Viksit Bharat. But what I see here, transforming young minds requires much effort, and it should come from your own heart. जब आप इतने important topic को ध्यान से सुन ही नहीं रहे, तो transform क्या करोगे आप? Remember this. Today, biosimilar, it is projected that in next 5 years, the biosimilar market will be 10 times more. Number one. Similarly, figure of 10 has been quoted that the human resource in next 5 years will be 10 times more requirement in human resource. और हमारे human resource को कौन ले जाएगा? जबकि हम यहाँ पे गप्पे मार रहे हैं, इतना important session, even if you have 5% retained what has been taught today from A to Z of biosimilar, I think your job prospect would increase. Unfortunately, most of the students, young minds who are sitting here, they may not be knowing is how the biosimilars, biologics are named, what are the critical issues, what are the quality control issues, what are the manufacturing issues, how many industries are working on biosimilars. These more than 150 biosimilars have been approved in which sector, and then how to do research in biosimilars. I think अगर आपको विकसित भारत का one of the pie which is considered to be only 3 to 4% of biosimilars used today will be 75% plus of therapeutics in biosimilars in next year. That is the projection. So that is why I am saying this session was so important, so critical, but unfortunately those who did not pay attention to this are loser. I give all compliments to the organizers of this session because this was really ultimately हमारे दो ही तीन चीज जो हमें pharmaceutical industry में pharma sector में जा रही हैं, anti-cancer drugs, biologics, diabetics, and anti-infective, AMR. These are the things which are of contemporary nature. And you have to really think out of box how we can convert India at an advantageous position. If you read the articles today, and I also wrote an op-ed, India is poised to be leader in biosimilars in the globe. Even we have a potential कि हम चाइना को पीछे छोड़ सकते हैं biosimilars में, इतना हमारे पास potential है. अब वो तभी हो सकता है जब हमारे young scientists अभी से train हो जाएं how to handle biosimilars. It's not that necessary you go to industry and then learn कि biologics, biosimilars क्या होता है, उसके बाद हम इसमें करें. So your job prospects will increase if you are even sensitized to what is biosimilars issue. Maximum job आपकी जो बाद में आएंगी ना से 5 साल के बाद में, this will be in biosimilar. So I really compliment all those speakers, and I must admit that इतना material कुछ ज़्यादा था कि दिमाग के अंदर घुसना थोड़ा मुश्किल होता है. The material was very complex, exhaustive. But I think अगर इसमें से 2% भी गया, it will be very useful. So I don't want to wait between the entertainment, but I think you had enough entertainment in between session also. Personal, private entertainment कर रहे थे लोग. So thank you.
Thank you. Thank you all.
A deep dive into the complex world of biologics and biosimilars. Thank you to all our industry experts. We would now like to felicitate our experts with a token of gratitude. May I invite Dr. Shubhadeep Sinha, Dr. Soumya Raut, and Dr. Pankaj Thakur to please come on the stage. And may I request our, yeah, they are already there. Please. With heartfelt gratitude, we thank all of you. We, we thank our industry experts. Now we will felicitate our chairpersons. May I request Dr. Babul Kumar, IPS President, to please come on the stage and do the honors. Thank you, sir. Thank you all for your gracious presence and valuable participation. This concludes the scientific program for day 1. Our cultural program will shortly begin, and following the cultural presentation, all delegates are invited to the welcome dinner. Thank you so very much.
A very good evening to everyone. Very good evening. मुझे आवाज नहीं आ रही. Very good evening. Thank you for the response. So the thing is, after you can say knowledge बहुत gain कर ली since morning. Now it is the time for the refreshment. So हमने curtain थोड़ी देर के लिए किया है. Just give us 5 minutes and we would be ready to make you dance for sure. Thank you so much for your patience. Just give us 5 minutes.
हेलो हेलो।
ये बोल दो मैम ये महफिल का रंग तभी चढ़कर बोलता है जब दिल से निकला हर अल्फाज दिल को छू जाता है। आज की शाम भी कुछ ऐसी ही है, हर लम्हा अपने साथ एक नया एहसास लेकर आई है। आप बोल दो मैम।
मेरे स्पेक्स निकालने दो। कौन बोलेगा? ले में जो बोले।
कौन बोलेगा? मैं बोलूं? आप बोल के देखो।
जो हमें एक और मिली है।
ले में। ये दूसरी वाली जो मर्जी बोलती रहे बस।
उस साइड से आपको आना पड़ेगा।
बाहर नहीं जाना।
अच्छा अंदर से ही?
बिल्कुल।
बैक स्टेज।
बैक स्टेज।
ये बढ़िया। ऑन है?
ऑन है।
चलो एक और निकालो फटाफट। हाँ जो भी बस।
एक प्यारी सी शाम की मुस्कान के लिए आप सबको थोड़ा सा इंतज़ार करना है, तो उसके लिए एक शायरी मैंने लिखी है। महफिल में आज रोशनी से बिखर जाएगी, महफिल में आज रोशनी से बिखर जाएगी, हर दिल से एक नई धुन सी निकल जाएगी। बैठिए सुकून से, बैठिए सुकून से, मुस्कुरा कर ज़रा, ये शाम आपकी यादों में उतर जाएगी, ये शाम आपकी यादों में उतर जाएगी।
वाह वाह क्या बात है।
ये ले करियो टेस्ट बीट बजाइए। हेलो 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 हेलो। ठीक है।
ये बना लेंगे। ठीक है।
हेलो 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 संदीप नायक। हेलो।
एक ही चीज़ है वही आती हो, कुछ और कर दे भाई। कोई गिटार बजाएगा? हाँ गिटार तो बजा दे पीछे।
हेलो
यार आओ नीचे, आप चलो, आप नीचे चलो, आप नीचे चलो।
सुन मैं बताता हूँ वही करना है। यहाँ पे यहाँ पर दिखने में तो चाहिए भाई, यहाँ लगाना दिखने में तो चाहिए, हमें दिखने में तो है।
म्यूजिशियंस के लिए
ये वैसे से भी बोल सकते हो निकल।
गुड इवनिंग एवरीवन, आपका थोड़ा सा अटेंशन चाहती हूँ। गुड इवनिंग एवरीवन। यस, मुझे लगता है कि थोड़ा सा हम लोग पूरा दिन करके सेशंस थोड़े थक गए हैं। बहुत ही प्रोडक्टिव लेक्चर्स थे, बट थोड़ा थकान तो होती है। तो एक शायरी लिखी थी, महफिल में जब सुकून की बातें होती हैं, महफिल में जब सुकून की बातें होती है, थकी हुई रूहें भी मुस्कुराती होती है। थोड़ा सा आपका रिस्पॉन्स चाहिए मुझे। तो महफिल में जब सुकून की बातें होती हैं, थकी हुई रूहें भी मुस्कुराती होती है। आज हम सब मिलकर ऐसे ही पल बनाएंगे, आज हम सब मिलकर ऐसे ही पल बनाएंगे जहां हर याद दिल में बस जाती होती है। थैंक यू।
नीचे वाला एकदम लास्ट में, ये वाली व्हाट्सएप करो मुझे।
शायद मैं फिर से दोबारा आ गई, कोई नहीं लेकिन थैंक यू। मुझे सेशन स्टार्ट करने से पहले यहाँ से चाहिए कोई सिंगर है हमारे पास? एनी सिंगर इन द ऑडियंस? हाँ बिल्कुल, उठाओ उठाओ, हमारा माइक ऑलवेज रेडी है। आ जाओ स्टेज पे आ जाओ। Put your hands together.
जी हेलो हेलो लाइक ये गाना आपको अगर आता है तो आप लोग भी लाइक साथ में ज्वाइन कर सकते हो, ठीक है? ऐसा क्यों होता है तेरे जाने के बाद, लगता है हाथों में रह गए तेरे हाथ, तू शामिल है मेरे हंसने में रोने में, है क्या कोई कमी मेरे पागल होने में, मैनू इश्क तेरा ले डूबा, हाँ इश्क तेरा ले डूबा, हाँ इश्क तेरा ले डूबा, हाँ इश्क तेरा ले डूबा।
हेलो हेलो
हेलो हेलो हेलो हेलो हेलो।
अरे तालियां क्यों रुक गई सोहेल के लिए? ओके, सो ऑर्गेनाइजिंग कमेटी के लिए भी थोड़ा बनता है ना, तो कृतिका भी हमारी सिंगर है, उसे भी एक बार बुला लेते हैं।
हेलो।
Hello everyone, my name is Kritika and I'm from B Farm 3rd year and I'll be singing Lag Ja Gale and I would like the audience to join me as well. हमको मिली है आज ये घड़ियाँ नसीब से, जी भर के देख लीजिए हमको करीब से, फिर आपके नसीब में ये रात हो न हो, शायद फिर इस जन्म में मुलाकात हो न हो। Audience kindly join. लग जा गले के फिर ये हंसी रात हो न हो,
हेलो 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 हेलो।
शायद फिर इस जन्म में मुलाकात हो न हो। Thank you so much.
तो सिंगिंग चाहिए या शायरी चाहिए? फिर से शायरी या सिंगिंग? ओके, दोनों क्या आ रहे हैं, दोनों कर लेते हैं। तो एक लिखा था कि ये महफिल भी क्या कमाल की बनी है, ये महफिल भी क्या कमाल की बनी है, हर नज़र में आज एक चमक सी तनी है। आइए इस शाम को और खूबसूरत कर दें, आइए इस शाम को और खूबसूरत कर दे, किसी हसीन मुस्कान की जैसे शुरुआत सी हुई है। तो एक सिंगिंग और करवा लेते हैं। तो मैं अपने को एंकर, इसका नाम नहीं बताऊंगी, मैं उसे बुलाती हूँ, वो खुद ही आपके बताएगा।
तो सारे प्लीज मुझे ज्वाइन करिए। एक गाना, रेट्रो गाना तो बनता है सबके लिए। चलिए शुरू करते हैं। तो आप सब यहाँ पे सब राजेश खन्ना के तो फैन होंगे ही, कोई है नहीं? ओह माय गॉड, सारे जेंजीज खड़े हुए हैं यहाँ पे, मुझे लगा कि कोई तो होगा। तो चलिए गाना राजेश खन्ना जी का, यहाँ पे मैं गाना शुरू करता हूँ। यूं तो अकेला भी अक्सर गिर के संभल सकता हूँ मैं, तुम जो पकड़ लो हाथ मेरा दुनिया बदल सकता हूँ मैं। मांगा है तुम्हें दुनिया के लिए, दिल तुमको ही चाहे तो क्या कीजिए। ओ मेरे दिल के चैन, चहनाए मेरे दिल को दुआ कीजिए। थैंक यू एवरीबॉडी।
अभी पढ़ता तो खुल ले तो। पीछे चलो। गाना मैंने कर दो शुरू। अभी ये खुलने तो दे। हमारे तो है ना।
नमस्कार, सत श्री अकाल और आदाब। सो लेडीज एंड जेंटलमैन, तैयार हो जाइए क्योंकि IPSCON 2025 का सबसे रंगीला और सबसे धमाकेदार हिस्सा अभी शुरू होने जा रहा है। पूरा दिन हमने नॉलेज और डिस्कशन का सफ़र तय किया और अब वक्त आ गया है स्ट्रेस को लॉग आउट करने का, मूड को रिफ़्रेश करने का। आज की ये शाम आपके लिए लेकर आई है सुरों का जादू, डांस की खूबसूरती और कल्चर का वो रंग जो IPSCON को और भी खास बना देता है। इस अवसर की शुरुआत हम एक शुभ और पवित्र अंदाज में करना चाहते हैं।
हमारी परंपरा के मुताबिक किसी भी बड़े कार्यक्रम से पहले माँ सरस्वती का आशीर्वाद लेना मंगलमय माना जाता है। फॉर आवर इंटरनेशनल डेलीगेट्स, Goddess Saraswati is known as the symbol of knowledge, learning, wisdom, and creativity. The performance you are about to witness, Saraswati Vandana, is a classical dance performed to invite clarity, peace, and positive energy, setting a calm and inspiring tone for the rest of the evening. So, now we present the Saraswati Vandana with a beautiful shlok. या देवी सर्वभूतेषु बुद्धि रूपेण संस्थिता नमस्तस्यै 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 नमो नमः।
Thank you for the graceful Saraswati Vandana. This divine invocation has left both our minds and the stage feeling wonderfully blessed.
As we carry the calm and purity forward, now it's time to let music gently elevate the atmosphere. Music has a unique way of connecting us across ideas, cultures, and emotions.
वो कहते हैं ना, गीतों का जादू ही कुछ और होता है, गीतों का जादू ही कुछ और होता है। हर सुर में एक नशा, हर लफ्ज़ में एक प्यार होता है। आज की ये महफिल उन लम्हों को फिर से जी उठाए, आज की ये महफिल उन लम्हों को फिर से जी उठाए। चलिए इस शाम को सुरों से और हसीन बनाएं, इस शाम को सुरों से और हसीन बनाएं।
Now let's welcome Onkar, Raghav and Ojas as they present a soulful singing performance prepared specially for this occasion. Let's give them a warm round of applause.
Check, check, check.
Hello.
Check. Ready?
Check, check, hello.
1, 2, 3, start. तेरी याद मैनू तड़पावे, मैनू ते चैन ना आवे, मैनू जिस्म चो मेरे जानी तेरे जिस्म दी खुशबू आवे। तेरी याद मैनू तड़पावे, मैनू ते चैन ना आवे, मैनू जिस्म चो मेरे जानी तेरे जिस्म दी खुशबू आवे। मैं चाहे जागा मैं चाहे सोवां, तंग कर देने ख्याल तेरे ओ फकीरा, ओ फकीरा। मैनू ले जा तू नाल तेरे ओ फकीरा, ओ फकीरा। मैनू ले जा तू नाल तेरे, तेरे बिना कौन पुछूगा मैनू, मेरे सजना वे बाद मेरे। दुनिया दी इस भीड़ च एवें खो जांगे यारा, तेरे बिना असी पागल वागल हो जाएंगे यारा। दुनिया दी इस भीड़ च एवें खो जाएंगे यारा, तेरे बिना असी पागल वागल हो जाएंगे यारा। जे मेरे तो दूर गया तू, लैन सिवे मैं बाल मेरे ओ फकीरा, ओ फकीरा। मैनू ले जा तू नाल तेरे ओ फकीरा, ओ फकीरा। मैनू ले जा तू नाल तेरे, तेरे बिना कौन पुछूगा मैनू, मेरे सजना वे बाद मेरे। We're still not done yet.
नहीं जीना तेरे बाजो, नहीं जीना, नहीं जीना, नहीं जीना तेरे बाजो, नहीं जीना, नहीं जीना। मैं तेनू समझावा कि ना तेरे बाजो लगदा जी, मैं तेनू समझावा कि ना तेरे बाजो लगदा जी। तू की जाने प्यार मेरा, मैं करा इंतजार तेरा। तू दिल तू यो जान मेरी, मैं तेनू समझावा कि ना तेरे बिना लगदा जी। तू की जाने प्यार मेरा, मैं करा इंतजार तेरा। तू दिल तू यो जान मेरी हो। तुर पे मेरी आसा जीना मेरा है, जीना मेरा है तेरा कि मैं करा तू
सुन एतबार मेरा, मैं करा इंतजार तेरा, तू दिल तू यो जान मेरी, मैं तेनू समझावा की न तेरे बिना लगदा जी। हो And now a medley for you all. We're still not done yet. A medley for all of you present over here, our esteemed guests. So I hope you'll enjoy this segment of our song too. शाम मस्तानी मदहोश किए जाए, मुझे दूर कोई खींचे तेरी ओर लिए जाए। ये शाम मस्तानी मदहोश किए जाए, मुझे दूर कोई खींचे तेरी ओर लिए जाए। बात जब मैं करूं मुझे रोक देती है क्यों, तेरी मीठी नजर मुझे टोक देती है क्यों। तेरी हया तेरी शर्म तेरी कसम मेरे होंठ सिए जाए। ये शाम मस्तानी मदहोश किए जाए, मुझे डोर कोई खींचे तेरी ओर लिए जाए। प्यार दीवाना होता है, मस्ताना होता है, हर खुशी से हर गम से बेगाना होता है। प्यार दीवाना होता है, मस्ताना होता है, हर खुशी से हर गम से बेगाना होता है। क्षमा कहे परवाने से परे चला जा, मेरी तरह जल जाएगा यहाँ नहीं आ। क्षमा कहे परवाने से परे चला जा, मेरी तरह जल जाएगा यहाँ नहीं आ। वो नहीं सुनता उसको जल जाना होता है, हर खुशी से हर गम से बेगाना होता है। प्यार दीवाना होता है, मस्ताना होता है, हर खुशी से हर गम से बेगाना होता है। Thank you everyone. Thank you. एक और गाना नहीं करना, बहुत हो गया, बहुत अग्री हो गया।
चलिए, सिंगिंग और शायरी का दौर तो बहुत हो गया, अब आपकी थोड़ी फिल्म नॉलेज भी देखी जाए। होप आप सबको ये परफॉर्मेंस बहुत अच्छी लगी होगी। प्लीज गिव मी अ ह्यूज शाउट। थैंक यू। तो चलिए, रूल्स ये हैं कि हम दोनों आपके सामने एक मूवी का डायलॉग बोलेंगे और आपने गैस करना है। जिसको पता होगा वो हाथ खड़े कर दीजिएगा और बताना। चलिए शुरू करते हैं।
तो ये रहा आपका पहला डायलॉग। बाबू मोशाए, जिंदगी बड़ी होनी चाहिए, लंबी नहीं।
वेरी गुड मैम, आनंद, वेरी गुड। तो अगला डायलॉग, हम जहां खड़े हो जाते हैं लाइन वहीं से शुरू होती है। ओह नो नो, कालिया, यस इट इज राइट।
बड़े बड़े देशों में ऐसी छोटी छोटी बातें होती रहती हैं।
जी हाँ, डीडीएल जी। आई कैन टॉक इंग्लिश, आई कैन वॉक इंग्लिश। एनी गेसेस? नमकलाल, वेरी गुड।
डॉन को पकड़ना मुश्किल ही नहीं, नामुमकिन है।
ये तो आपने गैस कर ही लिया होगा। आज खुश तो बहुत होगे तुम। दीवार, यस मैम।
मोगैम्बो खुश हुआ। मिस्टर इंडिया इज द राइट आंसर।
पुष्पा, आई हेट टीयर्स। यस मैम।
ये हाथ मुझे दे दे ठाकुर।
मेरे पास माँ है। यस, इट्स करेक्ट।
मेरे करण अर्जुन आएंगे।
जा सिमरन जा, जी ले अपनी जिंदगी। मैं आज भी फेंके हुए पैसे नहीं उठाता।
ये बाबूराव का स्टाइल है, हेरा फेरी।
इतनी शिद्दत से मैंने तुम्हें पाने की कोशिश की है कि हर जर्रे ने मुझे तुमसे मिलाने की साजिश की है।
हेलो 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 चेक।
ओम शांति ओम। यस। एक चुटकी सिंदूर की कीमत तुम क्या जानो, मैं अपनी फेवरेट हूँ जब भी मैं।
जिंदगी में कभी किसी से इतना मत डरो कि डर ही जीना छोड़ दे। जिंदगी में कभी किसी से इतना मत डरो कि डर ही जीना छोड़ दे। काला पत्थर, काला पत्थर इज द राइट आंसर।
तारीख पे तारीख, तारीख पे तारीख मिलती रही। दामिनी, यस। ये 2.5 किलो का हाथ जब किसी में पड़ता है ना तो बंदा उठता नहीं, उठ जाता है। जब ये 2.5 किलो का हाथ किसी पे पड़ता है ना तो बंदा। इट्स दामिनी, दामिनी।
दोस्ती की है निभानी तो पड़ेगी। दोस्ती की है निभानी तो पड़ेगी। सौदागर।
तो चलिए अब इसको हम आगे एक शायरी से कंटिन्यू करते हैं। पर्दा उठेगा तो रंगों का सफर शुरू होगा। पर्दा उठेगा तो रंगों का सफर शुरू होगा। हर कला बोलेगी और संस्कृतियों का मंजर शुरू होगा। लम्हे चमकेंगे, नगमे धड़कनों से जुड़ेंगे। इस महफिल के साथ एक खूबसूरत कार्यक्रम शुरू होगा। ये कार्यक्रम सिर्फ देखना नहीं, महसूस भी करना है। ये कार्यक्रम सिर्फ देखना नहीं, महसूस भी करना है। यहाँ हर कल्चर की धड़कन सुरों के साथ भरना है। तो मुस्कुराइए, झूम जाइए और दिल से साथ निभाइए। पर्दा उठा नहीं है, उठने ही वाला है। समझ गए ना? हाँ जी, तालियों को अभी से बजाइए। प्लीज टेक अ ह्यूज राउंड ऑफ अप्लॉज।
So, ladies and gentlemen, it's time for the act that unfolds so effortlessly. You won't notice when laughter arrives and when a gentle thought finds a way to your hearts.
And truly, what's a moment of this scale without a touch of शायरी with it?
कहते हैं ना, मंच का हर किरदार एक कहानी के साथ आता है। मंच का हर किरदार एक कहानी के साथ आता है। हंसी, एहसास और सच का जहां बसाता है। आज की स्किट भी वही जादू लाए। आज की स्किट भी वही जादू लाए जो दिल को छूकर चेहरे पर मुस्कान सजाए, चेहरे पर मुस्कान सजाए।
So audience, let's sit back and let the moment unfold and welcome our talented performers with a huge round of applause.
Hello everyone. Before we start, I would like to inform that no animals were harmed in the making of this skit. इस नाटक में किसी भी जानवर को नुकसान नहीं पहुंचाया गया है। जहां जानवर डरते नहीं, वहीं से शुरू होती है जंगल बचाने की असली कहानी। एक ऐसे ही अनोखे जंगल की कहानी दिखाने आ रहे हैं आगाज डीएवी ड्रामेटिक्स के स्टूडेंट्स who are also the zonal and interzonal youth festival winners। आज जानवरों की बारी है बोलने की और हमारी बारी है समझने की। अपनी कहानी बताने के लिए ये जानवर प्रस्तुत करते हैं स्किट एनिमल पार्क, डिजाइन्ड एंड डायरेक्टेड बाय मिस्टर निशांत डोगरा।
यार आ रहा है तेरा प्यार।
Hello. So ladies and gentlemen, what an exceptional performance it was. The fineness, the timing, the chemistry, everything was absolutely outstanding.
Truly, Panchul, it was not just a skit. It felt like a beautifully crafted moment on the stage. Indeed, a cinematic elegance.
And now, as we move ahead, let's celebrate a completely different shade of talent.
Yes, mimicry it is. An art where observation meets voice and creativity meets precision. थोड़ी सी मस्ती, थोड़ा सा magic, but with a class.
So ladies and gentlemen, presenting an artist who brings character to life with effortless charm.
So please put your hands together for our mimicry maestro, Mr. Aman.
जब तक वो हमारे साथ शामिल होते हैं, हम मिमिक्री को डिफाइन करने के लिए कुछ शायरी भी तो यूज कर सकते हैं ना। तो चलिए शुरू करते हैं। नकल करना आसान नहीं, टैलेंट का गेम होता है। नकल करना आसान नहीं, टैलेंट का गेम होता है। सेम आवाज बनाना एकदम फेम होता है। मिमिक्री सिर्फ कॉपी नहीं, अंदाज का जादू होता है। मिमिक्री सिर्फ कॉपी नहीं, अंदाज का जादू होता है। दिल जीत ले वो आवाज से, वही असली हीरो होता है।
आवाज बदली, स्टाइल बदला। आवाज बदली, स्टाइल बदला। पूरा हॉल हंस पड़ता है। मिमिक्री में एक सेकंड में एक स्टार बन पड़ता है, एक स्टार बन पड़ता है।
नकल करना आसान नहीं, ये कला बड़ी फाइन होती है। नकल करना आसान नहीं, ये कला बड़ी फाइन होती है। ज़रा सा अंदाज बदला तो पूरी दुनिया सेम टू सेम बोलती है। और यहीं आगे हमारे मिमिक्री माएस्ट्रो।
प्लीज गिव अ ह्यूज राउंड ऑफ अप्लॉज।
हेलो 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 हेलो।
ओए ओए
बेस चाहिए, बेस चाहिए। हाँ। हेलो 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 हेलो। तो गाइज, मेरा नाम अखिल बलूनी है और मैं मिमिक्री आर्टिस्ट हूँ। आपके सामने एक कहानी रखूँगा अलग अलग एक्टर्स की आवाज़ में, अलग अलग चीज़ों की आवाज़ में। ठीक है, तो शुरू करते हैं।
आ गए मेरी मौत का तमाशा देखने। अरे आओ बैठो, बजाओ इंट्रो सॉन्ग। अरे बंद कर, इंट्रो है, गजल नहीं। कहाँ है मेरी पिक्चर का विलन? लाओ उसे, करो शूटिंग स्टार्ट। अम्मा बैडमैन, मुझसे बड़ा दरिंदा कौन है? मैं हूं बॉलीवुड का सबसे बड़ा विलन।
ओए 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 लाले, मुगेम्बो अभी जिंदा है
साहब। अपन 15 घंटे से कैमरा पकड़ के खड़ा है साहब। अपन को भी कोई स्टाइल वाला रोल दो ना साहब। अब आपका, दादा का, भाई का, सबका उम्मीद लेके आ रहा है साहब। अपन या तेरे को स्टाइल वाला रोल चाहिए या बाबूराव का स्टाइल है? ओए पहला टेक, दूसरा टेक, तीसरा टेक, चौथा टेक, टेक पे टेक। यहाँ पे पटवारी की तू खाटे लेके थूकनी एक भी जगह नहीं है।
अगला तुमने तो कहा था हम गरीब हैं, लेकिन मेरे दूध में केसर कहाँ से आया?
ओए ये केसर नहीं, मेरे सुबह केसरी का कमाल है। बोलो सुबह केसरी। और ये आवाज कहाँ से आ रही है? बिग बॉस चाहते हैं किसी समय सभी अभिनेता शूटिंग एरिया में एकत्रित हो जाए। स्वागत नहीं करोगे हमारा? हम आ गए हैं बिग बॉस की शूटिंग खत्म करके। लाओ हमारी स्क्रिप्ट। और ये हीरोइन का है? अरे बाबा हीरोइन। अरे नहीं बाबा, वो हीरोइन नहीं, एक्ट्रेस एक्ट्रेस। पहले से ही जान को इतना खतरा, ऊपर से आप ये सब।
अरे चिंता काय को करता है? ये देखिए, ये घोड़ा और ये मैगजीन, ये डाला इसमें और दागा और तो ट्रिगर, खेल खल्लास।
ओए सजो, ऐसे हथियार खिलौनों के बाजार में हजारों बिकते हैं, लेकिन इनको चलाने के लिए जो जिगरा चाहिए ना, वो दुनिया की किसी बाजार में नहीं बिकता। मर्द उसे लेकर पैदा होता है। और पुल्ली ना, मैं जाटा जाट डारदारी किसे तो जड़ा मर्जी होवे,
शरी पुत्र हथियारा दी गल बात करी, पहला मेरे लिए पैक बना दे। गलत हो रहा है हमारे साथ। हम मिर्ज़ापुर में कट्टों का व्यापार छोड़ के बम्बई शूटिंग करने आए, लेकिन हमें वैनिटी नहीं दी गई। हमें आज ही अपने लिए वैनिटी चाहिए। यदि हमको शाम को वैनिटी ना मिली, मुन्ना कार्रवाई करो।
कोई सी करते त्रिपाठी सर, क्या बताएं सर, समय समय की बात है। हमारा शो इंडियाज गॉट टैलेंट, उस पर भी ऐसी कार्रवाई सर, शो ही बैन कर दिया। क्या बताएं, निर्देशक ने हर अभिनेता को जो काम था सौंपा। अरे क्या कर रहा है, समय निकल रहा है, जल्दी बोल। समझे नहीं हो ना, समझ के सुनो। निर्देशक ने हर अभिनेता को जो काम था सौंपा, हर अभिनेता ने उस काम की माचिस जला के रख दी।
हाँ बुढ़ो लोग, बम्बई का किंग है की जय कौन? जय की दादा। हाँ रणबीर मेरा बच्चा है बिड़ू, इधर आ। देखो पिक्चर चाहिए, एक्टिंग दिखा और पिक्चर ले जा। हाँ ठीक है दादा, मैं आपको एक्टिंग दिखा दूंगा। आपको कुछ नहीं करना है दादा, आपको बस बैठना है, बोलना है दादा दादा दादा, और मैं आपकी एक्टिंग करूंगा। शिद्दत से करना दादा, मेरा बस एक ही मौका है। हेलो धर्मा प्रोडक्शन, हेलो जौहर, ये पिक्चर से रणबीर को निकाल, टाइगर को डाल, मेरा बच्चा है बिड़ू। सुनाई दे रहा है, बहरा नहीं हूं मैं।
जानी, हम तुम्हें पिक्चर देंगे और जरूर देंगे, लेकिन तब जब पिक्चर हमारी होगी, डायरेक्टर हमारा होगा और प्रोडक्शन हाउस भी हमारा होगा। मेरे प्यारे भाई और बहनों, पिक्चर तो खत्म हो गई, लेकिन एक कमी है, गाना नहीं है। तो गाओ मेरे साथ, मेक सम नॉइज फॉर देसी बॉयज, दी बॉयज, दी बॉयज। बहुत अच्छा है। ओए पापा, ओए पापा, किरण,
नमस्कार नमस्कार देवस लोग, आने में थोड़ी देरी हो गई, क्षमा चाहेंगे। एक क्षण लेता आपसे। हाँ, समय समाप्ति की घोषणा।
मुगेम्बो खुश हुआ।
Impersonations always remind us how powerful expressions and voices can be. Speaking of voices, let's now shift from humor to the vibrant pulse of Bollywood.
बॉलीवुड भारतीय संस्कृति की खूबसूरती और उत्साह दोनों को साथ लेकर चलता है।
बॉलीवुड डांस हमेशा से अपने एक्सप्रेशंस, रिदम और लाइवलीनेस के लिए जाना जाता है।
Performances like these add a unique charm to IPSCON, reminding us that science, knowledge and culture सब एक साथ सेलिब्रेट हो सकता है।
रोशनियों के इस मंच पर एक नई कहानी सजने वाली है कि रोशनियों के इस मंच पर एक नई कहानी सजने वाली है। सुरों की धड़कनों पर जिंदगी फिर से जगने वाली है।
ताल से ताल मिलाकर हर कदम एक जज्बा दिखाएगा, ताल से ताल मिलाकर हर कदम एक जज्बा दिखाएगा। बॉलीवुड के रंगों में डूबा आज का ये पल सबको याद आएगा, सबको याद आएगा।
So let's acknowledge their hard work and dedication with a huge round of applause.
तुमने कभी किसी से प्यार किया? कभी किसी को दिल दिया? मैंने भी दिया। ला 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 ला। ये मेरी उम्र के नौजवानों, दिल न लगाना प्यार करके चैन खोया नींद खोई। अरे झूठ तो कहते नहीं है लोग कोई। तो गाओ हो शांति शांति शांति।
ओ जाने जाना ढूंढे तुझे दीवाना, सपनों में रोज आए आ जिंदगी में आना। ओ जाने जाना ढूंढे तुझे दीवाना, सपनों में रोज आए आ जिंदगी में आना सनम।
एक लड़की थी दीवानी सी, मुझसे पूछा करती थी प्यार कैसे होता है, ये प्यार कैसे होता है। और मैं सिर्फ यही कह पाता था।
आंखें खुली हो या हो बंद, दीदार उनका होता है। कैसे कहूँ मैं ओ यारा ये प्यार कैसे होता है।
हुआ छोकरा जवारे
करता है गलियों और चौबारों में, फेंका भागी करता फिरे तू तो अपने यारों में।
फेंका भागी कुछ नहीं सच बात जो बयां की, दहाड़ है जवां की मर्दानगी मस्तानगी। अब तू भी मान ले नैनों के जाम दे, ओ आजा रे आजा रे आजा रे आजा रे आजा। हुआ छोकरा जवारे जवारे जवारे, हुआ छोकरा जवारे, हुआ छोकरा जवारे।
काले कटोरे सुरमा बटोरे रख दे छिछोरे बड़े हाय फाय। दिल पे कराती सट चल जाती और दिल गुलाटी पूछे वाय वाय। चाय में डूबा वे सिकुट हो गया।
Such a hello. Such a refreshing and beautifully synchronized performance. हमारे परफॉर्मर्स ने बॉलीवुड के हर स्टेप को इतनी एलिगेंस से पेश किया कि स्टेज खुद चमक उठा।
जी बिल्कुल, जिस अंदाज से इन्होंने इस मंच को सजाया, हर मुस्कान और हर कदम ने दिल जीत लिया। और ऐसी कला को देखकर एक बात कहनी तो ज़रूर बनती है, ज़रा ज़ोर से तालियां बजाइए क्योंकि ये हुनर लाजवाब है।
पंचुल, लेकिन फिर भी कुछ तो मिसिंग है ना? कुछ मिसिंग लग रहा है कि नहीं लग रहा है? चलिए, तो एक शायरी थी, आज सुबह से आप शाम से मेरी 2-2 शायरियाँ सुन चुके हैं, तो एक और बनती है। एक क्वेश्चन है आप लोगों से, थोड़ा सा टेंशन चाहती है, थोड़ा सा। एक क्वेश्चन है आप सबसे, कह दो जरा वो क्या है, कह दो जरा वो क्या है जो हाथों से निकलती है पर दिल पे जाके लगती है, जिससे मंच का हर कोना जगमगा उठता है। समझ गए क्या? आवाज नहीं सुनाई दी मुझे, लेकिन चलिए, तो अगली परफॉर्मेंस हमारे 2 रंगीले राज्यों का एक खूबसूरत संगम है। अगली परफॉर्मेंस हमारे 2 रंगीले राज्यों का एक खूबसूरत संगम लेकर आ रही है। हिमाचल के नाटी की कोमलता और हरियाणा के लोकगीत का धाकड़ अंदाज, और आज ये दोनों संस्कृतियां मिलकर एक खूबसूरत कल्चरल जुगलबंदी पेश करने वाली है।
जी हाँ, बेसिकली इमेजिन करो आप हिमाचल में घूम रहे हो और आपको कोई बोले, ओ भाई धीरे नचना, ओवा पतली है। और हरियाणा वाले तो हमेशा यही बोलेंगे, रे छोरे हम तो जोर ते नाचेंगे।
बिल्कुल, ये परफॉर्मेंस केवल एक नृत्य नहीं बल्कि 2 राज्यों की परंपरा, ऊर्जा और एक एकता का प्रतिबिंब है।
And now, ladies and gentlemen, with great pleasure, I invite our talented performers to the stage and please join us in welcoming the team with a huge round of applause.
हो जाए फिर से धमाका, क्यों नहीं शर्मा जी।
बोलो बस कहे दिलो रे मेरे प्यारी है, तू तो बस कहे दिलो रे मेरे प्यारी है।
बोलो शौर्य तू आया करे मनोरी के पोरे, और तू समझिया तू मेरी मजबूरी, वो भी करे दीवाना होता है, मुस्काना होता है, हर खुशी और हर गम से बेगाना होता है।
जब तेरे दिल का तार मेरे दिल से मिलेगा, जब तेरे दिल का तार मेरे दिल से मिलेगा, किन्नौर तो छोड़ो सिर मोर हिलेगा, किन्नौर तो छोड़ो सिर मोर हिलेगा।
काली काली या कुटी दा बटने, काली काली या कुटी दा बटने, चौपेला है कचड़ो, पीछे सॉरी गोदा मेरी ये बटने, लाखों लाभ काला बदड़ो, पीछे सॉरी गोदा मेरी ये बटने, लाखों लाभ काला बदड़ो। देखी तेरी गुल्ले चटी नामे गुल्ले, ये देखी गुल्ले चटी चंदी गुल्ले, देखी तेरी गुल्ले चटी नामे गुल्ले, ये देखी गुल्ले चटी चंदी खेलना तेरी तू दूरी है ठंडे पानी रे नाला लो ठंडे पानी रे नाला सूरी है ठंडे पानी रे नाला लो
न्यारे सुन ले उमर जानी मैं तेरे कर दूं वारे न्यारे सुन ले उमर जानी मैं रैपन क्या बंदड़ी चाल पावली मारी डाली मैं रैपन क्या बंदड़ी चाल पावली मारी डाली मैं
क्या कामाली ते हो क्या तू दिख जाला हो जागा क्या कामाली ते हो क्या तू दिख जाला हो जागा मैं पुगले बरगी तोली रंग मेरा काला हो जागा मैं पुगले बरगी तोली रंग मेरा काला हो जागा
क्यों खड़ी खड़ी तू हल्लर गोरा चाल कसूती चाले क्यों खड़ी खड़ी तू हल्लर गोरा चाल कसूती चाले तू चाल कसूती चाले आज चाल कसूती चाले रे क्यों खड़ी खड़ी तू हल्लर गोरा चाल कसूती चाले क्यों खड़ी खड़ी तू हल्लर रे आज चाल कसूती चाले
wasn't Wasn't that absolutely spectacular? This fusion blended so seamlessly that it felt like the stage itself came alive.
बिल्कुल, क्या परफॉर्मेंस थी। हर कदम हर मुस्कान ने तो दिल ही जीत लिया। इनको देखकर ना मेरा मन झूम उठा।
तो ऐसे ही सारे अपने दिलों को थाम लीजिए क्योंकि कुछ परफॉर्मेंसेस अभी बाकी है मेरे दोस्त। And now it's time for the act we have all been waiting for, where effort is optional but style is compulsory. Yes, the lazy dance, where the boys prove that swag can sometimes work harder than the dancer himself. They won't break a sweat, but they will break the stage with their sheer attitude.
True, these boys have mastered that rare art where every relaxed steps looks like a trend. Every move is easy, breezy, and somehow unforgettable. But hold on a second. Panchul, मैं देख रही हूँ that you are going to join them. But sorry, you are not allowed. So please come back.
But someday I will. So ladies and gentlemen, brace yourselves for pure effortless brilliance. A big round of applause for Lazy Dance.
आगे पीछे डोलते हो भंवरों की तरह, क्यों देखते हो मुझको यूं बेसब्रों की तरह? क्या मेरे दीवाने हो?
नहीं नहीं।
क्या कोई परवाने हो?
नहीं नहीं।
क्या मेरे दीवाने हो? क्या कोई परवाने हो? काम क्या है मुझसे इतना कह दो जी जरा।
मेरा दिल न तोड़ो, मेरा दिल न तोड़ो, रूठ के न जाओ मेरी जान, पास मेरे आओ मेरी जान। मैं अंगूठा छाप पढ़ना और लिखना जानू ना।
इसका दिल न तोड़ो।
किसी डिस्को में जाए, किसी होटल में खाए, कोई देख लेना हमें यहाँ कहीं घूम के आए हम। चलो इश्क लड़ाए, चलो इश्क लड़ाए, चलो इश्क लड़ाए सनम।
गुनगुनाती है ये हवाएं, हाँ, रिमझिम 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 सन 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 हवा, टिप 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 बूंदे गुर्राते बिजलियाँ।
भीगी भीगी साड़ी में यूं ठुमके लगाती तू, जैसा फिल्मों में होता है हो रहा है हूबहू।
आई 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 डूबी 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 पंपारा, डूबी डूबी परापा। सोने सोने पटोले लखा, सोने सोने पटोले, ए तक दिया रेंदिया खा, ए तक दिया रेंदिया। तेरे हुस्न दी कोने 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 दी, कोने कोने दी। ओ बेबी डॉल में सोने दी, ओ बेबी डॉल में सोने दी, ओ बेबी डॉल में सोने दी, ओ बेबी डॉल में सोने दी। ये दुनिया पित्तल दी, ये दुनिया पित्तल दी, ये दुनिया पित्तल दी। ओ बेबी डॉल में सोने दी, ओ बेबी डॉल में सोने दी, ओ बेबी डॉल में सोने दी, ओ बेबी डॉल में सोने दी।
घूमे खातिर गाड़ी हीरो होंडा खोजेली, अरे घूमे खातिर गाड़ी हीरो होंडा खोजेली। जब से चढ़ल बा जवानी मोछे मुंडा खोजेली, जब से चढ़ल बा जवानी मोछे मुंडा खोजेली।
अठारह बरस की कवारी कली थी, घूंघट में मुखड़ा छुपा के चली थी। 18 बरस की कवारी कली थी, घूंघट में मुखड़ा छुपा के चली थी। हंसी गोरी चले के खेत में, कोई चोरी चले के खेत में।
तुम क्या अपने आप को मुगले आजम हम लोग का अनारकली समझता है बे? कितना नचा रहा है।
रंगीला रंगीला देश मेरा रंगीला, देश रंगीला रंगीला देश मेरा रंगीला।
kindly maintain the decorum.
अरे मत ऐसे करो ना, मैंने सबको पहले ही बोला था। क्या चीज़? Guys, kindly maintain the decorum. ਉੱਚੀਆਂ ਲੰਮੀਆਂ ਲਾਲ ਖਜੂਰਾਂ, ਉੱਚੀਆਂ ਲੰਮੀਆਂ ਲਾਲ ਖਜੂਰਾਂ, ਪੱਤਰ ਜਿਨ੍ਹਾਂ ਦੇ ਸਾਵੇ। ਉੱਚੀਆਂ ਲੰਮੀਆਂ ਲਾਲ ਖਜੂਰਾਂ, ਪੱਤਰ ਜਿਨ੍ਹਾਂ ਦੇ ਸਾਵੇ। ਜਿਸ ਦਮ ਦੇ ਨਾਲ ਸਾਂਝ ਹੈ ਸਾਡੀ, ਤੇ ਸਾਨੂੰ ਉਹ ਦਮ ਨਜ਼ਰ ਨਾ ਆਵੇ। ਗਲੀਆਂ ਸੁੰਨੀਆਂ ਹੋ ਜਾਣ ਦਿਸੇਂਦੀ, ਗਲੀਆਂ ਸੁੰਨੀਆਂ ਹੋ ਜਾਣ ਦਿਸੇਂਦੀ, ਤੇ ਸਾਨੂੰ ਵਿਹੜਾ ਵੱਢ ਵੱਢ ਖਾਵੇ। यार फरीद उत्थे की वसना जिथे यार नज़र ना आवे। यार फरीद उत्थे की वसना जिथे यार नज़र ना आवे।
हेलो।
इसे नाल स्वागत करते हैं विनर भंगड़ा टीम ऑफ इंटरजोनल यूथ एंड हेरिटेज फेस्टिवल 2025 फ्रॉम गोस्वामी गणेश दत्ता सनातन धर्म कॉलेज पंजाब यूनिवर्सिटी चंडीगढ़। जोरदार तालियां नाल स्वागत करो साडी भंगड़ा टीम का।
हेलो हेलो। हेलो। हेलो हेलो हेलो। हेलो 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 हेलो। हेलो 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 हेलो। हो 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 हेलो 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 हेलो। माइक चेक। हेलो 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 हेलो। हेलो हेलो हेलो।
बोले ईसो निहाल। सोने देश पंजाब मेरे दी की मैं सिफत सुनावा। वगदे पंज दरिया ने इत्थे नाले मौज बहारा। जोर पट्टा दा पैंदा पंगड़ा नचदे वांग बहारा। जोर पट्टा ते पाउंदे पंगड़ा जानदा ए जग सारा। हो मैनू जानो लगे प्यारा। पंजाब दा मैनू अणख प्यारी। अणख मेरी नू जाणदी ए दुनिया सारी। जोर जवानी डोलिया विच ठाठा मारे। सोने देश पंजाब तो मैं जावा वारे। सोने देश पंजाब तो मैं जावा वारे। सोने देश पंजाब तो मैं जावा वारे। खत्ता विच वेख सोहणीए नी अज किंज खड़ी के। मुंडियां ते चढ़दी जवानी वेख के नी तेरा दिल तड़के। सप साडे खत्ता विच वेख सोहणीए नी अज किंज खड़ी के। मुंडियां ते चढ़दी जवानी वेख के नी तेरा दिल तड़के। मुच्छां कुंडियां दे नाल चेहरे तकदे भी लाली ठाठा मारदी। ढोल दे डगे दे आके वेख सोहणीए जवानी नच्चे यार दी। ढोल दे डगे दे आके वेख सोहणीए जवानी नच्चे यार दी। ढोल दे डगे दे आके वेख सोहणीए जवानी नच्चे यार दी। ढोल वज्या जदों मित्रो आ गए गभरू कट्ठे हो के। खूंडे 7-7 फुट दे ला लिया दिल दे जड़दे कोके। मारन ललकारे बई हो मारन ललकारे बई पट्टां दा जोर है अज वखाउणा। बब्बा ते नच नच के पंगड़ा अज मुंडियां ने पाउणा। बब्बा ते नच नच के पंगड़ा अज मुंडियां ने पाउणा। ओ भाई खिच के जवाना। हो इत्थे तक इत्थे झूम 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 राजा पाउंदे सोने गभरू। लगे जो पहला पाउंदा मोर मेरी ये खानने गे चढ़िया जवानी वाला जोर। मेरी ये खानने गे चढ़िया जवानी वाला जोर। जोर न चलदा बलिए साडे दिलां ते। जोर न चलदा बलिए साडे दिलां ते। दिल ना तू देवी साडा तोड़। सोहणीए गे टुटिया नू लगदे नागी बो। आजा
जनाना मैनू पिंड दियां नारां दा सत भाइयां दा भाई नहीं मैं पुत सरदारां दा रूप तेरे ने करता मैनू इश्क दा रोगी नी भेस वटालिया जटिए ते जट बन गया जोगी नी तेरे पिछे फिरदा नी मैं मारा मारा नी तेरे करके जट ने छड्डिया तख्त गुजारा नी सारा पिंड पुछदा फिरे हो तेरी जेड़े गभरू दे नाल यारी कजले दी तार कढ के मुंडा पड़ सुटिया पटवारी मेरी रंगली चरखी हो अज तंद तेरेड़े कि तो मार रांझिया तू रंगपुर गेड़े ओ चल भी खिंच के आ जा गभरू पुत पंजाब दे जद जमन मावा गज गज चौड़ियां छातियां की सिफत सुनावा सूरज वांगरा चेहरे ते पैंदे लिशकारे मेले विच वजदा ढोल ते वजदे ललकारे मेले विच वजदा ढोल ते वजदे ललकारे सो थैंक यू जी ACSD कॉलेज चंडीगढ़ सो मेरी सारे नूं रिक्वेस्ट है जी जिन्हां ने इंजॉय करना भंगड़ा पा के उस स्टेज दे कोल आके इंजॉय कर सकते हैं जी ठीक है जी आ जाओ जिन्हां ने इंजॉय करना
हाले 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 हाले
हेलो 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 हाय नी तेरे पैर दी झांझर पुकारे रांझण रांझण हाय नी तेरे पैर दी झांझर पुकारे रांझण रांझण हो मुंडियां नू नच लैण दे सोहणीए अजे ना जा तू अखियां नू रज लैण दे सोहणीए अजे ना जा
मोढे तो तिलक दा जावे सतारा वाल खावे दुपट्टा तेरा सत रंग दा सोहणीए दुपट्टा तेरा सत रंग दा सोहणीए दुपट्टा तेरा सत रंग दा मुंडियां नू बड़ा तड़ पावे ओ सीने अग लावे दुपट्टा तेरा सत रंग दा सोहणीए दुपट्टा तेरा सत रंग दा मैं किते विच वड़ी किते विच लाती सी मैं बोलियां दी चढ़ी
संग दी संगौंदी नी मैं गिद्दे विच वड़ी गिद्दे विच लाती नी मैं बोलियां दी चढ़ी
आ गई मस्ती ते लगी फिर सार लोकी कहंदे बस कर बस कर बस कर बस कर गिद्दे विच आ जे ना पचाल लोकी कहंदे बस कर
हेलो
खिच के
हेलो
हो जेड़ी नचदी गिद्दे च बड़ी हो जेड़ी नचदी गिद्दे च बड़ी जचदी गिद्दे च ओ जेड़ी नचदी गिद्दे च बड़ी जचदी गिद्दे च जेड़े आउंदे उत्ते आया कहरा उस नूं बुलाओ नी मैं हो गया शराबी मैनू होर ना बुलाओ नी मैं हो गया शराबी मैनू होर ना बुलाओ वे मैं हो गया शराबी
हो कदे हूं करके कदे हाँ करके
कदे हूं करके कदे हाँ करके गेड़ा दे दे नी मुटियारे लम्मी बाह करके गेड़ा दे दे नी मुटियारे लम्मी ओ ना मैं हूं करनी वे ना मैं हाँ करनी ना मैं हूं करनी ना मैं हाँ करनी गेड़ा दे दूंगी पर लम्मी नहीं बाह करनी गेड़ा दे दूंगी पर लम्मी नहीं बाह करनी गेड़ा दे दूंगी पर लम्मी नहीं आउण नेरियां नी जान नेरियां आउण नेरियां नी जान नेरियां नी बिल्लो बोतलां शराब दियां अखां तेरियां बिल्लो बोतलां शराब दियां अखां तेरियां नचो 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 रुते नचने दी आई आ नचो 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 रुते नचने दी आई आ मार मार अड्डी इत्थे धरती हलाई आ मार मार अड्डी इत्थे धरती हलाई आ नचो 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 रुते नचने दी आई आ नचो 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 रते नचने दी ओ मैं निकला ओ गड्डी लेके
कॉलेज वाले जीटी रोड तो किन्ने राह निकले। सर एक सेकंड सॉरी सिर्फ 2 मिनट लूँगा। मैं भी इस पंजाब यूनिवर्सिटी का स्टूडेंट रहा। मेरा नाम गैरी गिल .official मेरी इंस्टा ID है। तो मैं इस यूनिवर्सिटी ਦੇ ਵਿੱਚ पढ़ के गया है, पास आउट होया है। सो मेरा एक गाना बहुत करीब सीगा ते ਉਹਦੇ मैं 4 बोल के जाऊँगा। उस लैक्चर हाल दे लास्ट बेंच ते मेरा ना खुणिया। हाँ उस लैक्चर हाल दे लास्ट बेंच ते मेरा ना खुणिया।